In this video, we're going to discuss questions based on set theory as well as an introduction to functions. So if you are new to these topics, this is your video. So I've got all the questions that you need to know under set theory. So the first question here reads, given that U, that is the universal set, has got elements starting from -2 all the way up to 20. Then it has got subsets. So subset X is saying even numbers in the universal set. Then Y is saying prime numbers in the universal set. Z is saying whole numbers in the universal set. Then B has got natural numbers less than 19. Then C has got integers starting from -2 all the way up to 17 for the universal set. So the question is saying list the elements and the cardinality of the following sets. So before we start answering this question, let's first come up with the actual elements of these subsets which we have. So let's start with set X. So set X is saying even numbers in the universal set. So what is an even number? So an even number, this is a number which is divisible by 2. A number which is divisible by 2 and it does not leave the remainder. So it includes both positive and negative numbers. So from this universal set, even numbers is going to be numbers starting from -2. Next is going to be 0 is an even number. Next is going to be 0. Then we have 2, then 4, 6, 8, 10, 12, 14, 16, then 18. The last one is going to be 20. Because the universal set ends on 20. So this is going to be set X. Then we also have got set Y. So set Y, we are saying set Y has got prime numbers in the universal set. So what is a prime number? So a prime number, this is a positive integer which is divisible by 1 and itself only. So it's divisible by 1 and itself only, but 1 is not included. So elements of set Y, they are going to be starting from 2, then 3, 5, 7, 11, 13, 17, and 19. So a number which is divisible by 1 and itself only, that is a prime number, and it has to be a positive number for that case. Then we also have got set Z. So Z, we are saying that Z has got whole numbers of the universal set. So what are whole numbers? So whole numbers start from 0, 0, 1, 2, 3, up to wherever you can end. So Z is going to be 0, 1, 2, then all the way up to 20. So every number starting from 0, that is a whole number. Then we also have got set B. So B is saying X is a member of natural numbers, but less than 19. So 19 is not included. So what are natural numbers? So natural numbers, these are counting numbers, positive counting numbers. So that is set B will be equal to, so positive counting numbers, so 1, then 2, 3, all the way up to 20. These are going to be natural numbers. So that will be set B. No, so not up to 20 because we are saying less than 19. So all the way up to 18. Because 19 is not included in the set. Because we are using the symbol less than. If it was less than or equal to, we are going to include 19 as well. So that will be B. Then what of C? So C, we are saying that X is a member of integers. So integers, these are whole numbers, both positive and negative. So in this case, we have got the universal set starts from -1 up to 20. So Z is saying, or set C is saying, starting from -2 all the way up to 17. So it's going to be every member, every element starting from -2, -1, 0, all the way up to 17 is included now. So all the way up to 17. So this is these are the sets which we have. So now that we have listed the sets, we can answer these questions. We can answer these questions. So remember that the question is list the elements under the cardinality of the following set. So cardinality simply means the number of elements in that set, the total number of elements in the set. So it's given by the formula, which is modulus of A equal to n, where n is the total number of elements in that particular set. So this one only applies if the set is finity, that is, the set is ending. It does not apply to infinity. So if the set is infinity, you also apply a different formula. But what we have here, all these affinities, because they end, you can see that the inverse set is ending at 20 early, starting from -2. So we're going to apply that formula to calculate for the number of elements for each and every set. So let's start with the first set, which is saying x union y. So x union y. So union simply means add. So that is add the element in x as well as in y. So what are we going to get? So if we add x, so x has got elements starting from -2. Okay, this has got even numbers. Then y has got prime numbers. So if we add these, what are we going to get? So we're going to have, so this is going to be equal to, so the element that we're going to have, just add the elements in x as well as in y. So the element which is found both in x and y, you just list it once. A good example can be, do we have an element like 2? So 2 is common in x as well as y. So in short, this set is going to be starting from -2. Next we are going to have 0, then 2, 3, 4, 5, 6, all the way. So all the way up to 20. So this is going to be set. This is going to be x union y. So just add the elements in x as well as in y. That is what union means. Simply add. Then we go to the next question. So we have x intersection y, complement. So complement simply means elements which are not found in that set. So elements which are not found in that set. So we can start by listing the elements which are found in x and y. So we have set x here and set y. Let's list the elements which are found both in x as well as in y. So we are going to have, so we are saying that x intersection y, you start by listing this. So x intersection y, elements which are common in these two sets. So we have 2 here and 2 there. What else? Only 2 is common in these sets. So x intersection y simply is 2. So now when we say complement, so now we are saying elements which are not found in x intersection y. So x intersection y, we just have 2. So what is going to be x intersection y? Complement, element which are not found in x intersection y. So this is going to be every element which remains in x as well as y, excluding the element which is found both in x and y. So we're just going to exclude 2, but everything else will be included in x intersection y. These elements are in x as well as y, but they are not in both of these two sets. So that is going to be elements -2, then 0, 3, 4, 5, so on up to 20. So that is going to be the answer to x intersection y complement. Simply elements which are not found in x as well as y. So that will be the answer to question 2. Okay, so there's one thing which we forgot, the cardinality. So for each and every set, you have to state the cardinality. So you just have to count how many elements are you going to have, how many numbers elements are you going to have in that particular set. So for this one, we're going to say cardinality, which is given by this, equal to n. Then we're going to say cardinality will be equal to, so how many elements are we going to have? So 0, In short, just count all the elements which we're going to have here. So we can count 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is going to be equal to 18. It means you would have answered that question or that part. So you have answered both, listing the elements as well as stating the cardinality. Then let's deal with this question, which is question 3. So we have x intersection open bracket y z. So this symbol simply means the difference of the set. So when we say y z, we simply means y minus z. So elements which are found in x, or elements which are found in y, but they are not found in z. That is what that means. That's why you can also write it like this. But again, in mathematics, when two sets are subtracting, it simply means this is the same as y intersection z complement. This simply means that elements which are found in y, but they are not found in z. That's what it means. So when you see this symbol, it simply means difference of sets. So subtract elements which are found in the set which is coming first, but not in the set which is coming second. So that's what it means. So let's answer this question. So we are saying we have elements which are found in x. So we already have x. X is this one here. So we are going to keep that, but let's first find this. So we have y, this z. So we are saying that this is the difference of the set. So y minus z. So elements which are found in y but they are not found in z. So we have y here and z is there. So which elements are found in y but they are not in z? So let's check out. So z has got whole numbers 0 all the way up to 20. So which elements are not found in z? So we're going to say this will be equal to open bracket. So elements which are in y but not in z. So we have 2 is in y but not in z. No, it's there. Then 3 is also in z. 5, 7, 11, 13. So this simply means it's going to be an empty set. We don't have elements which are in y but not in z. So all the elements which are in y, they are also in z. So that means it's going to be an empty set. So empty set is denoted by that. So that is the symbol for empty set. So which means that here now what we have is we are saying this such that is equal to empty set. So we are saying that now let's intersect this with x. So x intersect empty set. What are we going to have? Which elements are common in x as well as in an empty set? So we can't have common elements we can't have elements which are common in the given set and the set which you have nothing. So this is also going to be an empty set. So this will be equal to an empty set. So this is going to be the answer to part 3 there. So if you are to state the cardinality here, so we're going to say cardinality will be equal to 0 because we don't have any elements here in this set. So that's what it means. So having understood that, you can answer the remaining questions here. So when we say B union C will be the same as the first part, which was saying X union Y. Simply add elements in B as well as in C. Then that's your answer. Then Z union C complement. So here we are saying combine the elements in Z and U. Then the elements which are not found in Z and U, but they are in the universal set, that is going to be your answer. So if we combine Z and U, and C, what are we going to have? So we have Z is here, which are whole numbers, and where is C? C is there. So in short, if you look at Z and C, if you combine Z and C, you are going to get the universal set. So you are going to get the universal set. So now we are saying elements which are not found in these two when you combine. What are you going to have? So you are going to have nothing. So that is also going to be an empty set. That simply means add these two sets. When you add elements which are not found in these two sets, but they're in the universal set. So we are saying when you add Z and C, you are going to get back the universal set. So the universal, no. Are we going to get back the universal? Yes, because C goes all the way up to 20. Then Z goes all the way up to 20, whereas C starts as low as -2. So if we add these two, we're going to get the universal set. So simply means that is going to be an empty set as well. So that is a question 5. Then question 6 is saying X complement union. So this one we have to simplify first before you answer. So we are saying C complement union B, then complement outside. So when you see this, it simply means complement, but you can also write it as that. They also mean the same. So when you have got a complement and a complement inside, you are allowed to multiply this complement outside and that inside. So a complement and a complement, they cancel. It's more like you're multiplying negative, multiplied by negative, you're going to get a positive. So in this case, what we are going to do is, we are going to say this complement multiplied by that complement. So we're just going to have C. Then this union is now going to change to intersection. Always when I multiply a complement from outside with inside elements, what we have here is going to change. If it was union, it would be intersection. If it was intersection, it would be union. Then this is going to be B, the complement will come here. So simply means that part 6 is C intersection B complement. So what does this mean? What it means is that first you have to list elements of which are not found in B. Where is B? B we have got elements starting from 1 all the way up to 18. So meaning that B complement is going to be elements which are in the universal set but they are not in B. So elements which are in the universal set but are not in B, we are going to have -2, -1, 0, then also 19 and 20. So this is going to be B complement. So now we are saying find B intersection C intersection B complement. That is, find the elements which are found in C, but those elements are also in B complement. So which elements are going to be those? So C intersection B complement is going to be equal to, where is C? So we have C here. C has got elements starting from -2 all the way up to 17. So which elements are common? As you can see, we have -2. So we have -2, -1. These elements are found in both, as well as 0. Then 0 also, yeah. So 17 is not in B complement, whereas 19 and 20, they are not in C. So only these. So this is going to be your answer to part 6 there. So now state the cardinality of this set. So cardinality is going to be equal to n. So how many elements do we have there? If you can count, we have 1, 2, 3 elements. So cardinality is going to be 3. So this is how you can answer these questions. Then if you come to the last part here, we are saying B union C intersection Z. So first of all, start with B union C. Simply add the elements in B as well as in C. So earlier you already had B union C. You already had find this. So now find the elements which are common in B union C and also in Z. That is going to be your final answer. So that is how you can answer this question. Then the second question is saying, let X, so we have got -10 to 10, be the universal set. A, we have got -1 to 4, B 0 to 9, C -3 to 6, be the subsets of X. Find each of the following and display them on the real line. So real lines also simply means the number line. So we have to display our solutions on the number line. So here there are things which you have to consider when answering such kind of a question. As you can see, we are going to have this scale bracket as well as as well as something like this or that. So where you see this curly bracket, what it means is that not included, not included. Okay, it means the same. These two, they mean the same, not included. Then where you are going to see these two, this simply means included. So these two simply means included. So before you start answering questions here, you have to pay particular attention to which symbol has been used. So if we say, like the universal set, we are saying starting from -10 all the way up to 10. So if you see here, we have got this curly bracket and that one. So what is the difference between the two? So this one simply means the starting number here, -10, is not included. Okay, it's not part of the universal set. Whereas where we are going to end, we have got that symbol. So this simply means that this 10 is included. Okay, so where you see that symbol, we are going to say it's open, meaning that not included. Where you see these two symbols here, it means it's closed. So meaning that if you want to present your solution on the number line, you are going to say, if we have the real line here, then we list the numbers. Let's say we have these numbers here, for instance. Then let's say we have 3, 6, 9, 12, and 15. Then we are saying a particular set is 3, 9. So when presenting this on the number line, you can see that 3 is not included, 3 is not included, 9 is also not included. So it's open. So it's going to be open at the 3 as well as also open at 9. Then you join these two. So that is going to be your answer. You would have answered this question and you have presented it on the number line. If you have something like, let's say 9 all the way up to 12, this one is going to be, you can see that it's including 9. So it's going to be closed at 9 and open at 12. 12 is not included. So when presenting on the number line, you are going to shade. So closed is going to be shaded like that. And open at 12. 12 is not included. So you join like that. It means your answer would have been like that. So pay particular attention to what symbol has been used. Is it open or closed? Okay. So we have the universal set. So in answering these questions, you are going to, let's have the number line or the universal set. So you are going to have the number line or the universal set. So the universal set has got elements starting from 10 not included all the way up to -10 not included all the way up to 10. That is our universal set all the way up to 10. Then so we have -10, then all the way up to 10. So what we're going to do now, we are going just to list, instead of listing all the elements here starting from -10 all to 10, that is going to be tedious. So what we're going to do, you only put the numbers on the line which you have here. Let's say A has got -1 to 4. So we have to include -1. We also got -3. That's all. So it means I can include, let's say, here we have -3. Then we also have got -1. What else? So positive numbers, we've got 4, 6, and 10 itself. So let's say here we have got 4. Then there we have got 6. So this is the universal set. You don't have to list all the elements of the universal set. Let's say -10, -9, all the way up to +10. No, that is going to be so tiresome. You may not even have enough space. So just put the numbers which you have in the questions given, including those in the subset. So as you can see, we have -1, 4, -3, 6, as well as those. So these numbers are enough to help us to answer all these questions which we have here. So what we have here, this is the universal set. So let's answer the first question. So the first question is saying A complement. So that is A complement. So what does A complement mean? So A complement simply means elements which are not found in A. Elements which are not found in A. But what is A? So A, we have got elements starting from -1 all the way to 4. So A, we have element starting from -1 included and all the way up to 4. So you are starting from here all the way up to 4, both closed because both of them are included, so it will be closed at both -1 and as well as 4. So that is A. But the question that is not asking us to find A, it's asking us to find A complement. That is, we have to find elements which are not found in A. So elements which are not found in A but are in the universal set. So it's going to be starting from this same 4. So now 4 is in A, so it can't be in A complement. So it will be open at 4 all the way up to 10. 10 is part of the universal set, so it's going to be closed there. So this is going to be all the way up to there. So this is going to be all the way up to there. Then also -1 is in A, so it can be in A complement, and -10 is not in the universal set. So this is also going to be A complement. So we have, this is A complement, this is also A complement. So if we are to answer this without using a line, we are going to say A complement will be equal to -10 not included all the way to -1 not included union 4 not included all the way to 10. 10 is included, like this. So this is going to be the answer. And present it on the number line. You are going to present it the way I have presented there. But again, if you want, you can extract and present this on its own number line. So what you can do is you're going to say the number line to this is going to be then here also I'll just list the elements of interest. So we have -10, then we have -1, we have 4 as well as +10. So -10, then -1, 4 and 10. So now I want to present just that on the number line. So we are going to say this is we're going to say A complement is going to be 10 not included, 1 also not included. We join this. Union 4 is not included, but 10 is included. Then we join this. So this is the answer on the real line. That is A complement. So that is how you can present your answer on the real line. Okay. So always pay particular attention. If this was also curved like that, we are going to say open at 10. This was not going to be included. 10 was going to be open like that. But we have got this bracket. Simply means that number is included. So that's why we are including it there. So this is the answer to the first part of the question. So you can do this to answer even the second part. So the second part which was saying, the second part is saying we have to find elements. So we are done with this. Don't know if we will need it again. Anyway, okay. So we have this real line. Then okay. So now the second part is saying A intersection B. So that is, you have to find elements which are common in A as well as in B. But for you to find that, you are first supposed to list elements of A. So let's use the real line. So we're going to have A is starting from -1 included. So we have -1 included all the way to 4 also included. This is going to be A. Okay. So we have A there. What about B? B is starting from 0 not included, so I also had to include 0. I didn't see 0 as well as 9. So 0 will be between, okay, 0. We also have got 9. So let's say we have 9 there. Okay. So B is starting from 0, 0 not included. So open at 0 all the way to 9 not included. So this is going to be B. So now the question is, find A intersection B, elements which are common in A as well as in B. If you look at these two lines, where do they intersect? So they intersect at this part. So what is going to be our answer? So we're going to say A intersection B is going to be equal to 0 is not in B. So it's going to be open at 0 all the way to 4. As you can see, 4 is going to be in B and also 4 is in A. So this is going to be included. Then answering it on the rule line, you are just supposed to extract this part and present it, also including the universal. So you're going to say negative 10, 0, 4 as well as 10. Then you present that part. 0 open at 0 and close at 4. That is going to be your A intersection. That will be your A intersection B. So you would have answered that question as well. Then we move on to this other part, which is part 3, A union C complement. So A union C complement simply means add A and C and elements which then complement. Complement simply means elements which are not found in A union C. So when we add A and C, what are we going to get? Then which elements are going to remain, which will not be in A union C, but they are in the universal set. So what is A union C? So we have A there. Where is C? So C starts from negative 3 all the way to 6, whereas negative 3 is included. So close that negative 3, but 6 is not included. So it's open at 6. So this is C. That is C. Then we have A. Which question am I answering? No, it's B, not C. A union B. So this is supposed to be B. So where is B? B is starting from 0, not included, all the way to 9. Supposed to have 9 there. Also not included, open like that. So when we add now, we are saying A union B. So add these. So when you add, you're going to find that you're going to have elements starting from negative 1 all the way to 9, but 9 will not be included. So this is going to be equal to negative 1 included to 9 not included. That is going to be A union B. So now we are saying complement. That is elements which are not found in A union B. So A union B complement is going to be equal to, so it's going to start from here, negative 1 not included all the way to 10. 10 is negative 10. Negative 10 is not included. Also starting from 9, 9 will be included in the complement because it's not in A union B. Then all the way to 10 also included. So this is going to be equal to negative 10 all the way to negative 1 open. Then union 9 will now be included in the complement all the way to 10 also included. Then you can just shade this part. That is your answer to that question. So this is what you can do to answer this question. This is what you can do to answer these questions. So maybe you can go ahead and answer part 4 as well as the last part. So these will require you to simplify. So let me just help you to simplify these two, then you are going to finish and send me the answers. So I have A intersection C minus this complement and complement. So as I said earlier, that superscript C there, it simply means complement, which can also be presented as this. So for you to answer this question, you are first supposed to simplify. So this is A intersection open C. So in mathematics, if you have A minus C, this simply means that A intersection C complement. So minus simply means intersection complement what comes after minus. So what we're going to have here, this is going to be C intersection B. You can see that B already has got a complement. So complement and complement, that will be positive. So this will just be B positive. Then we have a complement outside there. So for you to answer this question now, what you are supposed to do is you are supposed to find C intersection B, then complement. So elements which are not found in C as well as in B. Then those elements intersect them with A. They have to be common in A as well as in that set. Then what else? Yeah. Then you'd have answered this question. So just find C intersection B. So C intersection B, where is B? B already have it there. Then C is starting from -3 included all the way to 6 not included, like that. So that is C. So if we say C intersection B, C intersection B is going to be which part? So C intersection B will start from 0 all the way up to 6. So 0 not included. So C intersection B will be all the way from 0 not included up to 6. 6 also not included. Then complement elements which are not found in those sets. So it's going to be starting from 0 included now all the way to -10 not included. That is now I'm answering C intersection B complement. So be equal to -10 not included all the way to 0 included union. You also start from 6 will be included in the complement all the way to 10. So this will be union 6 included all the way to 10 also included. Then you can present that on the number line. Then you would have answered also this question. Then the last part, which is part 5. So we have X intersection. Okay, we have X. So remember that X is the universal set minus this. Then union open A minus B minus C complement. So simplify this. So simplifying this, we're going to get universal set intersection A complement union. This is going to be A intersection B complement intersection C complement. So C has got a complement already. So complement, that is going to be, remember I have C minus or B minus C complement. So this is the same as B intersection C complement. This complement and this one complement. So complement is positive. So this will just be B intersection C. So that is what we are going to have here, like this. Then now your first is supposed to start by finding A intersection B complement, elements which are found in A as well as in B complement. Then everything that you are going to have, intersect it with C. Then you have this. Then also find universal set intersection A complement, elements which are in the universal set but they are also in the A complement. Then after you find this, then combine together. That's what union means. Combine the element that you're going to get from here as well as there. Then after that, put your answer on the real line. Then you would have answered that question. So you can send me answers to that last part. I'll be waiting. Question 3, which reads, let R be the universal set and D be equal to that, E, F be that, be the universal set on X. So the universal set is R. So that R is the symbol for real numbers. So meaning that our universal set here is the set of real numbers. So real numbers is starting from any number starting from -infinity all the way up to +infinity. So that is going to be our universal set. Then we've got subset, which is D, E, F on X. So now we are saying that I think here, let's first list the actual element or members of F. So we're saying that X is such that -10 is less than or equal to X, X is less than or equal to 10. So if we are to list this, F is going to be equal to, as you can see there, -10 is less than or equal to X, meaning that -10 is included. So we're going to use this. So that will be -10 all the way to 10, which is also included because we are saying less than or equal to 10. So it means 10 is also included. So we're going to have -10 included all the way up to 10. So this is set F. So now that we have these, we can answer these questions. So the question is saying display your results on the number line. So the first one being, so I said that always when answering this question, you're supposed to display all the elements given in the question on the number line. So let's say this is our number line. So we're going to have -infinity this side. Then which number will come after that? So -10. Then let's say we have -10 here. Then after negative 10, we're going to have negative 7. After that, let's say we are going to have 0. We're going to have 0. Then let's say any positive number, we have 8. Okay, so we're going to have 8. Then we also have got 10. We also have got 11. Then we can say negative infinity. So now what we're going to do is we just put the members of interest. So this will be negative infinity at the inverse, then all the way up to positive infinity. Then what is the smallest number after that? So we're going to have negative 10. After negative 10, negative 7. After this, I think we're going to have 0. After 0, what comes after that? So we're going to have 8. After 8, we'll have 10. Then we'll have 11. Then all the way up to positive infinity. So this is going to be our numbering. So remember that the inverse set is denoted by x. So in short, what we have here, this is set x. On the real numbers, they are all real numbers. So now we can start answering the questions. Now we can start answering the questions. So the first question being, okay, so the first question is saying we have to find f. So earlier on I already explained what this means. So this is the same as f minus e complement. So remember that complement is the same as f. So let's say we're going to have f minus e complement. So this now is going to change into intersection. So which will give us f intersection e. So there's a complement already there, another complement. So I said complement, they cancel each other. So that will just be f intersection e. So this is the first question, and we have to display it on the number line. So now we have to find f intersection e. So f intersection e, let's first have f. So f, we are saying it starts from negative 10 included. So it will be closed because it's included all the way to positive 10. This positive 10 will also be included. So this is going to be set f. Then what of e? So e, we are saying from 0 to 11, both not included. So 0 open at 0 and also open at 11, like that. So that is set e. So now where do these two intersect? So you can see that the intersecting part is from 0 all the way up to 10. But is it going to be included? No. So it will be open at 0. So this is going to be open at 0 all the way to 10. So 10 is going to be included. Reason being, you can see that 10 is in set f. At the same time, 10 is also in set e. So this is set e. So for the fact that f is closed at 10, it means that 10 is included in f. Then you can see that this line for f, for e, is passing that 10. It means that 10 is also a member of e. But if you check 0 here, so we are saying that e will start from 0, but e does not include the 0. So that's why it's going to be open by there. Despite 0 being in set f, it's not included in set e. So that's why it's going to be open at 0 and closed at 10. So that is going to be your answer. So you can shade it like that, then leave your answer. You'll be marked correct because you have presented your answer on the real line there. Then let's answer part 2. So part 2 is saying use the sets above to verify that D complement union E complement is the same as open bracket, open, D intersection E complement. What about it? So we'll start with the first one. So here we're just verifying, is this true? So let's do this, okay? So let's verify if that is true or not, if the two sides are the same. So we'll start with the first part, which is say, so we have D complement union E complement. Oh no. So that is we have D complement union E complement as well. Then we are saying that this should be equal to open D intersection E complement. So I want to confirm if this is true. So okay, yeah. So the first part, D complement union E complement, yes. So let's first answer the first part, which is saying D complement union E complement. What is the result? So where is D? D is from -7. So let's have D. D is from -7, not included, all the way up to 8. So 8 is included in D. This is going to be D. Now what of D complement? What is going to be D complement? So D complement will be open at 8 and closed at 7. This one will go all the way to -infinity, and this one will go all the way to +infinity. So this is D complement. This is also D complement. So now that we have D complement, let's come up with the E complement as well. So E runs from 0 to 11, both not included. So we're going to say 0, open at 0, and also open at 11, like this. So this is going to be E. So now we are saying that is going to be E. So we don't want E, we want E complement because that is our interest. So now that we have E, then we can come up with E complement. So E complement is going to be closed at 11 all the way to +infinity, and also closed at 0. 0 is going to be included in E complement all the way to -infinity, like that. So now we have E complement as well as a D complement. So the question here is saying find D complement union E complement. So union, I said, simply means add. So we have to add D complement as well as E complement. What are we going to get? So if we add, we can see that E complement covers from 0 all the way to -infinity. Okay? Whereas D complement starts from, so in short, this part of E which starts from 0 all the way up to -infinity, it caters for D complement. So elements which are in D complement this side, they are also in E complement. So we're going to say that has been swallowed by E complement this side. So this side we're going to say it's from 0 included all the way to +infinity. Then union, where else? So D complement also starts from 8. So in short, we are going to jump from 0 to 8. Then D complement starts from 8 all the way to +infinity. So +infinity, this side we also have got E complement. E complement starts from 11 all the way to +infinity. So this part has also been swallowed by D complement. So since we are just adding, we are not finding the intersection, so we're going to say our final result is going to be -infinity all the way to 0. 0 is going to be closed. Then union, also starting from 8. D complement is open at 8. So we're going to say union, this will be open, then 8 all the way to +infinity. So this is going to be your answer. If you want to shade, you are going to shade like this, from there all the way up to that. Then you skip that part, then you also shade this part all the way to +infinity. So this is the result for D complement union E complement. So now that we have the result for D complement union E complement, let's come up with, because remember that we are verifying if the two sides are equal. So now let's come up with the other set. So that other set is, what is it saying? So it's saying that we should also find D intersection E. So we should find D intersection E. So let's start with a D. So D, we are saying it runs from -7 not included all the way to 8 closed. So what we have here, in short, this is D. What about E now? So E runs from 0 not included, so it will be open at 0 all the way to 11. 11 also not included, closed at that part again. So like this. This is E. So now remember, this question is saying intersection. So we are now looking for the elements which are common in D as well as in E. So where the two lines intersect, intersect, that is where our solution is. So if you look at these two lines, the black and white, the black and red line, these two intersect from 0 all the way up to 8. This simply means that D intersection E is going to be equal to, you can see that it's open at the starting point of 0. So we're going to say this will be 0 all the way to D ends at 8. And 8 is included in D as well as 8 is also in E. So it will be closed like that. So this is going to be our D intersection E. So that part which is shaded there. So now we can go back to answer the question. Use the set above to verify this and that. So are the two sides equal? So if you look at this, you can already see that the two sides are not equal. So our final results is going to be, our conclusion is going to be D complement union E complement is not the same as D intersection E. So we have verified the two sides are not equal based on the results obtained. So the two sides are not equal. Then what about that other one? So what about the second one? So which is saying we have to find, okay, let me leave D there. So we now move to the other part, this part, which is saying D complement intersection E complement intersection F. Is it the same as that? Does it hold? Meaning that are the two sides the same? So here we have D complement intersection E complement. So I'm just going to explain this question, then you are going to finish based on how I've explained. So we have this is D complement intersection E complement, also intersection F complement. Is it the same as D union E union F complement? That is, if you add all the three sets, then the elements which will not be found in those sets when you add, but they are in the universal set. That's what it means. Then you are going to make a conclusion if the two sides are equal. So if you want to handle this first part, the first part you can handle it well if you can first start with 2. So let's say you start by finding D complement intersection E complement, of which we already found in the when answering this question. We found that D complement intersection E complement, even though that one was union, so now it's complement. Then when we find that, intersect it with F complement, then that is going to be the end result for this part. The same will be true this side. You can first start by finding two, or if you want this side, you can simplify by multiplying by that negative, so that complement, which is going to give you D complement union E complement. When you multiply by a complement, if it was union, we said that it's going to change to intersection. So this is going to be the same as D complement intersection E complement intersection F complement. So these two are the same. The top one and the down one, this and this, those two are the same. The other one is, I've just simplified it. So now that we have this, you can decide to handle 2 first. So you can say you find D complement intersection E complement, of which is the same as this, then intersect it with F. So here, if you look at this, the two sides are already equal. So we're also expecting your results to be the same, because after simplifying this, what we have obtained is exactly this one here. So that's the same there. So even your results that you are going to obtain, they should be the same. So that part is going to be, this part is going to qualify to be equal. So you can just go ahead and use this number line to verify this. So the two sides have to be equal. If you not find them to be equal, then you would have gone wrong somewhere. So you can drop your results so that we compare with what I have with me here. So question 4 reads, for each of the following sets, state whether it is finity or infinity, and in each case justify your answer. So we have to state whether any of these sets comes to an end, that is, it has got the beginning and the end, or it does not end. Okay, that's what infinity means, it does not end, or finity, it comes to an end. So we'll start with the first one, which is set B. So set B, we are saying that we have got counting numbers starting from 1 all the way up to 100. Now if you look at this set, you can see that you have the starting point. So you have the starting point is 1 and the end point is 100. So if you want to pick a member from this set, you are restricted. You can't pick a member which is less than 1. Also, you can't pick a member which is greater than 100. So it means that this set, the first set is this one is finity because it's coming to an end. It has the beginning and the end. That is the justification. Then we come to part C, which is saying, so remember that this symbol simply means included. So this set C, we are saying you have members. If I draw the number line here, so that we understand this question better, we are going to have, let's say this is 1 and this is okay. So let's say we have this is going to be 0. Of course, this is going to be 0. Then this is going to be 1. Okay. So we are saying from 0 to 1, both included. So which simply means that it's going to be closed at 2. I just want us to understand what that means there. So close at 2 and also closed at 0 and also close at 1. This is this part. Then we are saying this part should now intersect with so we have this set 3 over 4 not included all the way up to 3 over 2. So if you divide, you are going to get that 3, how many times can 3 go into 4? So that is going to be 1 point, remainder will be 1 into 10, that is 3. Then remainder will be 1 into 10, another 3. So that is going to be something like 1.3. So where are we going to have 1.3? 1.3 is greater than 1. So let's say 1.3 is somewhere here. So this will be, let's say this will be 4 over 3. Then we also got 3 over 2. So what is 3 over 2 in decimal? So that is going to be, let's say 3 over 2, this will be equal to 3 into 2, that will be 1 point, remainder will be 1, 5. So this at least will be 1.5. So let's say 3 over 2 is there. Then now if you want to, we are going to say both are not included because we are using open symbols. So open here and also open there. Then we can join this. So the question that we have here is, we want to find elements which are common in this set, but they are also in that set where the two intersect. We are looking for the intersecting part. So if you look at these two sets which we have here, they do not intersect at any point. This set is outside this other set, so they don't have common members. So this set is going to be an empty set. Okay, so C is simply equal to an empty set, and an empty set is a finity. Okay, an empty set is a finite set. So part C is also finite as well because it's an empty set. Empty set comes to an end. So the answer is finity for part C. Justification is that we don't have members which are common. As a result, this set is going to be empty. So an empty set is going to be finite as well. Then we move on to part D. This set D is saying D is such that D is a member of then set D. So set D we have D is given by, so we're saying that X is such that is a member of real numbers. Then X squared plus X is greater than 2. So we have to state if this set is finity or infinity. So now if you look at that, let's just consider this. So that is an equality. So we're going to say that is X squared plus X is greater than 2. So if we rearrange this, we're going to have X squared plus X. That will be minus 2 is greater than 0. Then now this is a quadratic, so we can solve this as a quadratic. So we have product, sum, and factor. So product is negative 2. Sum is going to be 1. So what are the factors? Two numbers that we can multiply to get negative 2. We add, we get 1. So that is going to be 2 and negative 1. Okay. So then when we solve this, we are going to have x squared minus x, then plus 2x minus 2 will be greater than 0. Then we factorize, so we're going to have x is common, we'll remain with x minus 1. Then here common is 2, and remain with x minus 1 is greater than 0. After this, now we are going to have x plus 2 is greater than 0. Then we also have x minus 1 is greater than 0. So this will be x will be greater than negative 2. Then we also have x will be greater than positive 1. So now we are supposed to test these. And in quality, when you find the values, you should always test the results so that you see where it's going to be defined, or yeah, it's going to be defined. So we're going to have this number, right? So let's say we have two numbers there. Let's say this is negative 2. Then this is going to be 1. So after this, what do we have? Okay, so this side is going to be positive, negative infinity. Then this side is going to go all the way up to positive infinity. So this result is saying that okay, so we have, what do we have? So we have, this is negative infinity, then we have negative 2, then we also have 1 here and positive infinity. So these values that we have obtained, these values are now what we call critical points. So we have x is equal to negative 2, then x equal to positive 1. So our interest is to test where, in which range of values is our solution is going to be greater than 2. Okay, so we're going to consider positive in that case. So what you're going to do with these critical values, you're going to reverse them and multiply the results. So that is going to be, if we reverse this, we are going to have x plus 2 multiplied by, that will be x minus 1, like this. So now let's consider any number which is less than negative 2. Let's say any number less than negative 2, let's say negative 3. Any number between negative 2 and 0, that is going to be, and 1, sorry, that is going to be 0. And any number greater than 1, so that is going to be, let's say 2. Here, you pick any number to the left hand side as well as to the right hand side, or the critical point. So you can see that we only got two critical points, negative 2 and 1. So you pick a number less than that critical point and also a number greater than that critical point. So less than negative 2, we're going to have negative 3. Greater than negative 2, we have 0. Then less than 1, we have 0. Greater than 1, we are going to have negative 2. So now we're going to use those numbers, the ones which are in red, and plug them in here and see the overall result that we're going to get. So here we're only interested, is the result going to be positive or negative? So let's say if we plug negative 3 here. If we put negative 3 here, we're going to have negative 1. So negative 1 multiplied by, we put negative 3 there, that will be negative 4. So the overall result, if you multiply negative 1 multiplied by negative 4, that is going to be positive 4. So it means if you get any number greater or less than negative 2, the result is going to be positive. What if now we plug in 0? We get a number which is less than, or which is greater than negative 2. That is 0. So we plug in 0, we are going to have, this will be 2. There we are going to have negative 1. If we multiply the 2, we are going to get negative 2. So overall result, we are just interested in the sign. It's going to be negative. What if you pick a number greater than 1? Say 2. So we plug in 2 now. So if we plug in 2, we are going to have 2 plus 2, that will be 4. Then 2 minus 1, that is going to be 1. So 4 multiplied by 1, that is 4 as well. So the result, overall result, that is positive. So now we know where the range of values where this function is going to be varied. So it's going to be varied for any number which is less than all the way from negative infinity up to 2. 2 won't be included, or negative 2. Negative 2 won't be included because there it's just greater than. If it was greater than or equal to, we are going to say it to be included. So we are saying it will be all the way from negative infinity up to negative 2, not included, union. So if you pick any number between negative 2 and 1, the result is going to be negative. That which means that the result that we are going to obtain the number will be less than 2. So we don't want the number to be less than 2. We want the number to be greater than 2. So it means we're not interested in this area. Okay, so we are going to get a number which is greater than 1, and 1 won't be included. So we're going to say from 1 all the way to positive infinity. So for you to come up with this one, you use critical points, not these numbers. These numbers in red, they just help you to come up with or to decide what the outcome is going to be. So now this is our final result that we are obtaining. So now that we have found that this function is going to be defined in these areas, now we can state, is this set finity or infinity? Does it come to an end or it doesn't? So for the fact that we have got negative infinity and positive infinity, we are saying that we can pick any number starting from 1 all the way to positive infinity. You can also pick a number starting from negative 2 all the way to negative infinity. So this simply means that this set is infinity. It does not come to an end, because it can be any number except these numbers between negative 2 and 1. So this set is also is infinity. So we found that this was finity, this was also finity. Then for the first time, D is infinity. It does not come to an end because of that. So that's how you can justify your answer to state if it's infinity or finity based on that, because this is an inequality. So that is it for that part. Then for the last part, is saying A is such that x is a member of real numbers. Then we have modulus of x minus 1 is equal to negative 1. Now, what's one thing do you know about the absolute value, or do you know about modulus? So modulus, what simply means is that anything outside modulus, it can't be negative. So if I have modulus of negative x is a positive x, whereas modulus of x, positive x, is the same as a positive x. Maybe let me use numbers. So modulus of negative 2 is equal to positive 2, and modulus of 2 is equal to also positive 2. So anything in the modulus, it can't come out negative. So for the fact that this question is telling us to say we have modulus of x minus 1 then equal to negative 1. So anything, then remember that x can be any number as long as it's a real number. Okay? Any number as long as that number is a real number, is a member of real numbers. So you can pick any number on the line, and that can be your x. So we're saying that the result is going to come out negative 1. So this is not true. Something in the modulus can't come out negative. So this does not exist. This is false. This question is false. It does not exist. It does not have values which are going to make this set defined. So because of that, this set is going to be empty. It won't have members, because this is not true. That is false. Anything in the modulus can come out negative. So it's an empty set. So for the fact that it's an empty set, it does not have members, it means it's finity. So this set, the last set, is going to be finity, to come to an end, because it's an empty set, and this statement is not true at all, because anything in the modulus can't come out negative. So that is how you would have justified this problem. So question 5, we have another very interesting problem. So let's do with it. Let U be a set that is the inverse set such that x is a member of natural numbers. So you know that natural numbers, these are counting numbers starting from positive 1. So 1, 2, 3, 4, 5, and so on. So now in these natural numbers, we are saying that this set complies numbers starting from 1. 1 is included, because we are saying this set has got members starting from 1 less than or equal to, meaning that 1 is also included, all the way up to 30. So 30 is also included, because we are saying less than or equal to 30. So now what we have here, the universal set has got members, that is 1, 2, all the way up to 30. So this is our universal set. Then we move on, given that A is so this is going to be a subset of the universal set such that x is, okay, so let's understand this part. Okay, because we have to interpret and come up with the actual members of that set. So we are saying that x is such that x is equal to 2k plus 1. So what is the condition? So remember that we have this part. This part is saying k is a member of natural numbers. But remember that this is in the set of what? The universal set is starting from 1 to 30. So meaning that k can be any member from this set. Okay, not outside the universal set, because we are restricted by the universal set. So k is a member of natural numbers. But again, there is this condition here. We are saying that k is any member but less than 15. Okay, less than 15. So what does it mean? So meaning that k is going to be any member. So we're going to have k equal to 1. Also k will be equal to 2 all the way up to less than 15. So that is going to be k will be equal to 14. Okay, so we have k is all the way from 1 up to 14. These are the values of k. So it can be any number starting from 1 to 14. That is going to be k. But now we are saying that for you to get x, or set a, so a will be equal to, okay, a is going to be equal to, you have to start from 1, put let k be 1, so put k where the where there's k, so that is going to be 2 multiplied by 1, it to be 2, so 2 plus 1, that is going to be 3. So the first member of set a is going to be 3. Okay, 3. Then the next member k will be 2. 2 multiplied by 2, that is going to be 4. 4 plus 1, that is going to be 5. The next we are going to have, so I want you to observe the pattern that we're going to have here. The next we are going to have 3. 2 multiplied by 3, that is going to be 6. 6 plus 1, that is 7. The next we're going to have 5. So 5 multiplied by 2, that is 10. 10 plus 1, that is going to be 11. So if you have noticed, we are obtaining odd numbers. Okay, we are obtaining odd numbers. So how many are they going to be? So I was on 5. I was on 5. The next we are going to have 6. So 6 is going to be 6 multiplied by 2, that is 12. 12 plus 1, we are obtaining 13. Then 7 multiplied by 2, that is going to be 14. 14 plus 1, we have 15. Then 8 multiplied by that, 16 plus 1, that is 17. Then 9, 18 plus 1, we have 19. Then 10, that is going to be 20 plus 1, we're going to have 21. Then 11, that will be 22 plus 1, we have a 23. Then next we're going to have, I'm on 11, so 12, that will be 24 plus 2, we have 25. Then 13, 26 plus 2, that is going to be 20, plus 1. 26 plus 1, that is 27. Then next we have 14, that is 28 plus 1, that is going to be 29. So it means that we are done. This is set A. Okay? So these are the members. I've listed all the members of set A. So that is how you can come up with this set. Just use this formula. So the logic was you knowing what the value of k is and where are you going to get this k. And remember that the universal set runs from 1 to 30. So we are not expecting to have a member outside the universal set. That is why k there, they are saying k is less than 15. So that if you put k as 15, let's just try. If we say k is 15, 2 multiplied by 15, that is going to be 30. 30 plus 1 to be 31. So 31 will be outside this set. That's why we have that condition there. So all these are going to be members of set A. Then also set B is complete. So we have B, which is straightforward. Let's just bring it here. So B equal to, that is 1, 3, 8. We have 19, then 20. Okay, that is it. Then we also have got set C. So set C, what is it saying? So C, x is such that x is equal to k squared. So this one again we are supposed to calculate. So we are saying that for you to obtain x, this will be equal to k squared. What is the condition for k? So k should be a member of natural numbers in the universal set, but k should now be what? Less than 6. Okay, k should be less than 6. meaning that the value for k are going to be, k will be equal to 1, 2, 3, 4, and 5, because we are saying k should be less than 6. So now using this formula, let's come up with set c. So set c is going to be equal to, we start, if k is 1, what is going to be x? So 1 squared is still 1, so we have 1. Then 2 squared is going to be 4. 3 squared, that will be 9. 4 squared, that will be 16. Then 5 squared, that is going to be 25. Then this is the set c, because we are saying k should be less than 6. So if you put 6 there, it's going to be 6 squared, 36. 36 will be outside this set. That's why the condition is also k should be less than 6. Okay, so we have set c. Then lastly we have set d, which is already given. So d is equal to, d we have members, that is 1, 2, 6. So we have 1, 2, 6, then 8, 11, and 15. So now we have all the sets in their simplest form, so we can answer these questions now. So this is more like just a repetition. What was hard, it was just this part for you to come up with these sets, like set A, set and set C, as well as maybe the universal set. So now that we've come up with all these sets, I do believe that you can answer all these questions. So I'll just pick one and try to answer. So let me answer part 2. Then you are going to answer part 1 or all these remaining ones. So we have A, that is the difference of set. Then B union C. So that is difference of the set, which simply means A minus open B union C, like that. So this will be A intersection open B union what comes after that, we have a complement. So this means that we already have set A. Set A, where is it? So set A is here. So now we want to find members which are common in this set, but those members should also be found in B union C complement. Okay, they should also be found in B union C complement. So let's come up with that set, B union C complement. So members which are not found in B union C. When we add B and C, the members which are not going to be found in that set, but they are in the universal set. So where is B and C? So B and C, we have 1. So we're going to have 1, then 3, 4, 8, 9. Okay, let me write it somewhere. So we are saying B union C will be equal to, B union C, we are going just to combine 1, then 3, we have 4, then 8, the next we have 9, then 16, 19, then we have 20, and lastly we have 25, like this. Okay, so now complement simply means any element now which is missing in this set, but that element is in the universal set. So what is missing there? We have 2 is missing, 3, 4, 5 is missing, 6 and 7 they are missing, 10 is missing, then 11, 12, 13, 14, as well as 15, then 16 is there, 17 is missing, 18 is missing, 19 is there, so we have 21 is missing, then 20, 21, then 20, 22 is not there, 22, 23, 24, 25 is there, then we have 26. So all the elements there up to 30. So this is our B union C complement. These are the members. So now the question is, the question we are answering is elements which are common in A, but they are also in B union C complement. So let's see which elements are common in these two sets. So let me have it here. So we have A intersection open, B union C complement. So we're saying this will be equal to open. So each element are common there. So where is set A? Set A is here. So you can see that set A is a very big set as well. So which elements are common? We have 3 here, we don't have 3. 5, so 5 is the first element, so we have 5. Then 7 is also common. Then 11 is common. Then 13 is common. Then 15 as well is common. Then what else? 17, yes, is common. Then 19 is not common. 19 is not in B union C complement. Then 21 is common. So we have 21 is common. 23 is common as well. Then 25 is not common because it's not in the other set. 27 and 29. So 27 is common as well as 29. So this set is okay. So this is the answer to this question. That's our answer. A intersection open B union C complement. The result is this one there. Okay. So you can go ahead and find this one, that one, and this one as well. So these are very simple. Just simplify. So you're going to simplify this one or this, then you are going to answer this question. So let me just help you to simplify part 3, then I'm going to leave everything in your hands so that you can answer them. You can share what the solutions are going to be. Should I simplify? Let me simplify part 3. So we have open A union B, then intersection C, then complement outside. So here we're going to go ahead and say this is the same as if you have a complement outside, you are always allowed to multiply to open these brackets. So this is going to be A union B, then complement. So when you're multiplying a complement by whatever you have inside, if you have union here, this is going to change to intersection. If it was intersection the way it is here, it will change to union. So this one will now be union, then C complement. So this is the final result when you simplify that one. Then now you can go ahead and find A union B complement. Elements which are in the universal but they are not in A union B. Then add elements which are not in C. Then you combine the two sets together. That is going to be your final result here. So go ahead and answer these remaining questions. Question 6. So question 6 is in each of the Venn diagrams below, figure 1. So we have figure 1, which are these two. Shade each of the following separately. So we have to shade each one of these separately. So what it means here is that for this one, you're going to use this diagram as well as that. So what's the difference between these two? The difference is that if you check on this one, Z is a subset of Y. Whereas here we don't have subset. Any set is not a subset of the other except from the universal. So you have to answer that question on both of these two diagrams, but we are supposed to shade. So let's start with the first one. So the first one we have X minus Y. This symbol we said that it means the difference of the set. So Y, that is the same as X minus Y. So X minus Y is the same as X intersection Y, then this will take the complement. So we have X intersection Y. So elements which are found in X as well as in Y complement. That's what we are looking for. So usually with me to answer this question, most of the times I use numbers. So we're just going to assign one number in each of these. So let's say we have 1 here, then 2, 3, 4, 5, 6, 7, then we have 8 outside there. So let's start listing the elements there. So we have X. So X is going to be equal to which elements are found in X. So you can see that X takes up elements starting from 1. Then we have 3, 4, and 5. X will end there. You can check. So that is going to be X. Then now we are looking at, we should also find Y complement. So Y complement, these are elements which are not found in Y, but they're in the universal set. So where is Y? Y is this. So every element which is in Y will not be included. So we just remain with these also plus that. That is going to be Y complement. So let's say we have, that is going to be 4. 5, 6, and 8. This will be y complement. So now to answer the question, we are saying that we are looking for elements which are common in x, but they are also in y complement. So now let's check which elements are common in x as well as in y complement. So 1 is not in y complement, 3 is not in y complement, but 4. So 4 is in x as well as in y complement. What else? We also have got 5. So 5 is also in y complement as well as in x. That's all. So what do we have? We just have 4 and 5, which are common in these two sets. So we have 4 and 5. So meaning that x intersection y complement, the result is 4 and 5. Then now for you to answer, because you are supposed to shade here. So for shading, you are just going to shade where you can see 4 and 5. So our answer to this question, to answer this question now, we're going to say the answer is this part all the way up to that. So you would have answered this question. That is the answer. So this is how I find it easy to answer these questions involving shading. Just using numbers, it's very easy. Okay. So I've answered the first part. What about the second part? So the second part, so when I answer this second part, I also expect you to answer this third part as well as that. Okay, so we have this. Okay, so also remember that you are supposed to answer this x minus y also on this. Now that z is a member of y, z is a subset of y, how are you going to shade? How are you going to shade? So in this case, we are just dealing with two sets, x and y. So you can ignore z. You can ignore z because z is not involved there. But let's see this second question, which has got all the three. So to simplify that one, we're going to say we have x minus open y union z. So this is going to be the same as x intersection open y union z, then we'll have a complement. So when you have got a minus, whatever comes after that is going to be a complement. For the fact that these are in brackets, you treat these as one. So that's why the complement will come on top like that. So this is what we're going to have. So let's do the same. Okay, let's do the same to assign numbers. So let's say we have 1, then we have got 2, 3, 4, 5, 6, 7, and 8. So the first part, the complicated part, is going to be this one. Let's find this one first. So we're saying y union z complement. But for you to answer y union z complement, you should first just focus on the inside part. Ignore about the complement. So we're going to say y union z, this will be equal to, so which elements, when union simply means add. So let's add elements in y as well as in z. So we're going to have 2, 3, 4, 5, 6, 7. So this will give us 2, 3, 4, 5, 6, 7. So now then we can answer the complement part. So the complement part, now we are saying we should, so we want now to get y union z. So complements. Complement simply means when you add the elements, these two elements which are not going to be found in those two sets, but they are in the universal set. So let's exclude these elements. Everything that remains is going to be y union z complement. So what remains, we're going to have 1 and 8 only. Yeah, we're only going to have 1 and 8. So we're going to say this will be equal to 1, 8, like that. So now that we have y union z complement, we can now then find the shaded part. What is x? So let's list x as well. So x, we are saying we have 1, 2, 3, and 4. 1, 2, 3, and 4. That is our x. So now we want to find the intersection. Elements which are common in this set, they are also common in that set. So which numbers can you see that they appear in both of these two sets? So it's just 1. You can see 1 there. You can also see 1 in x. So now this means that x intersection open y union z complement using numbers, this is going to be equal to 1. So now go shade where you see 1 just. So 1 is seen in this part. Okay, just that part. So this is the answer to the second part. So do the same, simplify this one and do the same approach. The same with this one as well as that. So maybe okay, let me do this. Okay, so we should answer this same question on I'm going to use this same question to answer it on using this other Venn diagram, which has got different arrangement from this one here. So now we have got Z is a subset of Y. So remember, let's still assign the numbers. So let's say we have 1, 2, 3, then 4, and 5. So we have Y or X minus Y union Z. So this is the same as X intersection open Y union Z then complement. So using this second diagram, the Venn diagram, let's first come up with Y union Z. So Y union Z using the second diagram or Venn diagram, we are going to have where is Z? Z is A inside, so we're going to have 2, 3, and 1. So this will give us 2, 3, and 1. Let me put them in ascending order. So 1, 2, and 3. So that is going to be Y union Z. So now what we want to find is Y union Z complement. Elements which are in the universal set but they are not found in Y union Z. That's what Y union Z complement mean. So you can see that we're only going to remain with 4 and 5. These are the only going to be elements which will not be found in Y union Z. So we have 4 and 5. So that is where our interest is. So now intersect that with X. Elements which are found in X. So what is X? So X is equal to, X we have got 4 and 5, or 3 and 4, because X is this set. So let's list the elements of X. So we're going to have 3, 4, like that. So now what is common in this set? What is common in this set and also in this set? So we can see that only 4 is common. So now then we are going to say X intersection open Y union Z complement is equal to what is common. So we found that common is 4. It's just 4. So for shading now you can go ahead and just shade where you can see 4. So 4 is there, meaning that your answer to this question is going to be that part. That's the part which we are going to shade. So now that you are going to report these as your final results, these numbers should not appear as they go to the marker. This, you can do this on the rough paper. On your answer sheet which you are going to submit, just go ahead, don't show these numbers, then just shade that part. Just shade that part. This is your own trick. This is how easy I find to answer these questions. So you can answer any of these questions here. Any of these questions. So I want you to answer part 3, part 4, as well as part 5. Let me maybe for the last time answer which part? For the last time, okay, let me answer part 4. So I'll answer this part 4. Then for you, are going to answer the last 2 parts. That is part 5 and 6. So 4. So this requires you just to simplify. Once you simplify, you're going to find that it's very easy. So that part 4 is saying X intersection open Y intersection Z complement. We also have got a complement outside. So go ahead and simplify first because you can't answer like that. So we're going to have this will be X intersection open. This is going to be Y. So now we're going to multiply everything by this complement which is outside. So this will become Y complement. Once you multiply by a complement from outside, whatever you have here has to change. So it was intersection, now it will be union. Then Z complement. So this Z already has got a complement. So complement, we said these are going to cancel. That will just be Z. So we're just going to have y complement union z. So like this. This complement has already been used. So this is going to be our final result. Then now you just assign numbers in these sets. So let's say we have 1, 2, 3, 4, 5, 6, and 7. So x, we already know the elements for x. So x, we have x is equal to, we have got 1, 2, 3, and 4. That is x. So we should now find y complement union z. This requires us first to find the elements of y complement. So y complement will be elements which are in the universal set, but they are not in y. So exclude elements which are around this, because that's y. So everything outside that, which is going to be 1, 4, 5, and 8. So this will be 1, 4, 5, and 8. This is going to be y complement. So now union simply means add z. Union simply means add. So to whatever we have there, let's add z. So our final results, what we are getting, we are going to say y complement union z. This will be equal to, so where is z? So z has got elements which include the 3, 4, 5, and 6. So let's add to that. So we're going to have 1, then 3, 4, 5, and 6. Then we also have got 8 in y complement. So this will go all the way up to 8. So y complement union z, we have this. So now remember, the question that we are answering is x intersection whatever we have now. So let's see the elements which are common in x and also in this set. So which elements are those? Let's go ahead and list those elements. So we are going to see that 1 is in x as well as in this set. So the first one, we have 1. What else? Do we have 2? We don't have in here, but 3. We have 3 here. We also got 3 there. So 3 is the second element. So we have 3. What else? So 4. 4 is also common in y complement union z as well as in x. So we also got 4. That is all because set x ends up to 4. So these are going to be the elements. So now go ahead and shade where you can see 1, 3, and 4. So 1, 3, and 4. That is your answer. So 1, 3, and 4, you can see that this is going to be 1, 3, and 4. Yes, including this part, 1, 3, and 4. So this is going to be your answer. So that is the answer to this question using this first Venn diagram. So that's how easy you can find these using numbers. Then you do the same on this other one. So you're going to assign numbers 1, 2, 3, 4, 5. It doesn't matter. If you want, you can use alphabetical letters. Let's say A, B, C, D, or whatever. These are just going to help you, like which part are you supposed to shade. So remember that we have we said x intersection y complement union z. When you simplify this, that is what we got. So what is now going to be y complement union z? So let's first come up with y complement using that set now. So y complement is going to be equal to elements which are not found in y. So where is y? Y has got elements 1, 2, and 3. So elements which are not found in y is just 4 and 5. So we're going to say this will be 4 and 5. Then what about y complement union z? So when we say union, simply means add. So now let's add elements which are in y complement and also in z. So that is going to give us, so z has got elements 2 and 3. So let's add 2 and 3 to what we have there. So that is going to be 2, 3, then 4, and 5. So this is going to be y complement union z. That is y complement union z. Then now to answer the question, let's intersect whatever we have here with x. Which elements are going to be common in x as well as in that set? So what is x? So x we have that as 3 and 4. So which elements are common in these two sets? It's 3 and 4, meaning that this whole thing is just equal to x. Okay? because you can see that we have got 3 in this set, we also have got 3 there. We have 4 there, we also have got 4 there. So if you look at the 3 and 4, 3 and 4 is set X. So simply mean that to answer this question using this second Venn diagram, for you to shade, you are going to shade this part where you can see those numbers. So this is going to be the answer on this second Venn diagram. So now that you have an idea, go ahead and answer part 5 as well as part 6. So you should first start by simplifying. After you simplify, then assign these numbers, then you answer. So you can drop your solution that you are going to find so that we can compare with what I have. Okay, so for part B now they have shaded for you and you have to describe the shaded part. Instead of you shading, they have shaded for you and describe the shaded part. Previously we are given a description, then we are supposed to shade. So in each of the Venn diagrams, use the set operation. So it was supposed to be use the set operations, union, and or intersection and complementation to describe the shaded regions. So you can only use union, intersection, or complement to describe the shaded region. So the first part we have this. So what we are describing here, we are describing this shaded part where B is. So if you check there, what this describes is these elements are not in A. So elements which are not in A, that is going to be A complement. Then intersection B. So this is going to be A complement, intersection B. Let's verify if this is true. So let's assign numbers 1, 2, 3, let's say 4. What is A complement? So A complement is going to be equal to elements which are not in A. So that is going to be equal to 3 and 4 only. Then let's come up with set B. Set B will be equal to, we have 2 and 4, or 2 and 3. So this will be 2, 3. Then what is common? So what is common in A complement and also in B? So elements which are common in these two is 4. So where is 4? 4 is in B. So indeed that is true. So the answer to the first part is A complement intersection B. Elements which are common in A complement as well as those elements are in B. Then we come to the second part. So the second part, which is part 2, what are we going to have there? So this part 2, you can see that here we have now elements outside A. That white part simply means elements not in that set. So that is going to be, the starting point is A complement. A complement now, elements outside A. So element outside A is going to be everything, okay? Everything there, except this part. So you can see that this part is also shaded. So it's the one which is remaining now here. So how are we going to involve that part? So to involve that part, you can see that that part is part of B. So this is going to be A complement union B. So that is going to be the answer there. If you want, you can still use numbers to just confirm if this is true. So if you say 1, 2, 3, and 4, these numbers I'm just using them for the sake of being sure if the answer that we have is true. So what is A complement? So any element outside A, that is going to be 3 and 4. Then what about B? So B is going to be equal to, B we have 2 and 4. No, 2 and 3. So B is 2 and 3. Then now we are saying we should add A complement union B. So add those two. What are we going to get? So when we add, we're going to have 2, 3, 4. That is the part which should be shaded. So where 2 is, it's here shaded. Where 3 is also shaded. Where 4 is also shaded. So the answer is going to be A complement union B for the second part. Then we move on to the third part. So this part now, you can see that this area, the white area in A, that part simply means that elements not in that set. Okay? Then B also elements not in that set. So we are describing the shaded part. If you look at this shaded part, this is the intersection. So we are saying that that intersection. So we can say that this is going to be, but again, this shaded part outside here, these are going to be elements which are not in any of these two sets. Those are going to be elements which are not in any of the two sets. So what are we going to say? Elements which are outside the two sets. So elements which are outside two sets, we're going to say that is going to be A union B. You add the elements in A and B, then complement. So when you add the elements in A and B, complement, which simply means bring together all the elements in A and B, then elements outside A and B. So if you have A and B, you add together elements that are not going to be in A and B, is going to be this part outside here. So we have answered the first part. Now we want also to involve this part. The intersection part is involved. So that being part of the shaded part or the interest, we're going to say this also we should add. So union, what are we adding? We are adding A intersection B. So this is going to be the final answer. So A union B complement, describing the outside part. Intersection or union, we should add to whatever we have, we should add A intersection B. So this is going to be the answer to part 3. So if you want, you can go ahead and to verify these using numbers, but you should get the same answer. So I'll just answer one more, then you are going to finish the remaining two. Okay, so we come to part 4. So part 4 we have so part 4 we have this one here, A, B and C. So now we have 3 sets. So how do you describe these 3 sets which we have? How are you going to describe them? So let's start. So here we have A, B and C. So you cannot involve, it's possible you can involve all of them at once, but again it's possible that you use 2 then you add the other one. So this one is going to be, how is it going to be? So which part are we going to start with? So what are we describing here? We are describing the shaded part. So if you look at this, the white part here, let's consider just B and C, forget about A. So if you consider B and C, they are only leaving their intersection. This intersection part is the one which is not involved. So what are you going to say there? So if you look at that comma part between B and C, you're going to say B union C, you add the B and C complement. Not union, no. Not union, so that should be that comma white part. So that is going to be B intersection C. So B intersection C, that is not our interest. B intersection C is the white part. So elements which are not found in that white part are what we are interested with. So B intersection C complement. So elements which are not found in B intersection C, that is our interest. So that is going to be any element outside every element outside that part. Okay, every element outside that part. This is what B intersection C mean there. So now we want to add to whatever we have there. Remember that we also have got A. How are we going to involve A? Because if we leave it like that, it would mean that this part was also supposed to be shaded for A, but it's not shaded. So we want to exclude that part of A now. So how are we going to exclude that part? This is also going to be, then this now is going to be, we should add elements which are found in A, in A complement. So A complement, these are going to be elements not found in A. So elements, any element outside A. Any element outside A. So if you involve any element outside A, you're going to find that this part is going to be shaded. So this white part has already been taken up by that part. Then when we add the A, we are going to use that. So we're going to have B intersection C complement, then union A complement as well. So that is what we're going to get for this question. Then we have the 5th one and 6th. So I'll not finish all of these. So I'll end on, you are going to answer the last one, which is part 6. Let's answer this part 5. So part 5, we also got A, B, and C. So A and B, first let's consider A. All the elements in A are included. So this is going to be, you can start with considering A and C. So if you consider A and C, this is going to be A union C. Okay. So if you add A union C, even this part was supposed to be shaded. So we're going to say A union C. Then now let's forget about A. Let's focus on B and C. So B and C is excluding their intersection. If you see here, this is a excluding intersection. So we're going to say to whatever we have there, we should add. So this is going to be union, open, B intersection C. This one now should complement. So add elements in A and C. So you're going to have everything shaded. You're going to have everything shaded. Then now come to these sets B and C. So if we want to describe this gamma white part, this gamma white part is not included, but what is this gamma white part? So it's a B intersection C. So elements which are not found in that gamma part, B intersection C, then you just add a complement. So that is going to be the answer. So if you want, you can go ahead and use numbers. So you should get the same results if you use numbers there. Where we have got these shaded parts, that's where your numbers should be. So you can answer this last part and send your solution so that we can compare. So question 7, which reads, given that P and Q are disjoint sets, simplify P complement union Q complement. So here we are supposed to simplify, okay, just make it simple. So another key term there is going to be disjoint. So disjoint simply means that these two sets do not intersect, okay. So if we are to draw a Venn diagram and present those two sets, it's going to be like this. So this is the inverse, so then you are going to have, let's say this is P, then this is Q. Then we have the inverser there, that is the inverser, then this is going to be, let's say P, that is going to be Q. Then let's just assign elements, let's say 1, 2, then we also got 3 in the universal, like that. So from here now, we can go ahead and simplify. That is P complement union Q complement. So this one is a bit more simplified, but we have to be very sure, like we have to reach at the final, what is going to be the final result, the overall final result. So using these elements, let's come up with a P complement. So P complements, these are elements which are not going to be found in P, but they are in the inverse. So that is going to include 2 and 3 only. Then Q complement as well, this is going to be equal to elements which are in the inverse but they are not in Q. So that is going to be 1 and 3. 1 and 3. But then we are saying union. So union simply means add. So let's add P complement and Q complement. So that is P complement union Q complement. This is going to give us, so the overall is going to be 1, 2, 3. We are just adding. So this is the final result. But then remember that we are simplifying. We are not interested in what elements are we going to obtain. So if you look at this 1, 2, 3, which set has got elements 1, 2, 3? So that is the universal set. So this simply means that simplifying P complement union Q complement further, this is just going to be equal to the universal set. So universal set is presented by that symbol O. You can use this. So I'm avoiding to use this because someone will look at this as union. So that is P complement union Q complement is giving us the entire universal set. So that the final result is going to be the universal set. So that's the final result. So I'm using this Venn diagram just for me to be sure of the final result that we're going to obtain. Because I mean, that is very simplified, like P complement union Q complement. What step are you going to take for you to simplify this one? It will be very hard. So that's why, like, if you introduce Venn diagram, it's going to guide you much better. Then the second part, which is part B, is saying given that x and y are any two sets, express the following in its simplest form. So we are supposed to simplify these sets and leave them in their simplest form. So the first part, which is saying x complement intersection open x union y complement. So remember that if I have x to that is the same as x complement. So I'm very much used to using that complement than this c, because I can confuse this c with a particular letter. So let's simplify this. Okay, so it's already simplified though, but then from there let's introduce the Venn diagram so that we see what that one is going to be. So here we have got sets just x and y, and these two sets they intersect. They at least have got elements in common. So this is going to, let's say universal, this is x, that is y. Then let's come up with our own elements. Then let's say 1, 2, 3, and 4. So from there we are supposed to have elements that is x complement. So x complement elements which are in the universal but they are not in x. So that is going to be just 3 and 4. Okay. Then now let's come up with x union y. So x union y, this is going to be add elements in x and y. So x and y, when you add, we're going to have 1, 2, and 3. Then we are saying our interest is x union y complement. So elements which are not found in this set, but they are in the universal. So except 1, 2, and 3. So we're only going to remain with 4. Okay, we're just going to remain with 4. So now that we have both x complement as well as this, let's find the intersecting elements. So which elements are common in those two sets? So if you look at this, we have 4 there. We also got 4 in x complement. So it means that only 4 is common in these two sets. So now go ahead and check where 4 is. So 4 is outside these two sets, x and y. So how are you going to simplify this one further? So if you look at this 4 is outside x and y, which simply means that this can be x union y, then elements which are not found in x union y, so complement. So the final result, or simplifying that one further, the final result is going to be just x union y, then everything complement. So that is the final result. So you can see that using the Venn diagram, it's much easier to tell you the final result than just simplifying. Then, okay, so using that concept, you can answer this part. Just find x intersection y, also find x intersection y complement, then add. Then when you add, use the Venn diagram and see what is going to be the actual final result. So let me jump to part 3, which is saying we have x complement, then intersection y complement, and another complement outside. So for this one here, we have complements inside as well as outside. So in mathematics or in set theory, if you have got a complement there and the other complement inside, you are always supposed to multiply so that we can open these brackets. So remember that we have got x complement, so that is going to be x. So x complement multiplied by complement is just equal to x. So that is just going to be equal to x. So always when a complement is multiplied by elements inside the set or inside, whatever you have here is going to change. If it was union, it will be intersection. If it was intersection, it will be union. So now that we had intersection, this one now will change to union. The same will be true. Y is carrying a complement. Complement, that will be just y. So this will be x union y. So this is the final result. You cannot reduce this one further. So simply means just add elements in x as well as in y. So that's what this set is all about. So this is the final result. You would have simplified. So it's very simple. Then let me also deal with this part 5, which maybe it may confuse you. So let's go ahead we have x intersection y, then union open x minus y, then we have complement. So to answer this question, we are supposed to simplify, so we'll start by simplifying that part. So this is going to give us open x intersection y, then union open, this is x minus y, then we have a complement outside. So x minus y, that is the same as x intersection y complement. I've already explained how that is coming about. So this is now going to be open x intersection y, then union open x intersection y complement, then remember that we have another complement outside. So at this point on our next stage, this complement should multiply by everything inside. So we're going to say these brackets will be removed. So now we are going to just have x intersection y, then that complement will come here. So remember, when you're multiplying by a complement, this will change now. So it was union, it will now be intersection. Then this is going to be x intersection y complement, complement. So we can't have a complement inside and outside. There you are also supposed to simplify further. So here we are okay because we don't have a complement inside. So we can just bring this one down. That will be x intersection y, then complement intersection open. So now this complement is multiplied by everything inside. So this will give us x complement. Remember, this was intersection, so it will change to union. Y complement multiplied by complement, that is just y. So this is going to be equal to just y, like this. So now we'll not be very much sure if this is the final result. So what are we supposed to do at this point? Let's introduce the Venn diagram. So you have reached a point or at a stage where, let's say you have 2 over 4. If they tell you to say simplify this one further, you can't leave your answer there because there is a number which can go into 2 as well as in 4. So there you are supposed to use 2, that is going to be half. So this is the most simplified form. That's what they want to see. So at this stage we are not very much sure if we have reached at this point or maybe we are there. So there is still a step that we can take. So this is where now we are going to introduce the Venn diagram. So in the Venn diagram we just have two sets, x and y. So these x and y, they are intersecting. And then let's say this is universal, we have x and that is y. Then let's say elements, we have 1, 2, 3, 4. Okay, just like that. So now let's start listing the elements that we have. So let's start with x intersection y complement. So x intersection y complement simply means elements which are not found in the intersection. So we only have got 3 in the intersection. So every element which is not in the intersection, that is x intersection y complement. So this will be our final result. Also, let's answer this part. Then this is going to give us that one also demands us first to come up with x complement. So what is x complement? Elements which are not found in x but in the universal. So that is 1, 4. Okay. Then this one now union y. So let's add y there. So x complement union y. So when we add y there, we're going to have that is going to be 1, 1,4. Yeah, it will just be 1,4. So 1,4, this is the result for x complement union y. So what are we looking for? So what we are looking for now, we are looking for x intersection y complement, which is this set, union x complement union y. X complement union y. Okay, so union y will also have 3. I forgot that because we are adding, we are just adding. So 3 is in y. So 1, 3, and 4. That is going to be x complement union y. Then which elements are common in this set as well as in this set? So you can see that it's just 1 and 4. That is just 1 and 4. So we have 1 and 4 as our final result. Now let's check where is 1 and 4 in our set, in the set. So 1 is in the universal, whereas 4 is part of y. So if we are asked to shade, our final result was going to be like this. But now here we are being asked to just simplify. So simplifying this one, we cannot describe that shaded part because we have got an element in the universal set which is outside x and y, but this part is also taken up. Okay, so we're just going to say our final result will end there. But in a case, let's say this just gave us 1. If it just gave us 1, we are going to say that would have been x union y, then everything complement, this part outside there. But because we're including that, this will not be qualified, so we'll just leave it there. So that is going to be our final result to this is part 5. Then part 6 you can answer. So part 6 is already simplified. Just go ahead and answer this question. So you have x intersection y union x intersection y complements. Just simplify. After you simplify, then introduce the Venn diagram, then get to see what you are going to have as your final result. The same will be true with part 7. It's also already simplified. No need for you to stress. So just that here we have got 3 parts. So you have x intersection y union x intersection y complement, also union x complement union y. So for you to answer this question very well, you should do first treat 2. Okay, from there to here. So first find this, union that, so that this can give you a single set. So that when this gives you a single set, you are now going to add that. Then that is going to be your final result. So go ahead and answer that part. Then you can drop your solutions in the comment section. Okay, question 8. So question 8 is saying, express each of the following in the form of x over y, where x and y are integers and y is not equal to 0. So what you should know is that anything that can be expressed in the form of x over y, that is a rational number. Okay, that is a rational number. So rational number will be expressed in the form of x over y. Now in this case, x and y, these are coprimes. That is, they don't have a common factor. So a good example can be, let's say if you have 13 over 17. These two numbers do not have a common factor. So they are in this form. So this is an example of a rational number. So rational numbers are repeating and terminating. So they are repeating and non-terminating. So repeating and non-terminating, like, so a good example is going to be what we have here. So this is 2.2666. So these dots simply mean that 6 will keep on repeating. So that is non-terminating. Then sometimes instead of us showing those repeating, you are going to see something like a bar. So that bar simply means that the numbers which are covered under bar, those are the numbers which are repeating. So if on the second one, what is repeating is 3 and 5. Here it's 7. You can see that we have got a bar on just top of 7. So it means that it's just 7 which is repeating. Here 9 is repeating. So that is as good as saying 5.9 bar. So because 9 is repeating. Then for this one, you can see that the bar is on top of 4 and 1. So it is 4 and 1 which are repeating. So all these are rational numbers. Then we also have got what we call irrational numbers. So irrational numbers, these are non-repeating and non-terminating. So they don't repeat and they do not terminate. So good examples of irrational numbers can be, let's say, root 2, root 3, root 5, root 8, all these, also including pi. All these are non-repeating as well as non-terminating, so they do not qualify to be called rational numbers. And these cannot be expressed in the form of x over y. Okay? So here what we are dealing with rational numbers, because these can be expressed in the form of x over y. So that is what they want us to do here. So this first part, we have 2.1 2666. So you can see that 6 is repeating, so this is going to be 2.2, then 6, I'll put a bar on top of 6 because it's the one which is repeating. So I've changed this from that to this. Okay, you're going to do the same with part 5. So part 5, 9 is repeating, this will be 5 point, or part 4, 9 point, or 5.9, then the bar will be on top of 9, just like that. So now they want us to report this result. They should be in the form of x over y, not the way they are here. So how are we going to solve or to reach at that point? So what we do now is that since we have seen that 6 is repeating, the first thing will be to move this point to where the repeating number starts from. So for us to move this point, it means that we are supposed to multiply by 10. So that is going to be 10x will be equal to, when you multiply that one by 10, you're going to have 22.6 bar. Then the second step, now we have to move this point all the way up to the end. So how many steps are we going to move for us to get at the end? So that is will be 1, 2. So meaning that now we are supposed to multiply by 100. So 100x will be equal to, this one now is going to be 226.6 bar. So when this point moves all the way up to the end, this number become a whole number. Then after that, we are still going to add the number which is repeating. So 0.6 will still be there. The next, now we are just going to subtract. So here you can decide to subtract the way they are here. So meaning that you're going to work with negatives, even though the results will still be the same. Or you can rearrange. You start with the biggest number or the largest number, that is 100x, will be equal to 226.6 bar. Then now 10 will come down. 10x will be equal to 22.6 bar. Then you now subtract. So when you subtract, what are you going to have? 100 minus 10, that is going to be 90x. So 90x will be equal to 226 minus 22. That should be 204. The next you just divide by 90, divide by 90 here. So that x will be equal to a number that can go into 90 and 204. So 2 can go into 204 how many times? That would be 102 over 2 can go into 90 45 times. Do we have a number which can go into 102 as well as 45? I don't think so. So it means that this is going to be our final answer. So we have expressed the first question, the first part of the question in terms of x over y. So this is going to be the final answer. And you have to make sure that at the final step, there's no number which can go into the numerator as well as the denominator, because we are saying that these two should be co-primes, that is, they don't have a common factor. That is what defines a rational number. Then second, we have got 20.35. So this 20.35 bar, you can see that both 3 and 5, they are repeating. So meaning that here, in the first step, there's going to be no need for us to move the point. So meaning that what I was saying there, so this will be just x be equal to 20 the same thing, which is 35 bar. So there we don't have to move the point in the first place, because the repeating number, they are just after the point. Here we had the repeating numbers, we had a number before this repeating number. So we had to move a point in the first place. That's why we multiply by 10, but here there's no need. Next, now we are supposed to move this point all the way up to the end. So how many steps are we supposed to move? 1, 2. So meaning that now we are supposed to multiply by 100. So this is going to be 100x, which will be equal to 20 so it will no longer be 20 now. So this will be 2035, then 35 bar. Because when this point moves up to there, this become a single whole number. Then you just add the point, the repeating number. So that is what we had there. Then next we are going to subtract. So as usual, you can start with the largest number, 100x be equal to 2035.35 bar. Then we have x be equal to, that is going to be 20.35 bar. So why we add the repeating number at the end is to make sure that these repeating numbers, they cancel each other. So now after this, what we're going to have, 100x minus x. So that is going to give us 99x, which should be equal to, this is going to be 2035 minus 20. So 2035 minus 20, that is going to be, I think, 2015. So this is going to be 2015, if I'm not mistaken. Divide by 99, divide by 99. So x is going to be equal to, do we have a number which can go into 2015 as well as 99? Let's try 3, because we know that 3 can go into 99. So 3 into 20 can go there how many times? 6. Remainder 2. Into 21, 7. Then we have 5. So 3 can't go into 2015. So if there is, make sure that you look for a number which can go into these two. So I'm not finding that number, meaning that our final result is going to be 2015 over 99. But you are supposed to make sure that always there is no number which can go into these two, because we are saying that rational numbers do not have common factors. They are coprimes. So this is going to be the answer to that question. Then, so you're going to help me to answer part 4 as well as part 5. Okay, so this was supposed to be part 5. So you're going to help me to answer this one, I've already explained, as well as this one. So this one is similar to the first question which we had. Okay, so first we are supposed to move this point there. Then next you are going to move this point all the way up to the end. So meaning that at first you are going to multiply by 10, second you multiply by 1000 to move 3 steps. So let me handle this question. So this one, you can see that it's only 7 which is repeating, meaning that in the first place we are supposed to move this point how many steps? 1, 2, 3. So we're multiplying by what? That would be 1000. So 1000x will be equal to, this is now going to be 0016.7 bar. But you know that zeros before that, they are not counted as numbers. So that is the same as we have, this is the same as we just have 16.7 bar. So this is going to be 16.7 bar. Next, now we are supposed to move this point all the way up to the end. So that will be 1, 2, 3, 4. So now we are supposed to multiply by 10,000. So 10,000x be equal to, that will be, that one now will be 167.7 bar. The next you are going to subtract. So as usual, you can start with, let's say you start with the largest number, which is 10,000. X will be equal to 167.7 bar. Then we have 1000. 1000x be equal to 16.7 bar. Then let's subtract. So what is 10,000 minus 1000? 10,000 minus 1000, that is going to be 9,000, I'm sure. So that will be 9,000x will be equal to, then 167 minus 16, for these are going to cancel. So we have 167 minus 16, that will be 1, then that will be 5, so we have 151. 151 divided by 9,000 divided by 9,000. So we're getting x will be equal to, I don't know if we have a number which can go into 151 as well as 9,000. So if we don't have a number, it means this is going to be our final answer. So we have expressed it in the form of x over y. So this is now in that form. So we have achieved the goal to the question. So we have answered. So this is how you can answer these rational number questions. So help me to answer those two last parts. Then you can share your solution that you're going to find. Okay, so question 9, we have another very interesting question. So this is prove that the following are irrational numbers. So before we get into proving, let's first get to understand what irrational numbers are as well as rational numbers. So we have what we call rational numbers. Okay, So rational numbers, we also have got irrational numbers. So what is the difference between these two? Irrational numbers. So rational numbers, these are repeating and non-terminating numbers. They are repeating and non-terminating numbers. The good example is what we had on the previous question, which is question 8. Okay, so irrational numbers can be expressed in the form of x over y, where x and y do not have a common factor. So if two numbers do not have a common factor, it means they are co-primes. So x and y are co-primes where y is also not equal to 0. Why are we saying y should not be equal to 0? Because you know that a number divided by 0, this is undefined. So to make this one defined, we are going to make sure that the denominator is not equal to 0, but it can be any number. So any number that can be expressed in the form of x over y, that number is a rational number. So a good example can be, let's say if you have 3 over 2. So you can see that there is no common factor between 3 and a number that can go into 3 as well as 2 without leaving a remainder. So this is going to be what we call rational number. So if we divide here, you're going to find that if you decide to divide here, you're going to get decimals. And one thing you observe is that these decimals are going to come to an end. So that is what we mean by terminating. So rational numbers are terminating and repeating. They are terminating and repeating, so that sometimes they can be repeating numbers. Let's say you have 5.999, just like that. So 9 will keep on repeating. So this is also what? A rational number. So rational numbers can be expressed in the form of x over y, where x and y do not have a common factor and y is not equal to 0. What about irrational numbers? So irrational numbers, these are non-terminating and non-repeating. That is, there's nothing like, let's say you are going to get something which is let's say 5.33, then 555, like that. So they are non-repeating, meaning that no any number is repeating, but they are non-terminating. They do not come to an end. So numbers will just keep on exchanging. They do not come to an end. That is a irrational number. Then irrational numbers also can't be expressed in the form of x over y. They can't be expressed in this form. So good examples of irrational numbers is going to be, let's say, root of 2, root of 3, root of 5, and so on, including pi. So all these are non-repeating and non-terminating, hence they are irrational numbers. Okay, so this question here is telling us to say we have to prove that the following are irrational numbers. So we have to prove that this is a rational number, all these are irrational numbers. So I've given you this concept so that as we start proving, when you should be able to relate what we mean. So let's start. I'll start with the first part, which is saying we have to prove that root of 8 is a irrational number. So we are going to prove that root of 8 is a irrational number. So allow me to have space. So we have root of 8. So here you prove by contradiction. We are going to assume that root of 8 is a rational number. So you prove by contradiction. So you are going to say, taking an assumption, that is assuming that root of 8 is a rational number, okay, is a rational number. So what does a rational number mean? So if root of 8 is a rational number, it means that it can be expressed in the form of x over y, the form of x over y. So where we are saying y is not equal to 0, and also x and y are co-primes. Co-primes. So what does co-prime mean? They are co-primes. So co-prime simply means that those two numbers do not have a common factor. X and y do not have a common factor. So we are proving that by contradiction. So we are assuming that root root of 8 is a rational number. So if root of 8 is a rational number, then it can be expressed in the form of x over y, where y is not equal to 0 and x and y are coprime, that is, they do not have a common factor. So what does this mean? What it means is that root of 8 can be expressed in the form of x over y, something like this. So after this, now you have to get rid of that root there. So for us to get rid of the root, what are you supposed to do? You are supposed to square both sides. So when you square both sides, you are going to get 8 will be equal to x squared over y squared. So you're going to get x squared over y squared, like this. If you solve this one further, you're going to find that you're going to have 8y squared will be equal to x squared. 8y squared will be equal to x squared. So let's call this as equation 1. What does this mean? So what it means here is that you can see that since we have got 8y squared there and we have got x squared this side, for us to find y, we can just divide both sides by 8. So that is going to give us y squared will be equal to x squared over 8. So what does this mean? What this means is that x squared is divisible by 8. So what it means there is that x squared is divisible by 8, meaning that divisible by 8, meaning that 8 can go into x squared, because that's what this means. It's in that form. So for the fact that you know to say that if you have got an even number, let's say 25. Let's say 25. So 25 is 25 is not an even number. Okay. If you have got an even number, if you square an even number, you are going to get an even number again. So let's say we have 4. If we square 4, we are going to get 16. 16 is an even number as well. So what does this statement mean? Remember that we want to have something like that, x over y. So x squared is divisible by 8, because this is what it means. So if x squared is divisible by 8, what it means there is that 8 can also go into x. So meaning that x is also divisible by 8. Divisible by 8, meaning that 8 can also go into x. In other words, what are we saying? What we are saying there is that let's say if we have a number, let's say we square 64. So what is going to be 64 squared? So 64 squared, that is going to be, I think it will be a very big number. I just want us to understand. So 64 by 64, I'm getting 40,096, or I'm getting 4096. So remember, if you consider this statement, we are saying that in that case, if we have 64 squared over 8, so we have 64 squared divided by 8. So 8 can go into 4096. What it means there? Can go into 4096. Okay. Then 8 can also go into what? Into 64. In other words, what that means 64 squared, it means that you have 64 multiplied by 64 divided by 8. So this 8 can go into 64, as well as 8 can also go into, when you square this 64. So that's why here we are saying that x squared is divisible by 8 following this statement. So if x squared is divisible by 8, it means that 8 can also go into x. So we have this statement there. Okay, so we have that statement there. So next, after this now, since now we know that x has got a common factor which is 8. X has got a common factor which is 8. Let's now also check if y has got a common factor. So at this point, we're going to let x be equal to a particular letter. So we're going to say let's say x x meaning that x can be obtained by multiplying x multiplied by 8, let's say k, where this k is any constant. So k can be any constant. K is a constant. Okay, k is a constant. So now where there is x, we are going to put 8k. Why am I doing this? Is because we want now to check if y also has got a common factor, because we know that x has got a common factor. So what we're going to do is that in equation 1, where there's x, we put what? Where there's x, we're going to put 8k, because that's what x is now. So this is not complicated. If you are proving that, let's say you are proving root 3 is irrational, it means here it's going to be 3k, or you can decide this to be anything apart from that letter which you are using. Let's say even c. If you are proving root 5, at this point it's going to be what? 5k. That is what is going to be. So we're going to have that. Then in equation 1, where there's x now, we put what? 8k, so that we check if y also has got a common factor. So I'll go ahead and solve that one. So using equation 1, we have 8y squared will be equal to, now x is 8k, so we're going to say 8k, but x is squared, so I'll also square this. Then what do we have? So this will be 8y squared will be equal to, when you square 8, you're going to have 64, that will be k squared. Then you can divide both sides by 8, you can also divide this side by 8. So what do we have? So what we have now, we have y equal to, so what we have now, we have y squared equal to, that is going to be 8k squared. So this is equation 2. Okay, this is equation 2. So if you check this equation 2, it has taken us where? We are here again. Okay, we are at this point again. So what does this mean? So what it means is that what it means here is that 8 is a common factor. So you can decide to divide by 8 this side, also divide by 8 this side. That is going to give you k squared will be equal to y squared over 8. So what does this mean? This is the same as this. So we have y squared divided by 8. So the implication of that is that so we have k squared equal to y squared divided by 8. So this also implies that, remember that this is our equation 2. So this implies that y squared is divisible by 8. So y squared is divisible by 8. So if y squared is divisible by 8, it also means that y is divisible by 8. Y is also divisible by 8. So y can go into y squared, 8 can go into y squared, as well as 8 can also go into y. That is the same as if you have 16 squared. 16 squared then divided by 4. That will be 16 multiplied by 16 divided by 4. So 16 can go into y squared like that, or 4 can go into 16 squared, but 4 can also go into 16. So that is what we have done there. That is the concept behind. So now if you look at this, this is a contradiction. You can see that both x and y, they are divisible by what? 8. So now we are going to say x is also divisible by 8. So this is a contradiction. Earlier we assumed that root 8 was a rational number. So if root 8 was a rational number, it means it would have been expressed in the form of x over y, where x and y do not have a common factor. But what is our conclusion? Our conclusion is contradicting with our earlier assumption, because we can say that x has got a common factor 8, then y also has got a common factor 8. So this is what? A contradiction. So what does this mean? So what conclusion are you going to make now? So our earlier assumption, okay, based on this, we are going to say the assumption that the assumption that we made, the assumption that root 8 is rational is wrong. The assumption that root 8 is rational is wrong. Why? So the reason is because x and y have got a common factor. Because x and y have a common factor, which is 8. Have a common factor of 8. So if root 8 was irrational, we are not expecting x and y to have a common factor. So for the fact that x and y, they have got a common factor, which is 8, it means that our area assumption that this was a rational number is false. So therefore, root of 8 is indeed what? Is irrational. It can't be irrational because rational numbers do not have a common factor. So what we have found here is that both x and y, they have got a common factor, which is 8. Hence, our assumption was false. So it contradicts with our area assumption. X and y were not supposed to have a common factor. For the fact that we are finding that x and y, they have got a common factor of 8, it means that the assumption that root of 8 is rational is false. So therefore, because it is false, it means that indeed root of 8 is what? Irrational. So this is how you can prove using contradiction method. So you can prove anything now. When I give you root 2, the approach will be the same. Root 8, which we have proved. Then root of 3, so you can go ahead and try to prove this. But then, okay, you can go ahead and try out to prove those. So you can help me to prove this one. Then as well as this. So maybe I should try to prove that one. So for this one, which is the third one, what we are going to do, you can see that we have got 3 of those. So we have root of 2 plus root of 18, then plus root of 5. So here to be maybe difficult for you to prove. So what we are going to do is this one can be simplified. Root of 18 is the same as root of 18 will be the same as root of 9 multiplied by 2. So that will be the same as root of 9 multiplied by root of 2, which should be equal to 3 root of 2. So we are then going to say that is we have root of 2 plus 3 root of 2 then plus root of 5. So you can see that these ones now are like terms. So that is going to give us 4 root of 2 plus root of 5, like this. So you can now go ahead and prove that this one is irrational. So you still prove by contradiction. So between this one and that one, I'm going to answer one. Then you help me to answer one. These are going to be a bit different because we have 2 different roots in the same equation. They are different from these direct ones. So the method that we have used, that one will only apply like at a point where we had to let. That will only apply if you have a single thing like that. So let's see how we can also prove by contradiction that part 2 and part this other part. So which one should I pick? Which one should I pick? So let me go with that one. So we have root of 3. I think I'll need space. Okay, so we have to prove that root of 3 divided by, that was negative 1. Negative 1 minus root of 2 is irrational. So minus root of 2, we have to prove that this is irrational. So it's still proved by contradiction. So we're going to assume that one, that number as a rational. So we're going to say assuming so we're going to say assuming that everything root of 3 over minus 1 minus root of 2 is rational. is rational. So it means that this number can be expressed in the form of what? X over y. Here it doesn't matter. You can use A over B, you can use P over Q, okay? Anything you can use, okay? Depending with which one you're comfortable with. So it means that it can be expressed, so I'll stick to X and Y. So it means that that one can be expressed in this form, where then we are saying where y is not equal to 0, then x and y have no common factor, meaning that they are coprimes, have no common factor, Then what does this mean? So what it means here is that root of 3 over minus 1 minus root of 2 will be equal to x over y. Next step, you are going to cross multiply because this is an equation. So you are going to get negative x minus x, then root of 2, which will be equal to y root of 3. So at this point now, you are going to square both sides. So this will be a bit, we want to get rid of a root. So we're going to square this side as well as this side. So that will give us negative x, open, negative x minus x root of 2. Then we also have negative x root of 2 multiplied by, this will be very, very long. So negative x minus x root of 2, then equal to, okay, remember we are squaring both sides, equal to, so this other side we're going to have y squared multiplied by 3. So 3 will be here. Root of 3 squared, or root of 2 squared, like this is equal to 2, because this and that will cancel. So that is what has happened there to root of 3 squared. So from there, okay, from there now we are going to have okay, now let's answer part B. So part B is saying, given that we have root 8 plus 1 over root of 16 minus 1 be equal to a root of 2 minus b, where, so they're saying where a and b are integers, find the values of a and b. So we should find the value of a as well as the value of b. So now we can simplify. You know that root of 16, so root of 16 is equal to 4. Then this root of 8 is the same as root of 4 multiplied by 2. So that will be the same as root of 4 multiplied by root 2, which is going to be to give us 2 root of 2. So now we're going to say on the numerator we have 2 root of 2, then plus 1, divided by 16 squared, that is 4, so we have 4 minus 1, equal to, we have a root of 2 minus b. So 4 minus 1, that is 3, so this will give us 2 root of 2 plus 1, divided by 3, equal to, we have a root of 2 minus b. So you can cross multiply, because this is an equation. So when you cross multiply, what are you going to have? So cross multiplying here, we are going to have 2 root of 2 plus 1 will be equal to, that will be 3a root of 2 minus 3b. So when you reach at this point, you are going to equate. So you are going to equate members which are the same. So this one has got a root. We also got this side here. So the two sides we're going to say they should be equal to each other. So the first one we're going to say 2 root of 2, this one should be equal to 3a root of 2. That is the equation 1. The other one, we have a constant here, should be equated to a Ferrel constant that side. So we have 1 will be equal to negative 3b. So you can say negative 3, negative 3. So it means that the value of b will be equal to negative 1 over 3. We have answered that one. Then for this other part, you're going to divide both sides by 3 root of 2. You also divide this side by 3 root of 2. So this and this will cancel, this and that will also cancel. We'll have a will be equal to root of 2 cancel with root of 2, thereby leaving us on with 2 over 3. So a is equals to 2 over 3, b is equals to negative 1 over 3. If you want, you can confirm. If you want, you can confirm. So let's try to prove. So we said root 8 is 2, okay, 2 root 2 plus 1 over, down here we obtain the 3. Let's see if this side we can obtain the same. So we're saying that a is, where there's a, we put 2 over 3, then root of 2 minus b is negative 1 over 3, like this. So we are going to have 2 root 2 over 3, then this will be plus 1 over 3. So common there is going to be 3. 3 into 3, you have 2 root 2 plus 3 into 3, 1, multiplied by 1, it's 1. So you can see that this part is the same as that. So indeed it's correct. Then part C. So part C, we have given that, given that beta will be equal to, so we have beta equal to 8 plus root of 147. Express beta plus 1 over beta in the form of, so they want our final answer to come out to be in that form, where a and b are constants and they are rational numbers. So when we say a and b are rational numbers, a, b, and c are rational numbers, it means that they can be expressed in the form of x over y, where y is not equal to 0. So it's possible you can find something like, let's say even what we had, negative 1 over 3, then 2 over 3. You can have this constant in those fraction forms. That's what it means there. So since we know that beta is 8 plus root of 147, so what we're going to do is that we want to find beta plus 1 over beta. So where there is beta, we're going to put this. Let's go ahead and do that. So we are going to have 8 minus or plus root of 147, then plus 1 over 8 plus 147, everything, because beta is everything. So what we have at this point is a fraction that we are adding, remember? So we have to find a common factor. So what is going to be the common factor of these two? So the common factor is going to be this one, because this whole thing is over 1. Okay? So that is going to be, so I'm going to say we have 8 plus root of 147 here. So 1 into this, we're going to get the same, multiplied by that, so it means that we're going to have 8, we're going to have this squared. So if we have this squared, that is going to be 8 plus root of 147, then cross plus root of 147 open, 8 plus root of 147, okay, something like this, then plus this into that, it's 1 multiplied by 1, we're still going to obtain 1. Or maybe you're confused on how I've obtained this part here. What it means is since we had over 1 here, 1 into our denominator, we obtained the same. So what that meant was that 8 plus root of 8 multiplied by 8 plus root of 8. So we are supposed to have this, okay, then multiplied by the same 8 plus root of 147. So when you expand this, you are going to get what I have here. That's what I've done. Okay, so now let's go ahead and simplify. Let's go ahead and simplify. So simplifying this one, we're going to have 8 by 8, that will be 64, then plus, that will be 8 root of 147, then plus another 8 root of 147, then root of 147 multiplied by root of 147, that is going to be root of 147 squared, thereby only leaving us with a 147. Then everything divided by 8 plus root of 147. Then we can collect like terms. So you can see that these are adding, so we can add. Then these are also constant, we can add as well. So what is going to be 64? What is going to be 64 plus 147? So plus 64, that is 221. So which means that we are going to have 221 plus, if you add those two, you are going to get 16 root of 147 over, then what we have here, 8 plus root of 147. That is what we're going to have. But now remember, they want our final answer to be in this form, not what we have there. If we check there, we are not supposed to have a radical as a denominator there. So we have to find a way on how we can get rid of that. So we are supposed to take another step, that is, we're going to conjugate the denominator. So how should we go about that? So we have 221 plus root of, so we have 221 plus, I think that is 16 root of 147. So 16 root of 147. This is dividing by 8 plus root of 147. Okay? Yes. So now what we are going to do is we are going to conjugate. So conjugating, you are going to multiply everything by the opposite of this. So the opposite of the denominator, our denominator is going to be 8 minus root of 147. Then what you have done on the numerator, do the same on the denominator. So 8 minus root of 147, like that. Then now you start multiplying this, multiplied by whatever we have here. So what are we going to have? What we're going to obtain after that, we're going to obtain 221 multiplied by 8. Allow me to do that in advance because this question is so lengthy. So we have 221 multiplied by this 221 multiplied by 8 in the first place. So we are obtaining 1768. So that is 1768. Then minus this 221 multiplied by root of 147. We're going to get the same 221 root of 147. Then now we come to this root of 16 multiplied by 8. That is 16 multiplied by 8 root of 47. So 16 multiplied by 8, we are obtaining 128. So that is going to be plus 128 root of 147. Then lastly we have this multiplied by that, which is going to be negative 16. Okay, so we are going to have this squared. So when you square that, you're just going to have 147, like that. Okay, divide by. So remember, on the denominator, we are multiplying conjugates. So if you are multiplying conjugates, we have 8 plus root of 147. This is multiplying by its opposite, 8 minus root of 147. So instead of expanding when you're multiplying conjugates, you are allowed to say this 8 should go with its fellow 8. This sign should go with its fellow sign. Then this one should also go with its friend. That is going to be your final result. Because if you expand this, the elements in between are going to give you 0. So that is what we're going to do. So 8 multiplied by 8, that is going to give us 64. So we're going to have 64. Then positive multiplied by negative, that is going to give us what? Negative. Then root of 147 multiplied by root of 147, that will be root of 147 squared, which is just going to give us 147. So you can see that now at least we are heading there. We have gotten rid of a root on the denominator. That is how our answer should come out to be. So what is now going to be 16 multiplied by 147, so that we correct like terms together, we add it to this. These two are also like terms, so we are also going to add them. So that is going to be, we have 16 multiplied by 147, so I'm getting 2352. So that is, we have 1768, that will be minus 2352. Then what is now going to be these like terms? So what you are supposed to do, you are just supposed to consider these numbers in front, then you just add that. So what is the negative 121, negative 121 or 221, 221 minus or plus 128? That is going to be negative 93. So I'm getting negative 93 root of 147. Then everything over 64 minus 147. So I'm also getting negative 83. Okay. So then now let's subtract. What is going to be 1768? 1768 minus 2352. 2352. So that is negative 584. Then minus, this has no like terms, root 93 root of 147. Divide everything by negative 83. So remember that our answer should be in a form of a plus b root of c. That is what they want our answer to be. So upon reaching this, we are going to split. Okay, so that this is the same as negative 584 divided by negative 83, then minus 93 root of 147, also divide this one by negative 83. So what we are going to discover is that negative into negative is positive. So this is going to leave us with 584 divided by 83. Then also this negative, that will be positive. So this will be plus 93 over 83 root of 147. So remember that the condition was where a, b, and c are rational numbers. So earlier I mentioned to say that, meaning that these constants can exist as fractions. So if you look at what we have obtained here, do we have a number which can go into 584 as well as 83? I don't think so, because 83 is a prime number. So meaning that we don't have a number that can go into these two. The same will be true with this one. We don't have a number apart from 1 which can go into 93 as well as 83. So it means these are our final solution. This is the final solution. So what it means in this case is that our A is this first part, which is 584 divided by 83. Then our B, which has to be attached to a root, is this part, 93 divided by 83. Then finally, root of C, our C is 147. So hence we have answered this question. So that's how you answer questions involving these roots. Okay, question 10, which is saying a function f from a to a, where a is the set of positive integers, is given by f of x be equal to the sum of all possible divisors of x. So find the values of f34. So let's start with f34. So we are saying that this one should be equal to all the sum of all possible divisors. So let's first find the divisors of 34. So the numbers that can go into 34 without leaving a remainder, those are the divisors of 34. This will be equal to, so 1 can go into 34, 2 can also go into 34. After this, I think it's 17, then last will be 34 itself. So if you have missed any divisor of 34, it means my result is not going to be correct. So make sure that you take up all the possible divisors of that number. So let's say this is what we have. So we are going to say this will be equal to, now add, because they are saying sum of all these numbers. So that will be 1, then plus 2, plus 17, plus 34. So what are we going to get? So we're going to say f34 will be equal to, that is 1 plus 2 plus 17, then plus 34 itself. So I'm getting 54. So it means that f34 is equal to 54. That is the answer. You just follow that condition there. Then 120. So take up all the possible divisors of 120. So me, you answer this one for me. Then I'll go to f33 or f83. So this is going to be equal to what are the possible factors of possible divisors of 83? So 83, this is a prime number. So a prime number is only divisible by 1 and itself under 83. So it means that this is just going to be equal to 1 plus 84. So this will be 1 plus 84. So what are we going to get? So we're getting 85. So it means that if 83, no, this is supposed to be 83. So 83 plus 1, that is going to be 84. So the final result is just 84. That's it. It's very easy and straightforward. Then part B is saying show that. So now we are supposed to show that f of 14 is the same as f of 15. Okay, so the two sides are the same. Let's show. So f14, what are we going to have? So possible factors of 14, we have 1, then we have 2, we have 7, and 14 itself. So this side we're going to have 1 plus 2 plus 7 plus 14. Okay, so we're saying that this should be the same as, what are the divisors of 15? So 15 will be equal to 1, 3, 5, and 15 itself. So this side we're going to have 1 plus 3 plus 5 plus 15. Let's add. So this side we have 1 plus 2, 1 plus 2 plus 7 plus 14. That is 24. So I'm getting 24 this side. Is it the same as, if we add, that is going to be 1 plus 3 plus 5 plus 15. So I'm getting another 24. So it is indeed true. So we have shown that F14 is the same as F15. Then another question is show that another question is going to be this one. So that's saying show that F3 multiplied by F5 is the same as F15. So the two sides should come out to be the same. So let's start with F3. So 3 is also a prime number. So this is going to be just 1 and 3 itself. Then 5 is also a prime number. That is 1 and 5 itself. So this simply means that we're going to have 1 plus 3 multiplied by 1 plus 5. Is it going to be the same as, what are the divisors of 15? So 15, this is going to be 1 plus 3 plus 5 plus 15 itself. So here we have 1 plus 3, that is going to be 4. So 4 multiplied by 1 plus 5, that is 6. This side we have 1 plus 3 plus 5 plus 15. And the two sides are going to be the same. So 4 multiplied by 6, that is 24. So this will be 24. This is going to be the same as, that will be 1 plus 3 plus 5 plus 15. Yes, so I'm getting a 24. So hence we have shown that this side is equal to that. So this is how you can answer this question. Question 11. So this must be something like general knowledge. So let A be the set of positive integers greater than 3, and B be the set of all positive integers. So of A and B. And let D such that A is equivalent to B be the function given by, so this is the formula, where, okay, that is the formula. So we are saying which represents the number of diagonals of a polygon with m sides. So this m simply representing the number of sides. Okay, so this is the formula that we're going to use. So the first one is saying find D6. So here you can see that the formula is defined by dm. So meaning that we are saying that m is representing the number of sides. So if we say find dm, simply just replace where there is m, put 6. So we're going to say dm Okay, so now m is 6, so we're going to say this6 will be equal to negative 3, where there's m, you put 6, then plus 6, you square m, everything divided by 2. This will be equal to negative 3 multiplied by 6, that is negative 18. Then plus 6 squared, that is 36. So everything divided by 2. What is negative 18 plus 36? That is going to be positive 18. Positive 18 by 2. So d6, this is going to be equal to 9. So 9, that is the answer. Then you do the same with 10 as well as 8 and 12. Where there's m, just put this number, then calculate. So what you're going to find, that is going to be your final result, because you're just following that formula. So you're just following that formula. Then what about the second part, which is part B? So part B is saying, how many diagonals will a polygon with 20 sides have? So how many diagonals will a polygon with 20 sides have? So now if you understand this question, remember that we are using this formula. What is m representing? M is representing the number of sides. So we're saying that this one now has got 20 sides. So how many polygons or how many diagonals is it going to have? So in this case now, it means we are calculating for this one. What we have that. So what are we going to say? So here we're going to say, in that formula, m is now going to be 20 with 20 sides, because we said m is representing what? Number of sides. So the sides are 20. So where there is m, you are going to put the 20. But what we don't have is this one, the total number of diagonals which this polygon is going to have. So now we're going to denote, let's say this is x, unknown. You can put anything there. So we're going to say x will be equal to negative 3 multiplied by m. M is representing the number of sides, which is going to be 20. Then plus 20 squared, everything divided by 2. So you can see that this is an equation, there is an equal sign there. So you are allowed to cross multiply here. So this is going to be 2x will be equal to negative 3 multiplied by 20, that is going to be negative 60. Then plus 20 squared, that must be 400. So when you add negative 60 plus 400, what are you getting? So this will be 2x will be equal to negative 60 plus 400. This has to be something like 340, if I'm not mistaken. You divide by 2, you divide by 2. So x will be equal to 3 into, or 2 into 3, 1 into 14, 7. So this is going to be 170. So how many diagonals will a polygon with 20 sides is it going to have? So it will have 170 diagonals. So this is the final answer. So it will have 170 diagonals. Okay, that will be it. So we are just calculating for this unknown. Previously we are being given this m, so we are calculating for that. So this is how you can also answer this question 11. That's why I said here it's more like you're using general knowledge. It's because you have been given the formula, but again the condition was a be the positive integer greater than 3. So meaning that the result that you are supposed to be obtaining should be greater than 3. And for you, if you observed here, all the results that you're going to obtain will be positive and greater than 3. So that's it for this question 11. Question 12, which reads, find the domain, the range, and the inverse of each of the following functions. So for each of these functions, we have to find all these 3 stuffs for each single question. So when we talk about the domain we are talking about the x values. What values of x are going to make a particular function defined? That's the domain. Then when we talk about the range, here we are talking about the y values. What values of x are going to make a particular function defined? Then when we talk about the inverse, this is just the reverse of the function that you have. So we have question 1, which is saying g of x equal to, we have x plus 9 over 5. So this function that we have here, this is in a fraction form. So when you have a function in a fraction form, what you are trying to avoid is you are trying to avoid on the denominator to be 0. Not you are trying to avoid the denominator to be 0. When you have a situation where you have, let's say, a constant over 0, this is undefined. Let's say you have 1 over 0. This is undefined. When you punch on a calculator, the calculator will tell you to say math error. Okay? Or those advanced ones, they will tell you to say undefined, meaning that it does not exist. Then also when you get a situation where you have 0 over 0, 0 into 0 is also undefined. So we're trying to say what values of x do you need for this particular function to be defined. So what we are saying in this case, if you have a function in a fraction form, only the denominator should not be 0, but it can be any number. So any number that can which we can put as the denominator there except 0 is going to make the function defined. So in that case, if you have a function, a function in a form of, let me pick this one, where we have f of x be equal to 1 over x minus 1. So we're saying that the number that are going to make this function defined is any number except from a number that is going to make the denominator to be 0. So how are we going to find that number which is going to make this denominator to be 0? So we are just supposed to equate the denominator not equal to 0. So we are going to say what you have as the denominator, which is x minus 1, should not be equal to 0. Then you solve for x. So x should not be equal to 1. So meaning that for this function, we are going to say the domain is going to be x is such that it's a member of real number, but x should not be equal to that number, which is 1. So what we mean by this is that we are saying that x can be any number there. When we say x is a member of real number, you know that real numbers, they run from negative infinity all the way to positive infinity. So we're saying that it can be any number from the set of real numbers except from negative 1 or except from positive 1. Why it shouldn't be 1 is because when you put 1 here, you are going to have a situation where you have 1 over, that is going to be 1 minus 1. So this will give you 1 over 0. So we said a number divided by 0, it's undefined. Whereby, if you pick any number, let's say negative 4, so we're going to have 1 over negative 4. This is defined. If you pick 8, you have 1 over 8 minus 1. Okay? So 1 over 7. This is also what? Defined. So that is what we mean. That is what you are supposed to do when you have a function in a fraction form. So equate the denominator not equal to 0, then solve for x. That is if there is need. Okay? So in this case, I've answered part B, but again, also there are 2 B's here. I think there was a mistake. This was supposed to be D. Even there are also 2 A's, but anyway. So, I've answered this question. So we're saying that the domain is such that x is a member of real number, but x should not be equal to 1. But again, to satisfy this question, they are saying that for x should be any number greater than 1. X should be any number greater than 1. So to satisfy that, now we are going to say the domain is going to be equal to x is a member of a real number such that x should be greater than 1. So here it means that when we say greater than 1, it means that 1 is not included. So if you are to report this in interval notation, you are going to say the domain is going to be equal to 1 not included all the way to positive infinity. This is in a case where we have been given this condition. So we are saying that x values should only be numbers which are greater than 1. So it means that we are not going to include numbers which are less than 1. So this will not be the domain for that question. The domain for that question is going to be this one in red, or you can report it in interval notation, this one down here, just because of the condition that we are given. If this condition was not there, the answer was going to be this one here. So we have answered for the domain. So those are the x values. Now what about the range? So for the range, there are two ways that you can use. One of them is by sketching this. When you sketch, you are going to see the minimum values of that y can take and the maximum value of y, or just take the inverse of this function. Then when you take the inverse, you are going to find the domain of the inverse, that is the range. So since in this case we have also been asked to find the inverse, it would be better off we use the inverse way, we go the inverse way. So to find the inverse of this, we are going to say y be equal to 1 over x minus 1, x minus 1. So when you want to find the inverse, the goal is to make x the subject of formula. So here we're going to cross multiply. That is going to give us xy minus y will be equal to 1. You take y on the other side, so we're going to have 1 plus y. Then you divide both sides by y. You also divide this side by y. So what do we have? So we have y be equal to 1 plus y over y. So now then we are going to say f inverse of x will be equal to, where there is y now you change to x, so 1 plus x over x. So this is the inverse. Now that we have the inverse, we can find the range. So I said that range are y values, but you are just going to find the domain of this function. The domain of the inverse, that is the range. So the domain for this one, you can see that we have a situation where we have a function in a fraction form. So in this case, we are trying to avoid the denominator not to be equal to 0. So what are we going to say? So we're going to say x should not be equal to 0. Here there's no need of solving it straightforward. So it means that x should not be equal to 0. But remember, we are dealing with y. Oh, we are dealing with the range. So range can be x. So this has just helped us to find the domain or the inverse. Then now change this to y, because range, these are y values. So we're going to say y should not be equal to 0. But what does this mean? It means that it can be any number except from 0 itself. So then we're going to say the range of this function is going to be equal to, because we're finding the range, we are going to say y should be a member of real number, but x, for y should not be equal to 0. So this is the range. You can see that here now there's no condition. That is why our range is going to be like this. For the domain, there was a condition that x was supposed to be greater than -1, meaning that the accepted number there should only be numbers which are positives greater than 1. That is why we had the domain in that form. So our range is going to be this for that question. Then, so having understood this, I do believe that you can answer these two here. So if you look at this, our attention is where x is. So between the first and second one, I'll pick one. So let's say I pick, even though they are the same, so if I pick the second one, f of x be equal to x minus 3 over 2. So in this case, what number is going to make this function defined? That is, what number can you put at x, then it's going to make this function to be undefined. By being undefined, we are saying, in what situation are you going to get, let's say, a number over 0, also 0 over 0. So here there is no number that is going to give us any of these two conditions. Why am I saying so? It's because we have x on the numerator and not on the denominator. So in this case, there's nothing to worry about, because the denominator is a constant 2. So for the fact that 2 is already defined, this function, any number that you can put at x is going to make this function defined. If this denominator was, let's say, 2 minus x, you were going to solve for x here and say 2 minus x should not be equal to 0. Then you are going to say 2 minus x, or negative x, should not be equal to negative 2. You divide by negative 1, then you are going to say x should not be equal to 2. But in this case, we just have a constant, so a constant, you can't solve a constant on the denominator. So it means that here there's nothing to worry about. So the domain is going to be all real numbers. So we're going to say domain will be equal to all real numbers. If you want to report this in interval notation, you're going to say the domain is equal to negative infinity all the way to positive infinity. Okay? Or if you want it to report it in set builder notation, you're going to say x is a member of a real number. It ends there. It can be any number. It's going to make this function defined. So be it negative number, be it 0, be it positive number, any number, this function will still be defined. If x is 0, we're going to have 0 minus 3, that will be negative 3 over 2. This is defined. If x is negative 1, we're going to have negative 4 over 2. 2 into negative 4, that is negative 2. So that is still what? Defined. So the same will be true with the first one, which is saying g of x should be equal to x plus 9 over 5. So here also there's nothing to worry about because you just have x on the numerator and not on the denominator. So that is going to be it. Then what is going to be the inverse as well as the range? So let's start by finding the inverse because it's going to help us to find the range. So then we're going to say y be equal to x minus 3 over 2. You cross multiply, you have x minus 3 be equal to, this will be 2y. You take 3 on the other side, we have 2y plus 3. So this is going to be the inverse. Then we're going to say f inverse of x is equal to, where there's x you substitute, where there's y you substitute back with x. So 2x plus 3. If you look at this function, this is now a linear function. So the domain and range of any linear function is all real numbers. So here then we're going to say the range is going to be equal to negative infinity all the way to positive infinity. Or you can say the range is y is such that y is a member of a real number, meaning that it can be any number. So what you should know is that the domain and range of any linear function is always all real numbers. A linear function is a function where you don't have a root. It's just let's say even a quadratic function or a polynomial. All those are examples of linear function. So the domain of any linear function is all real numbers because you can put any number at x. There's no situation which is going to make that particular function to be undefined. So that is the inverse answering this part. Then this is the range answering that part. The domain we already found. So this is how you handle questions involving what? Functions involving fractions. So then we move on now to the other part, which is going to be now let's deal with a situation where you have so this is a cube root. So before I handle the cube root, let me just handle a square root. So if you have a function, let's say f of x be equal to, you have a root of anything inside the bracket. Let's say root of x minus 1. So in this case, what numbers are going to make a root be defined? So you know that a root is only defined for x should be greater than or equal to 0. In other words, we are saying that a root can only accept positive numbers. A negative number in a root is going to be undefined. So numbers starting from 0 all the way to positive infinity are the only numbers which are acceptable in the root. Okay? So here what you are going to do is you are supposed to equate or get what is inside the root, equate it to greater than or equal to 0, then solve for x. So then here we're going to say x minus 1 should be greater than or equal to 0. You solve for x, you're going to have x is greater than or equal to 1. Okay, so what does this mean? So it means that the domain is going to be equal to, you can see that we are saying greater than or equal to 1, so meaning that 1 is included, so it's going to be from 1 all the way to positive infinity. That is, you can get any number starting from 1 up to positive infinity. Anything is going to make this function defined. So if you have a radical function, what you're supposed to do is get what you have inside the bracket, then equate it to greater than or equal to 0, then solve for x. So if you have root of x, the domain on this one is going to be, just say x should be greater than or equal to 0. So it means that starting from 0 all the way to what? To positive infinity. That is, try to get any number. I've come back to this question. Try to get any number which is less than, let's say, less than this one. You're going to find that you're going to get a number, we are going to get a negative result in a root. Let's say we get 0. If x is 0, we're going to have 0 minus 1. That is negative 1. Root of negative 1 is undefined. So in a root you are trying to avoid to get a negative number. That's why we are equating to greater than or equal to 0. Then you solve for x. That is going to be your domain. Okay? So this only applies when you have a root. Then here we have here we have a cube root. So what is numbers are going to be defined in a function, in a cubic function. So we have cube root of x minus 1. A cube root, what it means is that you're looking for a number that you can multiply 3 times to get the result. So let's say if I give you cube root of negative 8 as well as cube root of positive 8. We are saying what number can you multiply 3 times to get what you have inside there. That's the meaning of a cube root. So the cube root of negative 8 is negative 2. When you multiply negative 2 3 times, you are going to get negative 8. What about positive 8? So this is going to be positive 2. You can multiply 2 3 times, you get positive 8. So what can we see from there? What we see is that a cubic function is defined for any number. So a cubic function can take up negative numbers in a cubic, it can take up negative numbers as well as positive numbers, including 0. So cube root of 0, it's 0 itself. You can multiply 0 3 times, you'll get what? You still get 0. That is the meaning of a cube root. So what we have here, it means that this function is defined for any number. So a cubic function is defined for any number. Therefore, it means that the domain is going to be all real numbers. The domain is going to be all real numbers. If you want to report this in interval notation, you're going to say from negative infinity all the way to what? Positive infinity. So infinity, we don't use this symbol. We always use open, these open symbols. Always when you have an infinity, you don't use included symbol, no. You use that open symbol. So that's what we're going to have there. So it can be, x can be any number. This function will still be defined because you can have a negative, a cube root of a negative number, a cube root of a positive number. Anything will still be defined. So let's find the inverse, then later on you can find the range. So the inverse, we are going to say y be equal to cube root of x minus 1. Then the goal is to make x the subject formula. So here we are supposed to take a cube root on both sides. Why are we doing this? It's because we want this and that to cancel. So it means we are now going to have cube root of y cube equal to, we just remain with what we have inside. So x minus 1. You take 1 the other side, we have y cube, this will be plus 1 equal to x. Now it means that the inverse we have, so it was g of x. So we're going to have g inverse of x will be equal to x cubed plus 1. So you change this one y back to x. So this is the inverse of this function. Okay, so it means that we have answered this part. Now let's answer what is the range of this function. If you look at this function, I said for you to find the inverse, the range, you are just supposed to find the domain of the inverse. That is going to be your range. But don't forget, range, you are talking about y values, so don't use x, you are going to use y instead of x. So if you look at this, this is a linear function. So we said that any linear function is all real numbers. So it means that here range is also from negative infinity or to positive infinity, or you can say y is a member of real number. So you are going to say y is a member of a real number. So all these, they mean one and the same thing. So that is going to be the range. So you can choose either to use this one in interval notation or to use this one in set builder notation. So that is all about the domain and range that we are supposed to know. So there are three situations. That is, if you have a function in this form, the denominator should not be equal to 0. So whatever you have on the denominator, if it's involving x, equate it to 0, not equal to 0, then solve for x. Then when you have got a root is only defined for numbers which are greater than or equal to 0. So we are going to get whatever you have inside the root, equate it to greater than or equal to 0, then solve for x. Then yeah, these are the two mostly involving questions. Then a cube root will take any number, so it's going to be all real numbers. So go ahead and look for questions involving domain and range and try to answer. Then question 13, which is saying determine whether f and g are equal functions or not. Give reasons for your answer. So are these two given functions equal to each other or not? So the first one, we have f of x be equal to, we have x squared plus 2. Then we also have g of x, which is equal to x plus 2 squared. So here you can see that the function of f is already simplified. But let's expand function of g to see what we're going to have. So when we expand this, we're going to have x plus 2 squared. It means you have two of those. So when you expand, you have x plus 2, then plus 2, x plus 2. So here we are going to get x squared plus 2x plus another 2x plus 4. Then you can collect like terms together. So we have x squared plus 4x plus 4. So this is g of x when you expand. That is what we're getting. So it means that now we have this function comparing it to this function. Are the two functions equal to each other? Just from the look of things, these two functions can't be equal to each other. Because you can see that here we have x squared. Quite alright, here we also have got x squared. There we have 2. We don't have 2 in this function. Again, we have 4x here. We don't have 4x in this function. So just by this and that, the two functions can be equal to each other. If you want to verify further, you can use numbers. Because these are linear functions, the domain will be all real numbers. So it means that x can be any number. Let's say x is 1. If x is 1, you're going to have 1 squared is 1. 1 plus 2, this will give us 3. This side, we're going to get 1 plus 4 plus 4. 4 plus 4 is 8. 8 plus 1, that is 9. So 9 is not equal to 1. Or is not equal to 3. So these two functions are not equal to each other because they are not giving us the same result. So your conclusion is going to be f of x is not equal to g of x. Okay? So that is it for the first question. These are straightforward things. Then B which is saying we have f of x equal to x squared. Then we also have got g of x be equal to modulus of x, then squared. So what this means is that you have modulus of x, then we'll put this in bracket, then you square that. So first of all, let's just handle the modulus thing. So if you have a function g of x equal to modulus of anything that is a constant, modulus of any number is a positive or absolute value of that number. So let's say if you have modulus of negative 3, the modulus of negative 3 is positive for that number, so it will be positive 3. In other words, we are saying that a number inside in a modulus can't come out negative. The result can be negative, so it will always produce negative result. So what we have here, modulus of x squared, it means we have something like this. So what this means is that let's say you have x is negative 3. So we're going to say this is the same as modulus of negative 3 then squared. So first of all, you take the modulus of what is modulus of negative 3? That is going to be positive 3. Then now you can take the square. So that is going to give us a 9. That is what this function means. So now they are saying are the two functions equal to each other? These two functions, they will be equal to each other because modulus of x squared is equal to x squared. Okay, if this is going to be equal to x squared. Why are we saying so? Let's verify using numbers. Let's say x is 2. For this function, put 2 where there is x. So we're going to have a 2 squared. 2 squared is a positive 4. Are we also going to get positive 4 this side? So we're going to have modulus of 4 squared. Modulus of 4 is 4. So that is 4 then square. What is oh, why am I using 4? I was supposed to use 2 because we use 2 this side. Okay, so modulus of 2 is going to be 2 then square 2. We are still going to get what? Positive 4. Let's use a negative number. Let's use a negative number. Let's say x is negative 2 or negative 2. So this is going to be equal to negative 2 squared. Negative 2 squared is positive 4. This side we are going to say modulus of negative 2 squared. Modulus of negative 2 is positive 2. Okay, but then there is a square outside, so we square this, so we're still going to get what? 4. So therefore we're going to say f of x is equal to g of x. So the second one, these two functions are equal to each other. The first one, the two functions were not equal to each other because the two sides were not the same. So now I want you to try this part C. Are the two functions equal to each other? Just from the look of things, the two functions won't be equal to each other. So try to verify further by using numbers. So here you can just say, let's say x is 1. If you put 1 here, we're going to get g of x will give us 0. If you put 1 there, we're going to have 1 minus 1, that is going to be 0, over 1 plus 1, that is going to be 2. So 0 over a number is defined, is 0. But a number over 0 is the one which is undefined. That is why earlier when we had a question in a fraction, when we had the function in a fraction form, for you to find the domain, we say the denominator should not be equal to 0. We are not worried about the numerator because the numerator can be 0, but the denominator shouldn't be 0 because in the denominator we can have a constant and numerator can be 0. So a constant into 0 is 0, it's defined. But a constant over 0 is undefined. So that is why we said for you to find the domain in that case, like for this question, if you have been asked to say find the domain of this one, you're going to say x plus 1 should not be equal to 0. So x should not be equal to 1 will cross that sign, negative 1. Why? Because when you put negative 1 there, it's going to be negative 1 plus 1, that will be 0. So you're going to have a situation where you have x squared minus 1 over 0, which is undefined. So that is it for these questions. So question 14 is saying, given that g of x is x cubed minus 8 and h of x is cube root of x, find. So these are what we call composite functions. So composite functions is where you are combining two functions to come up with one. So when we say, like here we have g of x as well as h of x. So composite functions, you can combine these two in whichever order to come up with a single function. So let's say if we have g, this simply means multiply, okay, or composite, that dot you see. So g of h of x. What it means here is that in the function of g, where there is x, put the function of f. In other words, we are saying that the function that is coming first, where there is x, put the second function. substitute x with the second function. Then we can also have h coming first, h g of x. So it means now that in the function of h, where there's x, put the function of g. That's what composite functions mean. So let's start with the first one. So the first one is saying we should find g h of x. This was not supposed to be there, that comma v. So what it means here is that we know the function of g of x. So g of x, we have g of x is equal to x cubed minus 8. Then h of x is equal to cube root of x. Then here we are saying that in the function of g, which is this function here, where there's x, put the function of h. Put the function of h. So let's go ahead and do that. So we're going to say g h of x will be equal to, is going to be equal to, we have x cubed. So where there's x cubed now, put the second function, which is h. So that is going to be cube root of x, but then x is squared in g, or is cubed. So you're also going to cube this, minus 8. So we have substituted x with the function of h. If this was cube root of x minus 1, where there's x, we are going to put this whole function to come up with a single composite function. So this one now can be simplified. So cube root of x cubed, this is just going to be x. This is just going to be x. So x minus 8. This is going to be the function of g h of x. Why that the case is because it's that situation whereby you have, let's say, square root of x. Square root of x, then you also square. So this and that are going to cancel, thereby leaving you on with x. So this is the same. Cube root of x. Then you take it, you say cube again. So cube root and that cube, they're going to cancel each other, thereby on leaving us with x. So we have x minus 8. So this is our composite function g h of x. Now the question goes on to say, and find domains and range. So for each function, you have to find its domain as well as its range. So this is a linear function. The domain, when we talk about domain, these are x values. Then when you talk about range, these are y values. So we're saying that what values of x can you put where x is to make sure that this function is defined. So in linear function, the domain is all real numbers, meaning that you can pick any number, put it at x is going to be defined. So we're going to say the domain for this one, it's all real numbers. Okay? All real numbers. All real numbers in intervals. If you want to report your answers in intervals, your result in intervals is going to be from negative infinity all the way to positive infinity. Then the range. The range of a linear function is also all real numbers. So, no. So the range will be restricted. So how do you find the range? How do you find the range? Okay. So if you want, you can sketch this function, or you can find the inverse of this function. When you find the inverse of the function, then find the domain of the inverse. That is going to be your range. What I mean is that let's find the inverse of this. So we're going to say, let this part be equal to y. So we're going to say we have y equal to x minus 8. So we want to make x the subject. So we're going to have x will be equal to y plus 8. Okay? So meaning that f inverse of x is equal to x plus 8. So what is the domain for this one? The domain of the inverse is your range, but range we are dealing with y values. So that is also going to be all real numbers. So that's why I said that it's going to be all real numbers, because it's a linear function. So negative infinity to positive infinity. You can put any number where y is, you are still going to make this function defined. Okay? That is what it means. So go ahead and try this one. So for this one now, you are saying in the function of h, where there's x, put the function of g. When you find that, also go ahead and find the domain and range. So where there's x here, we just have cube root of x. So we're going to have cube root of where there's x, put this whole thing, then find its domain and range. Then for b, we have we are saying h inverse g inverse of x. So we should find this and also the domain and range. So what this one means is that find h inverse. In the function of h inverse, put the g inverse. So you can't answer this without finding the inverse. So let's first find h inverse. So h is given by, we have cube root of x. So h inverse, we're going to say let this be equal to y. So we're going to say let this one be equal to y, then equal to cube root of x. Remember that here the goal is to find, to solve for x. So to get rid of cube root, you are going to take a cube root on both sides. So this and that will cancel. So x is going to be equal to y cubed. So this is h inverse of x. We have y cubed. So this one now we can say it's x cubed because you reverse. Then where is g of x? So g of x is given by x cubed minus 8. So you're going to let this part be y equal to, say, x cubed minus 8. You make x the subject of formula, so we have x cubed will be equal to y plus 8. I've just rearranged there, nothing has changed. Then now we want to find the value of x. So we're going to, or you are making x the subject. So we're going to take a cube root, this will cancel. So we have x will be equal to cube root of y plus 8. Therefore, g inverse of x will be equal to cube root of, you change this x plus 8. So now that we have the inverse, we are saying that in this, in the h inverse of x, where there's x, put the g inverse of x. So h inverse of x is this one here. So we're going to say h inverse multiplied by g inverse of x is going to be equal to, what is h inverse? H inverse is x cubed. So where there is x, you put this function. So that is going to be cube root of x plus 8. But then x is cubed of h inverse. So we're going to say this whole thing should be cubed. Then again, where are we? We are at a situation where you have cube root. So this cube and that cube, they will cancel, thereby leaving us on with x plus 8. So it means that h inverse g inverse of x, we are getting x plus 8. So this is the answer for h inverse g inverse of x. This is your final answer. Then find the domain and range. So domain is all real numbers for this one. Range as well is also all real numbers because it's just the same as the previous one. It's a linear function. So it will be all real numbers. That is what this question is all about. Then what about this one? So this is not the same as this, no. What this one means is that you should first find hg of x. When you find that one, the final result, you should find the inverse of your final result. So this question now we are answering this part. I skipped it deliberately, but here we're going to answer it. So first find hg of x, not inverse, just hg of x. So this will be equal to, in the function of h, where there's x, put the function of g. Where is h? It's cube root. So we're going to say this will be cube root of, where there's x, put the function of g. So we just have x there. So you are going to put the function of g, which is x cubed minus 8. So this is the hg of hg of x. This is the function, it ends here. Okay, then now find the inverse. So find the inverse of that function. So now we are going to say hg inverse of x. What is it going to be? So how do you find the inverse? You are going to let this part be y. So we are just going to say y be equal to cube root of x cube minus 8. Then the goal is to make x the subject of formula. So how can we achieve that? You take a cube root both sides, because we have a cube root here. The goal is to make sure that this cancels. If we square, this will not cancel, but we have to take a cube root. Okay, so this side we are going to have y cube, which will be equal to, that cube root will go with that one, so we'll just remain with what is inside, x cube minus 8. Now remember that our achievement is to make x the subject of formula. So I can say x cube will be equal to y cube. When 8 crosses the equal sign, it will be plus. Then here you can take another cube root both sides. So this is going to give us x will be equal to cube root of y cubed, plus 8. Therefore h g inverse of x will be equal to cube root of y cubed plus 8. Then find the domain and range. So the domain and range of a cube root, a cubic function, is all real numbers again. It means that x can be any number, all real numbers. X can be any number, because let's say a cube root of negative 8. The cube root of a negative number, it's there, it's negative 2. When you multiply negative 2 3 times, you're going to get negative 8. Whereas a cube root of positive 8 is positive 2. You can multiply 2 3 times, you get 8. So that is what it means that there. Which numbers won't be allowed in this cubic function that are going to make this function undefined? Okay, this has to be changed to x. So no number is going to make this function undefined. A cube root of 0 is 0. You can multiply 0 3 times, you still get 0. So domain is all real numbers. I do believe range is also going to be all real numbers, but you can go ahead and test. So these are going to be the domain and range. So that's about composite functions. Simply mean the function that is coming first, where there is x in that function, put the second function, the function that is coming second, then maintain everything and evaluate. So you can go ahead and look for questions involving these composite functions and try to answer. Question 15. So question 15 read, determine which of the following functions are even, odd, or neither even nor odd. So in what case do you say the function is even, it's odd, or it's neither? So a function is even if and only if f of negative x equals the original function f of x. So if the function satisfies this condition, it means that the function is even. Okay, so we are saying that where there is x, where there is x, you put negative x. Whatever you do with that, the result should come out exact as the original function. Then it means the function is even. Then the function is odd if and only if f of negative x equals negative f of x. So in this case, you are going to say the function is odd. Okay, if it satisfies this condition. Otherwise, it's neither. If it does not satisfy any of these two, then you're going to say the function is neither. Okay, so let's go ahead and answer this question. So just let's say you pick the first question. So we are saying determine whether f of x equal to 2x to the power 4 then minus 4 x cubed plus 5. Determine if this function is odd, even, or neither. So one trick which I'm going to tell you about these functions when testing even, odd, or neither is that if you have got the power of x, if the power of x in that function is even, then the function is also even. So you just go ahead and try or test even. You're going to find that the function will come out to be even. What I mean by that is that if you have a function f of x be equal to, let's say, x squared, this power 2 is can have a constant there. This power 2 is an even number. So this function, if you test, should come out to be even. It should satisfy this condition. Then again, if the power is odd for a particular function, let's say you have x equal to f of x equal to x cubed minus any constant, let's say 5. This function, for the fact that it has got x which is odd, then which has got an odd number, then this function should qualify to be an odd function. So you go ahead, you start testing what? Yeah, if it's odd. Otherwise, if you have a function which combines both even and odd, let's say you have a function f of x be equal to x cubed minus, let's say, 2x squared plus, let's say, 3. This function, you can see that it combines both. There is an odd number as well as an even number. That is, you are looking at the powers of x. Is it odd or an even number? So this function which combines both odd as well as even number, this function will be neither. Okay, this function will be neither. So let's see the question that we have here. So that is the trick which you have to know. So this question which we have here, you can see that we have got a combination of an even number as well as an odd number. This function, there are high chances that it will be neither odd nor even. So let's try. So let's test. So I'm going to say if it's even, if this function is even, then f of negative x should be equal to the original function f of x. So wherever there is x, we're going to put in negative x. If x is squared, you also square. So this is going to be 2 multiplied by, we have x there, so we say negative x, then to the power 4, minus 4 multiplied by negative x to the power 3 plus 5. We are saying this should equal the original function, which is 2 to the power 4 minus 4x cubed plus 5. It should come out exactly the same. Then we're going to say the function is what? The function is even. So negative x to the power 4, x is an even number, so this is going to be positive. So this will give us 2x to the power 4. Negative x cubed is negative x. So this is going to give us negative x. Negative x multiplied by negative 4. That will be positive 4x cubed. Then we add 5. Is this the same as 2x to the power 4 minus 4x cubed minus 5? No. So the two are not the same. So this function is not even. They are different here. This is positive, this is negative. Okay? That is a positive, this is negative. Otherwise, this should be plus. Okay, that one there. So they are different based on that. So this function is not even. Then you don't end here. Go ahead and test if it's odd. So we said that if this function is odd, then the condition should be f of negative x should be equal to negative f of x. So f of negative x, that is where there's x, put in negative x. So I've already defined f of negative x is this. So I'll just copy this and put it there. So we have 2x to the power 4 plus 4 x cubed plus 5. So we're saying this should be equal to negative multiplied by the original function, which is 2x to the power 4, then minus 4 x cubed plus 5. So when you go ahead and expand, the two sides going to be equal. 2x to the power 4, then plus 4x to the power 3 plus 5. Is it the same as, this is going to be negative 2x to the power 4, then this will be plus 4x cubed, that will be minus 5. So you can see that the two sides are not the same again. So these two are not equal to each other. So odd also has refused. So it means that this function is neither even nor odd. So your conclusion is going to be the function is neither. So the function is neither even nor odd. So that is your conclusion. There you are going to have full marks. So you can see that the trick is working hard. Then this one, you have 2 is an even number, 1 is an odd number. Is 1 an odd number? Okay, so this one you can try it out based on even, odd, and check if it's even or odd. Then which one else? So I'm sure this commodulus was a mistake. It was not supposed to be there. So this function, you have that is an odd number. Then this is you have one there. So 1 is also an odd number, I think. Yeah. Yes, 1 is an odd number. So this function should be odd. Let's try. So we're saying that if it's odd, f of negative x should be equal to negative f of x. So what we are saying here is that where there is x for this side, you put negative. So that is going to be 5 open negative x, then cube. That should be minus open negative x. We are saying should be equal to negative open the original function 5x cubed minus 4x. So if we multiply this, what is negative x cubed? Negative x cubed is negative x. Negative x multiplied by negative x cubed multiplied by 5. So we're going to have negative 5x cubed. These two here are going to give us positive 4x. Is it the same as this side? We're going to have negative x cubed. This will be positive 4x. So you can see that the two sides are equal. This function is what? This function is odd. So the trick is working out well. So you have got an odd number, the function has to be odd. If here we have got an odd number, this function should also be odd. So this helps you on time, helps you to save time, because you may be stressing out testing this one if it's even, when you already know that it can be odd. Okay? Then what about if they are dividing? So we have d. So d we have f of x be equal to 3x minus 1 over 1 minus x squared. So what do we have? So here we have a situation where we have got an even number, an even number dividing into an odd number. So there are high chances this function will be neither. Let's try if it's even. So we are saying that if it's even, so these statements you have to write. Let's say if you are answering this question in a test or an exam, you are supposed to write a statement and say, if even, then you drop the formula. If even, f of negative x should be equal to the original function, f of x. Then we are saying that where there is x, you put negative x. So that is going to be 3. That should be 3 multiplied by negative x minus 1. Divide this one by 1 minus negative x, then you square this. Should be equal to the original function. We already have the original function. So when you multiply, this is going to give us negative 3x minus 1 over 1 minus negative x squared is still positive x squared. Is this function the same as the original function? No. So it's not, because we have negative 3x, there it's positive that. So it's not, meaning that this function is not even. Then you go ahead and test if it's odd. Then you're going to say, if the function is odd, then you drop the formula again. So if the function is odd, f of negative x should be equal to negative f of x. So we already have f of negative x, which is this. So I'll just copy and put it there. So we have negative 3x minus 1 over 1 minus x squared. We are saying this should be equal to negative open the original function 3x minus 1 over 1 minus x squared. So here it's more like how is this negative going to affect what we have there? So it's more like you have a situation negative 1 over 1 multiplied by 3 over 4. Here what will happen is that negative 1 will multiply by that 3, so you're going to have negative 3 over 4. So in short, when you're multiplying a negative in a fraction, it is only the numerator which is affected. The denominator remains the same. Unless you have, let's say if this was also a fraction, let's say negative 1 over 3. 3 was going to affect the denominator. But in this case, we just have that. So this negative will only affect the numerator. The denominator will remain the same. So we're saying this will give us negative 3x. This will be plus 1 over 1 minus x squared. If this is the same as this, check out every term. So what do we have? So this side we have negative 3x. That side also we have negative 3x. But here we have negative 1. There we have positive 1. So it's also not odd. So the function is also not odd. Then you're going to say the function is neither even nor odd. That is going to be your conclusion. So you're making that conclusion. All these should be seen. The even part as well as the odd part, they all should be seen, so that the marker is also able to see that your conclusion is based on facts. You have not guessed. So that is it. So this trick will help you to answer these questions as on time. Instead of you wasting time, you will just be able to confirm even before you solve. So as long as you have the powers are both, there is an odd power as well as an even power, the function will be neither. If you have an even power only, it means the function will be even. If you have an odd power only, the function is going to be odd as well. So let's check out this one. So for this one, we have f of x equal to negative root of 4 minus x to the power 4. For the fact that this function, the power is even, the function should be even. So we're going to test first if this function is even. So we said if the function is even, then f of negative x should be equal to the original function. So let's go ahead and see. So this is going to be negative root of 4 minus open negative x to the power 4 should be equal to the original function which we already have. So negative open, this will be 4 minus negative 4 to the negative x to the power 4 is positive x to the power 4. So x to the power 4, which is the same as this. So here this negative will not affect okay, don't make a mistake to say this negative is going to multiply by what we have there. No, this negative is outside the root. So what it means there is that the result that you are going to get in a root should be multiplied by negative. Let's say if you have root of 9, you have negative root of 9. The result there is going to be negative. Root of 9 is plus or minus 3. So your answers are going to be negative 3 and positive 3. Okay? If you have root of 16 or negative root of 16 is 4. So, or plus or minus 4. So let me just use positive. So it means that this is going to be negative 4. That is going to be the answer. So this function is even. Then what about this one, f? So this f, they just want you to confirm. So they are saying f of x is equals to these where a, b, c, and d are members of natural numbers. So if you look at this already, we have odd and even, then odd. So this function should be neither. So go ahead and try to answer. Your results should all be different from the original function as well as from f of negative f of x. So that function should be odd. So what you're going to do is your attention is just where x is. Forget about this. These are saying they can be constant, meaning that they can be any number of they can be any of the natural numbers. So your focus should just be here where x is and the effect that negative is going to have. So go ahead and try to answer this, and you can share with us your findings in the comment section so that we confirm. So question 15, which reads, solve the following equations for x is a member of real numbers. So the moment you hear the term solve, just know that you have to find the value. So here we have to find the value of x, where x we are saying is a member of real number, meaning that it can be any value starting from negative infinity all the way to positive infinity. So now if you look at these questions, you find that they are equations involving modulus as well as radical equations. So radicals is these ones with roots. So a root we call it a radical. Then these symbols, this is what we call modulus. So we're going to start with modulus. So what does modulus mean? So modulus simply means that anything in a modulus should come out to be positive. So you can't have a negative result from a modulus. So that is to say, we are saying that anything in a modulus should come out positive. That is to say, if you have a negative modulus of a negative number, modulus of a negative number is positive for that number. So modulus of a positive number is still the positive for that number. So modulus cannot produce a negative. That is what it means. So if you have an equation, let's say x minus 1, then equal to, you are being told that equal to negative, let's say negative 1. Before you even start solving, just say this equation has no solution. Why are you saying so? It's because you have a modulus this side and the result is negative. So modulus can produce a negative result. So the moment you write this, the marker will know what you're talking about. You don't even have to waste your time to go ahead and solve this equation. This though will only apply when you're dealing with equations. We also have got what we call inequalities. So inequalities is when you have you can see these symbols. So let's say if that one changes, becomes this, it becomes an inequality. Here you can try to solve and check here the solution sets which you are going to have. I think we're going to have questions which are like this, but for now we are dealing with equations. Let's forget about inequalities. So if you have a negative result from a modulus, just know that that equation is not true. So say that equation has no solution. So we start with the first one, which is say modulus of negative 2x minus 1. Then we are saying equal to negative 6. So this is what I'm talking about. Modulus can't produce a negative result. For the fact that this is producing a negative result, we are just going to say this equation is not true, it's false. So it has no solution. So that is going to be our conclusion on this. We don't even have to waste time to solve this equation, because you can solve and find the values of x, but the equation itself is not true because modulus can't produce a negative. So here I can bet that if you go ahead and solve and substitute that value, you are going to get at x. I think the overall result is going to be modulus of negative 6. So modulus of negative 6 is positive 6 and not negative 6 itself. So that equation has no solution. Then b, so b we have modulus on both sides. That is modulus of 2x plus 1, then equal to modulus of 4x minus 3. So here we're going to come across different types of modulus equations. So one of them can be this one here, which we have. That is, you have modulus on both sides. So if you have modulus on both sides, what you're going to do is modulus in other terms. Modulus, it also means plus or minus. Why plus or minus? Because we are saying you can have a negative number, you can also have what? A positive number, but the result is what is going to be the same. So when you have a situation where you have modulus on both sides, what you are going to do is you are just going to introduce plus or minus on one side. You choose which side to introduce your plus or minus. It can be to the right hand side or it can be to the left hand side, but the answer should come out the same. So the moment you introduce plus or minus, the modulus disappears on both sides. So we're going to say plus or minus this side. This side you don't have to add anything. Let just the modulus disappear. So this will be 4x minus 3, like this. This will also be true if you say you keep this side, that is 2x plus 1. So you have 2x plus 1 equal to, then you introduce plus or minus this side, that will be 4x minus 3. Okay, so these two, when you solve, the result should be the same. So let's go ahead and solve this one. So this one simply means that we have got a positive part of this, we also have got a negative part of this. So what we're going to do is in the first place, you are going to pick one. Let's say we pick positive part of this. So the positive part of this is going to be, we're going to have 2x plus 1 be equal to 4x minus 3. Then you collect like terms together. That will be 2x minus 4x will be equal to negative 3 minus 1. So this is going to give us negative 2x be equal to, this will be negative 4. So we'll divide by negative 2, also divide by negative 2. So we're going to have x be equal to negative 2 into negative 4 is positive 2. Then we also pick the negative part of this now. So negative of that simply means that negative open 2x plus 1. So this negative should multiply by everything. That's what it means. Even positive, that is what was happening. So positive will have no effect. That's why it will come out the same. But for negative, this is going to come out as negative 2x minus 1. So that's what we are going to put here and say, now we have negative 2x minus, will that be minus? Yes, because we also have positive here. So here it should be plus. No, minus, because we have positive. So minus 1 be equal to, this side doesn't change, it will remain the same. That is 4x minus 3. Next step, we are going to collect like terms together. So negative 2x minus 4x will be equal to negative 3. 1 crosses the equal sign, becomes positive. This will be negative 6x be equal to, that will be negative 2. So divide both sides by negative 6, this side by negative 6. Then we are getting x will be equal to negative positive, 2 into 2, 1, 2 into 6, 3. So meaning that the other value of x is 1 over 3. So these are the values that we are getting. So now let's try on this other one if we are still going to get the same results. So on this other one, instead of introducing plus or minus this side, this person decides to introduce, or you decide to introduce plus or minus this other side. And we are saying the results will be the same. So let's go ahead and solve. So this side where there's nothing, you just copy the way it is. So that will be 2x plus 1 be equal to, let's get the positive part of this. So we are going to have 4x minus 3. So you collect like terms together. That is 2x minus 4x will be equal to, this will be negative 3, 1 crosses the equal sign, negative 1. So this will be negative 2x be equal to, we'll have negative 4. You divide by negative 2, you divide by negative 2, that is x will be equal to positive 2. Okay? So one result has come out to be the same. Okay, as you can see. Then the other one, now we're going to get the positive part, or the negative part of this. So the negative part of that, we're going to have, so we copy the right hand side, that is going to be 2x plus 1 be equal to, this side now we're going to have negative 4x plus 3. When you multiply everything here by negative, that is what you're going to get. So what do we have? So you collect like terms together. This will be negative 2x, 4 comes this side, positive 4. This goes this side, that minus 1. So this will give us 6x be equal to, that will be positive 2. So divide by 6, you also divide by 6. So we're getting x be equal to 2 into 2, 1, 2 into 6, 3. Are the two results the same? Yes. So 1 over 3, 1 over 3, positive 2, positive 2. So if you have a modulus, if you have modulus on both sides, just introduce plus or minus on the other side. Then the modulus will disappear on both sides. Okay? This is what you are supposed to do. Then, if you want, you can test these solutions if they are true, because we are saying the two sides should be equal. So for the first one, we are saying x is 2. So 2 by 2 plus 1 modulus equal to modulus of 4 by 2 minus 3. So this is going to be modulus of 4 plus 1. then this side we're going to have modulus of 8 minus 3. 4 plus 1, that will be modulus of 5. Then this side, 8 minus 3, that will also be modulus of 5. Modulus of 5 is 5. Modulus of 5 is also 5. So true, 2 is true. Why are we testing? It's because sometimes you find that quite alright, you have obtained these two values of x, but sometimes you would find that only one of these is a true result. The other one does not give us these two to be equal. It means that it's not the solution. So you're just going to report one value. In this case, let's say one of these is not a solution, so you're going to say if x is equals to 2 is the own solution, then you're going to say x is equals to 2 is the own solution. That is after you have solved for both of these two x values. Let's also test for that one, which is now going to be 2. Then we have 1 over 3 plus 1 modulus equal to, this side we have 4, 1 over 3 minus 3. So if you solve this, you are going to have, this will be 2 over 3 plus 1. This side we are going to have 4 over 3 minus 3. So these are fractions you're adding. You're going to have 5 over 3 modulus equal to, this side the same, you have 3, that will be 4 minus 9. So this is 5 over 3 modulus be equal to 4 minus 9 is negative 5. So negative 5 over 3. Then what is modulus of positive 5? Modulus of positive 5 over 3 is still going to be 5 over 3. Is it the same as modulus of negative 5 over 3? Yes, we said the modulus of a negative number will still be positive. So this will be positive 5 over 3. So in this case, it means that both x is equals to 2 and x is equals to 1 over 3. They are all solutions. So this is case number 1. You have modulus on both sides. You decide just where to introduce or plus or minus. Then case number 2 will be a situation where you have a modulus being equated to a number. Okay? You have a modulus being equated to a number. So I'm going to pick, let's say, let me pick D. So D and C are the same. Whatever I'm going to do with D, you do the same with C. And to solve. So here we'll be solving for K. There we'll be solving for X. So now we have a case where you have a modulus on one side. You have modulus on one side, x plus 1 over x minus 1. We are saying that this is equal to 3. So in this case where you have modulus on one end, it doesn't mean that it should always be a fraction in the modulus. No, it can be a linear function. Let's say x plus 1. This one equal to 2. You still do the same. What I'm going to do here, you do the same with this one and any kind of a modulus, as long as you have modulus on one side and a constant on the other side. So here again, you can still decide to introduce plus or minus this side, meaning that the modulus will disappear. So we just remain with x plus 1 over x minus 1, like this, equal to 3. Or if you don't want to do this, you're going to introduce plus or minus where a constant is. Then this side, the modulus will disappear. So it means that we are going to have x plus 1 over x minus 1 be equal to plus or minus 3. When you solve the two, the results should come out the same, just like the previous question. So if we get a positive part of this, we are going to have x plus 1 over x minus 1 be equal to 3. So this is an equation. Here you can cross multiply because you have an equal sign. So we're going to have x plus 1 will be equal to 3x minus 3. Then you collect like terms together. You have x minus 3x will be equal to negative 3 minus 1. So x minus 3x, that should be negative 2x, should be equal to negative 4. So you divide by negative 2. You also divide by negative 2. You get x to be equal to positive 2. Then you also get now the negative part of this. So the negative part of this, we have negative open x plus 1 over x minus 1. So this negative is only going to affect the numerator. Why is it so? It's because this is the same as you have negative 1 over 1. So negative 1 multiplied by the numerator, this positive 1 also multiplied by the denominator. So negative there will only affect the numerator. So what are we going to have after you multiply by that? So we're going to obtain, that is going to be now negative x minus 1 over x minus 1 be equal to 3. Then when you cross multiply, you have negative x minus 1 will be equal to positive 3x minus 3. Collect like terms together, negative x minus 3x will be equal to negative 3 plus 1. So what do we have? We're going to have negative 4x be equal to negative 2. So you divide by negative 4, you divide by negative 4, and we are saying x will be equal to positive half. So these are the values of x. So you can go ahead and try this one. The result that you should get should be the same. X should be equal to half and x should be equal to 2. Then if you want, you can test the result. So when testing, you don't substitute in here. When testing, you substitute in the original equation. So where there is x, put 2. So if we put 2 there, we're going to have 2 plus 1, that would be 3 over. Then 2 minus 1, that would be 1. So 1 into 3, that is 3. Modulus of 3 is 3. So that is true. You can also try half. You should get 3 as well. So that is, I would say, case number 3, because the first case was we had a case with a negative result. The second case, you have modulus on both sides. The third case now has been you have a constant and modulus on one side. So I think these are the main equations that you are going to have. Then I think there is another type of a scenario where you have modulus, let's say modulus of x plus another modulus of x plus 2, like this. Then let's say equal to 0. In this case, you can't have two modulus on the same side in an equation. So what you're going to do is take one modulus on the other side. So you're going to have modulus of x will be equal to, when this one crosses the equal sign, it will be negative. So it's going to be equal to negative modulus of x plus 2. Then you do what we did earlier. So you're going to introduce plus or minus on one side, because you have this situation again. Okay, so most definitely this should be minus, so that when it crosses the equal sign, it becomes positive. This negative, I know it might confuse you. So that is what you do in another case. Otherwise, all the modulus involving equation, the approach that I've taught you here, should be able to help you to answer any kind of modulus equation. We are on now remaining with inequalities involving modulus. So now let's go ahead and solve these equations now involving radical functions. So, or maybe this one we have a combination of a radical function on one side and a modulus on the other side. So 2 minus x modulus equal to root of 4 minus x. So the story remains the same. You are going to introduce plus or minus on one side. So here, just introduce plus or minus this side. You have 2 minus x, then equal to modulus of 4 minus x. If you get positive for that, you have 2 minus x will be equal to modulus of 4 minus x. Remember that the goal here is to find the value of x. So, we can't find the value of x in a modulus like this. So what are we supposed to do? We are supposed to find a way on how we can get rid of this modulus. So what you are going to do here, you are going to square both sides. You square here, you also square this side. When you square this side, this square and that root, they will cancel each other. So it means that we are remaining with 2 minus x squared, then equal to 4 minus x. So now what you are going to do is, this 2 minus x squared, it means that you have 2 of these, 2 minus x. You also have got 2 minus x. Then equal to 4 minus x. Then expand this. So this is going to be quadratic function. When you expand this side, then you collect like terms together, and it's going to be a quadratic function. Then you solve for x. So here you're going to obtain two values of x. When you obtain those two values of x, come and test them. Put the one value of x here, and this side. The two sides should be equal. Test both of your values. If one value is telling you to say that, the two sides are not equal, it means that particular value is not the solution to the question. So sometimes it so happens that both of the results that you are going to get cannot be solutions. So you find that, let's say you get x is equals to 1 and x is equals to 2. Then you test them here, you put 1 there, you have modulus of 1, you remain with 1. You put 1 there, you have root of 3. It's not true. Then 2, you put 2 there, you have modulus of 0. You put 2 there, you have 2, root of 2 this side. So it is also possible that both results cannot be solutions to that question. So then when you find that situation, you're going to say the equation has no solution, because both results are not giving you the two sides to be equal. So then what do you do in this case? You have a modulus which is 2x. You have modulus of 2x minus 3 or minus 3 equal to 1. So we want to solve for x. So here, first of all, you are supposed to get rid of the root, so you square both sides. This square and that will cancel. You have 2x minus 3 will be equal to 1 squared is still 1. Then you collect like terms, that is will be 2x will be equal to, when 3 crosses the equal sign, we have 1 plus 3, 4. So over 2 over 2. So x equal to 2. So if you put 2 where there's x, you should get 1. So if you put 2 there, we're going to have 4. 4 minus 3 is 1. Root of 1, indeed it's 1. So that is true. So if you have a modulus one side, no, a radical on one side, and a constant on the other side, you square both sides. Then what about this one? So this one, now you have a modulus on both sides. Or no, one side. So we have modulus of 3x minus 8, then minus modulus of x plus 2. We are saying this should be equal to 0. So this situation is the same as that one I gave you earlier, to say you have modulus on the same side, then equal to, let's say, 0. So you can't solve this when you have modulus on the same side. You have to take one modulus to the other side. So the same will be true here. We have radical function, we have these radicals on the same side. So we are supposed to split them, take one on the other side. So this is going to be 3x minus 8 will be equal to, this was negative, when crosses the equal sign it will become what? Positive, x plus 2. When you reach at this point now, you are just getting rid of the root on both sides. So you square this side, you also square this side. When you square, this and that will cancel, leaving you with 3x minus 8 be equal to, the same will be true, this and that will go. So you have x plus 2. Collect like terms together, we have 3x minus x be equal to 2 plus 8. So we are saying that 3x minus x, this should be 2x, be equal to, this is 10. So divide by 2, then x will be equal to 5. So this is the result, the value of x. So we're saying that when we put 5 where there's x, this whole thing should give us 0. So we're going to have 3 multiplied by 5, that is 15. 15 minus 8, 15 minus 8, I think it's 7. Yeah. So 7 minus 5, x is 5, 5 plus 2 is 7. So we have root of 7 minus 7. So indeed this is going to be what? 0. So that is what you do. So sometimes this equation, let's say if this number was not 0. So if that number was not 0, let's say it was 1. So we are going to have 3x minus 8. So this is another case I'm giving you. Then we have x plus 2. Let's say this was equal to 1. If that number was not 0, you are still going to do the same. The modulus, these radicals can't be on the same side. So we're going to take 1 on the other side. So we have 1, then plus root of x plus 2. So remember, the next step here should be to get rid of the root. So you're going to say you square both sides. So you square here, you also square this side. So when you square this square and that will cancel. So we only have 3x minus 8. But this side, the story is different now. you can't say this and that will go, then you only remain with x plus 1 plus x plus 2. No, this is not true. So this side now you can see that if you don't if it wasn't 0, what will happen now is that it means that you have got 2 of these, so expand in that order. So it means that this side we have 1 plus root of x plus 2, then open 1 plus root of x plus 2. Then you are going to expand this. So after you expand, you are going to reach at a point where you are going to have a single modulus. Let's say, if you want, you can go ahead and try this question to find the values. So you're going to reach at a point where you're going to have a number. Let's say you have, after you expand that, let's say you're getting 4 plus, let's say 2 modulus of x plus 2. Not here. Okay. Let's say you are going to get something like this, then 3x minus 8. You reach at a point like this one. So what you do is you square for the second time, and you still square both sides. So you square here and then square this side. Then again now here it means that you also have got 2 of these, so you have to expand this side again. You have 3x minus 8 and 3x minus 8 be equal to this side. Now you are going to say these 2 squared, that is going to be 4. Then root of x plus 2 squared, that is just going to be x plus 2. Then you are going to expand this side and also this side. Then you collect like terms. Then obviously this is going to be quadratic. Solve for x. So this is it. Can be another scenario. You can try to look out for questions which will be like that. So I think these are the basics which you need to know under these kind of equations. Otherwise you can go ahead and look for questions of this nature and try to solve. So here you can answer that one. You can answer this one as well. Okay, so this is different from a modulus like this one. This one we said a modulus can produce a negative result. Then this one we are saying negative 4. The result is negative 4. Will that be true? Will that be true? So a number in a root, for this root to be defined, you should only have numbers which are greater than or equal to 0. You should have a positive number. Okay, so the results of a root can't be negative. Again, can't be negative. So you should have numbers that are greater than or equal to 0. So let's see if you solve that equation, what are you going to have? So if you solve that one, you have root of 5x minus 1 equal to negative 4. So here dialect to square both sides. So we're going to have this and that will cancel. That will be 5x minus 1 equal to negative 16. Negative 4 squared is 16. So 5x will be equal to 17, because 16 plus 1 17. So 5x over 5 both sides, x will be equal to 17 over 5. Let's see if this is going to give us that. So let's put 17 over 5 where there is where there is that. So this and that will cancel, so we'll remain with 17 minus 1. So this will be root of 16. Root of 16 is plus or minus 4, so it's true. So it's only different, it's undefined when you have a modulus, but a root will produce plus or minus. So that is it's true. So it can be equal to negative 4 or equal to positive 4. Both are true. So go ahead and try to look for questions of this nature and try to answer. For question 16, which is saying sketch the graphs of each of the following functions involving radicals on the same coordinate system as that of f of x equal to root of x and find the domain and range. So what it means here is that for each and every of these questions, you are going to sketch it on the same coordinate with this. So this is going to exist on each of as you try to sketch each of these functions on the same coordinate. So these are radical functions. So that first one, which is saying f of x equal to root of x. So you know that radical functions are only defined when x is greater than or equal to 0. Radical functions are only defined when x is a positive number, including 0. Any number less than 0, a radical function is defined. Say root of -1, this is undefined. There's no number that we can multiply 2 times to get -1. But root of +1, it's 1, so this is defined. Root of 0 is 0, so 0 is also what? Defined. So when you want to find the domain, like here they want us to sketch. So for us to sketch, you know that sketching will require to have x and y coordinates. So how do you get these coordinates? So first of all, you should start by finding the domain on that function. So for this one here, the domain is going to be, you are going just to get what is inside. For you to find the domain of a radical function, just get what is inside that radical function, equate it greater than or equal to 0, then solve for x. So here we're going to say x should be greater than or equal to 0. There's no need of solving here because x is just alone. So it means that here x will be any number starting from 0 all the way to positive infinity. You can pick any number. So then now we can find the x value or the y values using the x values, because we know what values of x are going to make this function defined. So then you are going to say here we have x, then we have here we have x, then we have y. So now since this is saying x can be any number greater than or equal to 0, so remember we are dealing with radical functions. So here let's say if you pick numbers, let's say you start with this same number 0, then after 0 what will come is 1, then 2, 3, and so on. So you can end at 3. Then you start replacing where there's x, you put these numbers. So you're going to have 0. When x is 0, y will be what? Because f of x is the same as y, so y equal to root of x. So when x is 0, y will also be 0, because root of 0 is 0. When x is 1, y is also going to be 1, because root of 1 is 1. Then when x is 2, y is going to be root of 2. Okay, you are going to have root of 2. So here it will require you to start estimating where does root of 2 fall. Okay, so instead of avoiding these situations where you have a root of a non-perfect square number, what I would advise you to do, if you know that you can't manage to approximate root of a non-perfect square number, is that since we are saying x can be any number starting from 0, just pick perfect square numbers. Okay, so let's say you pick perfect square numbers that we have 0, 1, the next is 4, then 9, then you go on up 16, 25, and so on. So these are enough. Then these are the ones which I'm going to choose to be my x values. So then I'm going to say I have 0, I have 1, I have 4, then I also have 9. So that this side I should just be getting a perfect square number. Then a root of any perfect square number, I know the result that I'm going to have. So let's say if x is 0, root of 0, y is going to be what? Is 0 as well. When x is 1, y is also going to be 1. When x is 4, root of 4 is 2, so y will be 2. When x is 9, root of 9 is 3, so y will be 3. In this case, it means that you are saving yourself from stress if you can't manage to approximate the root of negative number. That's why you are supposed to pick perfectly square numbers. So it means that now this can help us to sketch. Okay, so on these coordinates, okay, then now we are going to have to say we have numbers, let's say from 1, 2, 3, 4, 5, 6, 7, 8, 9. We can even go up to 10. Then this side, say you have negatives. Then 1, 2, 3, 4, say 5. Then 1, 2, 3, 4. You can end wherever you want to end based on the numbers that you have. So 1, then 2, 3, 4. Okay, then 1, 2, 3, 4. These are negatives. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, and 5. Then now we can sketch the function of this function. So remember that the condition is x should be greater than or equal to 0. So it means that the starting point is included. So when you are sketching and the starting point is included, you start with this point. We call this as a closed. So it's going to be closed. If this was just saying x is greater than 0, it means the starting point is not included, so it was going to be open. You don't shade completely. So we call this as a open. Okay. So in this case, we are going to have the starting point which is closed. We have a starting point which is closed, meaning that the number at the starting point is included. So we have 0, 0. So it's going to be closed there. So you put a dot. Okay. You're going to put this to present that it's closed. That is closed. If it was open, we are just going to say a circle like that. But here it's closed. It's included. So we're going to say this 0, 0. Next is 1, 1. So 1, 1 will be somewhere there. Then 2, 4. So 2, 4 is somewhere there. Then 9, 3. 9, no. So I was supposed to have 4, 2, not 2, 4. X is 4, then y is 2. So 4, 2. So let's say we have it there. Then next we have 9, 3. So 9 there, then 3 is just on top of 2, like this. So then, if you look at this is telling you to say that your graph is going to be a straight line. A straight line is starting from 0, then you join these points. So then what are we going to have? So we're going to have, you just join those points. This is a straight line starting from there all the way to, you can keep on going. So this starting point is included. This is the graph for y or f of x equal to root of x. So I've sketched the first graph. Second, now they are saying that you are supposed to sketch this graph together with any of these. So let's say if we pick this function, okay, we are also going to sketch it on the same coordinates because that's what the condition is saying. So then we'll come here again and say now we have a function f of x be equal to root of 3 minus x. So here let's find the domain. The domain is the one which is going to help us to come up with the x values or x coordinates. So then we are going to say, since it's a radical function, the domain should be x minus 3 should be greater than or equal to 0. So x should be any number greater than or equal to 3. So meaning that you are starting from 3 all the way to positive infinity. It can be any number. So again here, I'm going to consider perfect square numbers. I just want to get perfect square numbers in the root. So perfect square numbers start from 0, then you have 1, then 4, then I'll end up on 9. So what I want to obtain in this root should be these numbers. So what should be x for us to have 0? X should be 3. That's why even the condition of saying x is greater than or equal to 3, meaning that 3 is the starting point. So we're going to have the 3. Next, I want to have 1 in that root. For me to have 1 in that root, meaning that x should be 2. In other words, if you want to find the exact perfect square number, you are going to be equating. So let's say 3 minus x equal to 1. You want everything that you have there to be 1. When you solve this one, you're going to have positive 2. So x should be 2. Next, I want to have 4 in a root. What should be x? X should be negative 1. So say this should be negative 1. Okay, will that qualify? No. So we said no. So this domain is not true. Let's start all over again. So the domain, we have f of x equal to root of 3 minus x. So the domain, we said you just get what you have inside. 3 minus x should be greater than or equal to 0. Negative x should be greater than or equal to, this will be negative 3, divide by negative 1, negative 1. So x will be, so this is an inequality. In an inequality is when you divide by a negative number, the sign has to change. So this was greater than or equal to, now it's going to be less than or equal to positive 3. Yeah. So this is now true. So then we are going to say, to sketch this one, we are going to, we know the x values. So x values can be any number. So can be any number less than 3. So then what we're going to do next is to avoid again getting non-perfect square result, let's say root of 5, for you to start estimating, just list these perfect square numbers. So 0, 1, the next is 4, 9, and so on. So your goal is to be getting in a root any of these so that you make it easy to find y. So if I want the overall result inside the root to be 0, what should be x? So you can just say 3 minus x equal to 0. So for x, so you're going to find that x should be 3. So x should be 3, and that is the minimum, because we said x, the domain is x is less than or equal to what? 3. Any number less than 3. Next, I want to have 1 in the root. What should be x? X should be 2. Then next, I want to have 4 in a root. What should be x? X should be negative 1. Next, I want to have 9. What should be x? X should be negative 6. Okay? X should be negative 6. Because we are saying any number less than or equal to 3. So the domain there is starting from negative infinity all the way to positive 3, but positive 3 included. So meaning that for this graph, at the starting point it will also be closed, just like this one here, because it's including the starting point. So now let's get y values. So we are saying when x is 3, what is y? So 3 minus 3 is 0, root of 0 is still 0. The next, x is 2. 3 minus 2 is 1, root of 1 is going to be positive 1. Then next one, negative 1. 3 minus negative 1, that is going to be positive 4. Root of 4, that is 2. So we have 2 here. Next is 6. 3 minus negative 6, that is positive 9. 9, root of 9 is going to be 3. So you can see that this way it's much easier for you to find the numbers. So let's say to find x values or y values. So this will be negative 6, negative 5, like that. So then now we can sketch. Let's say if we just chose numbers randomly, starting from, let's say 3, the next to be 2, next to be 1, then 0, 0, then negative 1. What you are going to find, let's say if x is 1, we're going to have 3 minus 1 is 2, root of 2. It means that y is going to be root of 2. So you start estimating where root of 2 is. So if you are not good at estimating without using a calculator, it means that that will be very hard for you. So that's why it is better off that you choose perfect square numbers. Just equate what you have inside there equal to those perfect square numbers if you are not sure of what x is going to be. Then that is going to help you to get that. So then let's start. So we have starting point is 3, 0. X is 3, y is 0. So 3, 0 is going to be this point. But remember, the starting point is included, so it's going to be closed at this point. So it will be closed at this point. Okay. Then next we have 2, 1. X is 2, 1. So 2, 1 is going to be, let's say, there. Then after that we are going to have negative 1, 2. Negative 1, 2 is going to be a point somewhere there. Then negative 6, 3. Negative 6, 3. So you can see that this is just going to be a straight line. Okay, this is just going to be a straight line. Then you can join these points. You can join these points together. So we are going to say this is going to be, okay, this will be our graph. So this point included, that is it's closed. Then you can even put an arrow, because we don't know where this one is ending. It's all the way up to positive infinity. So this is now the graph for f of x be equal to root of 3 minus x. So you have sketched two graphs on the same coordinate. So now the other question is find the domain under, sketch the following graphs of the function involving radicals system and find the domain and range. So after you sketch, it's very easy now to find the domain and range. You don't have to find the inverse or whatever. So what we are going to say, let's start with the domain. So for the domain here, since we are sketching on the same axis, we are supposed to get the values which are going to be defined for both functions. That is this one, which is this, as well as this one, which is that. When you pick a number, it should be defined for this function as well as this function. So if you check there, let's find the domain of the two. So we said the domain of root of x, this was the domain for this function. The domain was starting from 0 all the way to positive infinity. Then the domain for this one was negative infinity, or negative infinity not included. So was negative infinity all the way to positive 3 included. Okay, so we want to find the domain. So what you're going to do here is let's have a number line, a very simple number line. So we have this number line. Let's say we have okay, so on this number line, so what we want to find here, we want to find the intersecting part. That is the values that are going to be defined for both of these functions. So this will be positive infinity, then let's say this is 0, then let's say that is 3. I think this will be enough. So for this one, we are saying starting from 0 all the way to positive infinity. So starting from 0, 0 will come, okay, so 0 will be here, 3 will be here. So starting from 0 included all the way to positive infinity. That is for this one. Then this other one is saying starting from 3 all the way to negative infinity. So you can see that they intersect at that area. So that is going to be our domain. So we are going to say the domain will be equal to the intersecting part, that is 0 to 3. So what it means here is that if you pick any number starting from 0 to positive 3, you put it in this function, it will be defined. You put that number also in this function, it will be still defined. Let's say we pick any number between 0 and 3, we pick 2. So we're going to have 2 in root that one, we're going to have root 2. Root 2 is defined because it's positive. If we put 2 here, we're going to have 3 minus 2, that is going to be 1. Root of 1 is also defined. But let's say you pick any number greater than 3. Let's say we pick a number that is, let's say 4. If x is 4, we are going to have 3 minus 4. 3 minus 4 is negative 1. So negative 1 is not defined, it's undefined. So that which means that when you pick a number greater than 3, one of the functions will be undefined, but one will be defined. Then again, if you pick any number less than 0, one of the functions will be undefined, the other one will be defined. So for you to find the domain, you just have to pick the intersecting part of the two functions. Then that is going to be your domain, which is going to make both of the two functions be defined because we are sketching on the same coordinates. Okay? Then the other, so here we are saying that the domain is equal to 0 included all the way up to 3 also included. Then what about the range? So range, we said these are y values. So what are the minimum values of y that each of these graphs can take? So you can see that they both start at 0. This one minimum is 0 all the way to positive infinity. For this one, it's also from 0 all the way to positive infinity. That is the range. So it means that the range here is 0 included all the way to positive infinity. This is defined for both of these two functions. So this is all about graphs involving radical functions. So these are going to be our answers or solutions to the question, especially the first part of the question. So by now I do believe that you can answer any of these questions. So you're going to maintain this graph in black. You're going to maintain that graph in black. Then you just be adding. When you come to this one, you just come add it here, then find the domain and range. Also this one, just like that. So then again, okay. So that is what you are supposed to do. So for these ones, for you to find the domain for that B, you have 2 minus root of negative x minus 2. So here to find the domain, this is not affecting our domain in any way. What is affecting our domain is what is in the radical function. So for you to find the domain, just pick what is inside the radical function. Negative x minus 2 should be greater than or equal to 0, because the radical function is defined for any number greater than or equal to 0, not less than. Then negative x will be greater than or equal to positive 2. You divide by negative 2, you divide by, or negative 1, sorry. Okay, because we want to get rid of the negative 1, negative 1. So we're going to say x, since we're dividing by negative, the sign will change, less than or equal to negative 2. So it means that the domain for this function is any number starting from negative 2 all the way to negative infinity. So it will also be included at the starting point, because we are saying less than or equal to 0. Then you're going to sketch this. So let's say, how are we going to find the y coordinates? I'll just let's say xy. So we are saying one of the x coordinates is going to be negative 2. So we have negative 2 be the minimum. Then let's say if we put negative 2 where there is x, what will be y? So y is going to be, that is going to be negative, open negative 2 minus 2 root. Then that is going to be negative, negative, that will be positive. So 2 minus 2 is root of 0. So it means that now you have this 2 minus root of 0. So 2 minus root of that. So 2 minus root of 0 is 0. So this will be 2 minus 0. It means y is going to be what? 2. That is what you're going to do. Okay? So for any value of x that you find in a root, then let it subtract from 2. That is going to be the value of y. So that will be true for the b as well as this one. So whatever you'll be getting from here, the first one is going to be negative 2. X will be negative 2. Negative 2 plus 0, or negative 2 plus 2 is 0. Root of 0 is 0. Then now you have negative 3 plus 0. So y is going to be negative 3 there. Then you keep on adding just like that. Okay? The same will also be true for this one. So the domain for this one, you don't include the 3. 3 is not part of the radical function. The radical function ends at 1. So you're just going to pick 2x minus 1 greater than or equal to 0. So you're going to find that x should be greater than or equal to positive half. So the domain for that one is going to be starting from half included all the way to positive infinity. But then you are supposed to sketch this on the same coordinate as this function. Then find the domain and range, just like what I did with the first question. Okay, so you can answer these questions. This one, you are going to get this greater than or equal to 0, find the domain. Then find the values of x. So that one now you're going to have negative 1 minus 3. It means that anything that you get in a root, so the first one is going to be, I think, half, positive half. X will be positive half. So half minus half is 0. So you're going to have 0. So you have negative 1 minus 3 multiplied by root of 0 is 0. So then negative 1 minus 3, negative 3 minus, or 3 minus 0 is 3, or is 0. So negative 1 minus 0 is negative 1. It means that y is going to be negative 1. Just like that. But then what is the domain of this? So the domain of x squared, radical of x squared, we said you're going to say x squared should be greater than or equal to 0. So you take a root like this, you're going to say x should be greater than or equal to 0. But this simply means that starting from 0 included all the way to positive infinity. But how true is this? We are saying that x is squared. So before you take a root, that number is squared. So you know that any number, when it's squared, it becomes positive. So let's say if x is negative 4. or let's say x is negative 2. So we're going to say root of negative 2 square this number. So that is going to be negative 2 squared is positive. So then now you have root of positive 4, which is going to be 2. So simply means that this is going to take any number. So the domain for that one is going to be all real numbers, because x is squared inside the root. So anything squared, it will become out will be positive. So that is for this one. So when you solve, it's going to deceive you and tell you to say it's from 0 all the way to positive infinity, but it's not true, because x is squared, so it can take any number. Before you take a root of that number, you are supposed to square. So when you square a negative number, it becomes positive. So any positive number in a root is defined. So it means that the domain for that one is going to be all real numbers. So try to answer these questions. Where you have challenges or problems, you can comment in you can leave a comment in the comment sections, and we'll be able to help each other. Question 19. So question 19 is on under binary operations. So the question reads, the operation that is star on the set of real numbers R is defined by. So the definition of our operation is this one here. Then where A and B are members of what? Real numbers. They are members of real numbers. So the first question is saying, is a star binary operation on R? So let's first establish the basic foundation or idea behind binary operation. What is binary operation? So binary operation, by definition, binary operation on the set of real numbers. Binary operation which is presented by this symbol. So by the way, you are going to find there are a lot of symbols which are used to present binary operations. Some you are going to find these, some you are going to find these. So it means one and the same thing, but the most used is this one star. So as you can see here, what is being used is that one star. So that means binary. Okay. So we're saying that by definition, binary operation, that is a star on the set of real numbers. It is an operation which can combine two numbers. These numbers should be a member of that set. So in this case, we can combine two real numbers to get the result which is also a real number. So it doesn't matter. You can just pick randomly two numbers from the set of real numbers. Depending on the operation that you are going to use, the result that you should obtain, it should also be a member of that set. It should also be a real number. It means that star is now binary on the set of real numbers. Okay? So you'll be given these operations. Now, the basic operations that are used are, we have subtraction, addition, multiplication, as well as division. These are the most used the basic operations which are often used. So this star which you see here, it can be presented by, or it's representing any of these. Okay? It's representing any of these. So what we are saying is that, let me give you an example. Let's say we have set y. Set y has got members 1, 0, and let's say -1. Okay? Let's say -1. So we have set y there. So the question will come and say, is the star binary on set y? So for us to state if star is binary on set y, we are going to say, so in this case, let's say we are using an operation subtraction. So the question is subtraction binary on set y? So for that, we are going to say, if subtraction is binary on set y, let's pick any two numbers randomly from this set. Let's say we are picking which numbers? Let's say we pick 1 and -1. So we are subtracting, right? Okay? So our operation is subtraction. So depending on, regardless of how we're going to combine these numbers, let's say we have -1, then +1, then we also have, let's say, 1 minus 1. So here we're going to get 0, there we'll also get 0. 0 is also a member of what? Y. Okay? It's also a member of y. So this satisfies the condition. So we're going to conclude that this is subtraction is binary on set y. But someone is going to pick, let's say someone is going to pick -1, -1. So if we have -1 minus another -1, what are we going to obtain? So we're going to have negative 1 plus 1. We are still going to obtain 0. So 0 is a member of what? A member of our set Y. So someone is going to pick, let's say someone is going to pick 1 and 0. Then 1 minus 0, someone will say 0 minus 1. So 1 minus 0, we are getting 1. 0 minus 1, we are getting negative 1. So you can see that 1 is a member of set Y. Also, negative 1 is also a member of what? Set Y. So in that case, we're going to make a conclusion that subtraction is binary on set Y. Okay? So that's what binary means. So in this case, we are saying that we have to test is star binary on the set of real numbers. So remember, the operation that is being used is this one here. So by the way, it's not only this star which is used. Sometimes you're going to find symbols like this. Some will use these. So these will just represent what? A binary operation. So any of these symbols can be used. So don't be confused when you come across such. So let's now answer part 1. Is star binary operation on R? So we are saying that that is a condition. So we are going to say if star is binary, on R, on the set of real numbers, then two members, that is, let's say, then A and B should be, or let me say, A and B should be a member of real number, and the result that you are going to get, A star B, the result should also be a member of what? Real numbers. If these conditions are satisfied, then we are going to conclude that star is binary on what? On the set of real numbers. So in this case, let's say we are going to use numbers now, because it will be very hard for us to conclude using these operations. So we are going to say let A be equal to, so remember that this is on the set of real numbers. It can be any number. So let's just pick randomly. So let's say A is 1, and then we say, okay, then we say B be equal to, let me say, negative 2. So now we are going to plug in. So it means that following this operation, A, where there's A, you put what? 1. Where there's B, you are going to put negative 2. Then in this operation, where there's A, you'll be substituting with 1. Where there's B, you'll be substituting with negative 2. So now I'll bring down that operation. So the definition is A star B equal to, this is 2 minus 3B, everything squared, minus 5B squared. So I want to see if we can randomly pick two numbers from the set of real numbers, plug them in this operation, and the result that we're going to get, the result is also going to be a member of real numbers. That is what we want to conclude here. So you start with that statement which I've written on top. Okay? So now we have A is 1. So where there is A, we're going to have 1. So it means that this one now will be A star, B is negative 2. So it will be A star negative 2. Which means that where there's A, you put 2. So this is going to be 2 multiplied by 1. Then minus 3 multiplied by, what is B? B is negative 2. Then everything is squared, minus 5 multiplied by negative 2 squared. Okay? So what are we going to get after this? So this is going to give us, this will be 2 minus 2, that will be plus 6. When we multiply negative 3 and that negative 2, we're going to get positive 6. Then we square, minus 5 open, what is negative 2 squared? So negative 2 squared is 4. Then now we have 2 plus 6. So 2 plus 6, that is 8. 8 squared, we're going to get 64. 64 minus 5 multiplied by 20, or 5 multiplied by 4, we are getting 20. So what is 64 minus 20? This is going to be 44. So is 44 a real number? Yes, 44 is a real number. So this one now has satisfied what? This condition. The result that we have obtained for A star B, the result that we have obtained for A star B is also a member of real numbers. At first we picked two numbers which were members of what? This real number. So because this is satisfied, 44 is a member of real numbers. then we are going to say that star is binary on the set of real numbers. So your conclusion is going to be that star is binary on the set of real numbers. But again, you are not just supposed to use two numbers. After you have picked these two numbers, you are finding that this is satisfied. Try to pick two different numbers again. So let's say now you decide to say let a be equal to -1, then b be equal to, let's say, 3. But one thing that I would advise you, if it's on the set of real numbers, you better pick small numbers. Don't pick big numbers, because you can see that there are squares here. So you are not allowed to use calculator in an exam. So if you pick big numbers, you're going to find it very challenging. But just pick these small numbers. Let's say 1, -1, 2, and the like, so that you make your work easier. So you can also try these two. Then the result that you are going to obtain, is it a member of a real number? If it is, then yes, star is binary on error. Okay. So like most of the times, if you are testing if an operation is binary on the set of real numbers, most of the times it turns out that it is a real number, because any result that you are going to obtain, there are high chances that it is what? A real number. Because real numbers run from -infinity all the way to +infinity. So it means that any result, depending on how you can combine the numbers, you are still going to get a number which is a member of real numbers. But it becomes very restricted if you have been given, like the set that I gave you earlier, which was set X. So in that case, you are supposed to pick any members from that set, get the result, then the result that you are getting, is it a member? Is every result a member of that set? So let's say if we have that set. So pick any two numbers, test if star is binary on that set. Okay. So in this case, because we are not proving, you'll be asked to state if maybe, let's say if multiplication is binary on this set. So you're going to pick any two random numbers. Let's say you pick 2 star 2. This is going to give us, because our operation now is multiplication, so we're going to say 2 multiplied by 2. This is going to give us 4. 4 is not a member of this set, so it means that multiplication is not binary on this set. Okay, so that's how you test if an operation is binary or not. And this question will always come most of the times where this question is concerned in an exam. Then question 2 is saying determine whether star is commutative. So what is commutative first by definition? So an operation is commutative if, so we're saying that an operation is commutative if a star b equals to b star a. So if two numbers can be expressed in this in this form, you are getting a particular result, you try to swap the numbers, b comes first, a comes after, you are still getting the same result. It means that an operation is commutative. So for you to answer this question, you're going to say if this is commutative, then you're going to put this a star b should be equal to b star a. So now remember that our operation is defined by this. So a star b is going to be that same thing. So this side where there's a star b, I'm going to put that operation which we have there, because a star b is defined by, so a star b is defined by this. So I'll put this to the side where there's a star b. So this is giving us 2a minus 3b then squared minus 5b squared. This should be equal to, now you are just going to swap, where there is a you put b, because now we are saying b should come first, a should come after. So where there was a you put b, where there was b you put a. So this side is going to be should be equal to, this one should be 2, the constants should maintain, so this is going to be 2b minus 3a then square minus 5, where there was b it will now be a squared. So if this operation is commutative, this condition should be satisfied. So remember guys that you always use the operation given. Okay, so in this case we have been given this operation, that's why it's the one I'm using here. If our operation was saying, let's say a star b equal to 2ab, it means that we are still going to use this. So to this side where there's a star b, we are going to put this. Be equal to that side where there's ba, we are going to say should be equal to 2 then ba. That is what we are going to do. Okay, so at this point now it will still be very hard for us to conclude if the two sides are equal or not. So what are you going to do? Remember that this is on the set of real numbers. So just let again, at this point you're also going to say let a be equal to, just pick any number as long as that number is part of the set. So let a be equal to 1 and b be equal to, let's say, a simple 2. Then let's go ahead and plug in both sides. Where there's a, we'll be putting 1. So this will be 2 multiplied by 1 minus 3 multiplied by b is 2. Then everything squared. Minus 5, what is b? So b is 2. Then we square this. Is this going to be the same as this side? So let's say this side we are going to have 2 multiplied by b which is 2, minus 3 multiplied by a which is 1, everything squared, minus 5 open, what is a? So a is 1 squared. So let's work out this, then we'll also work out that side, then we'll compare the results. So 2 multiplied by 1, that is going to be 2. Then negative 3 multiplied by 2, that is negative 6. Then everything squared, minus 2 squared is 4. 4 multiplied by 5. 4 multiplied by this 5, that is going to be minus 20. So we have minus 20. Then 2 minus 6, that is going to be negative 4. Negative 4 squared, that will be 16. So this side we have 16 minus 20. 16 minus 20 is negative 4. Let's see, are we still going to get negative 4 this side? So this side we have 2 multiplied by 2, that is going to be 4, minus 3 multiplied by 2, that is going to be 3. Everything squared, minus, that is 1 squared is 1, 1 multiplied by 5, we'll still get 5. Is it the same as, so 4 minus 3, that is going to be 1. When you square 1, because we're going to have 1 squared minus 5. So 1 squared is still 1. Then 1 minus 5, that is going to be negative 4. Okay, so someone will say this operation is commutative. But what if now this cannot convince us to say that this operation is commutative? Try to pick other two different numbers and let's see if we are still going to get the same result. So the first numbers have satisfied, okay, have satisfied our condition. Let's now try to pick two different numbers. Okay, so now let's say a is equal to negative 1, then b equal to, let's say it's a 3. Are we still going to get the same result? So we start all over again. So 2, a is negative 1, minus 3 multiplied by b is 3, then everything squared, minus 5 multiplied by b which is 3, square this. Okay, is it going to be the same as open? Is it going to be the same as this side we have open, 2 multiplied by b which is 3, minus 3 multiplied by negative 1, everything squared, minus 5 multiplied by a negative 1 squared. So let's see if we are still going to obtain the same result. So we have open, that will be negative 2, then we have negative 3 multiplied by 3, that will be negative 9, square this, minus 3 squared, that is 9. 9 multiplied by 5, that will be 45. Is it going to be the same as this side? So this side we are going to have open, that will be 6. Then this is going to give us positive 3. So that will be plus 3. Then we should square this. Then minus negative 1 squared is 1. 1 multiplied by negative 5, we still have negative 5. So let's work out this one. So negative 2 multiplied by negative 2 minus 9, that is negative 11. So we have negative 11 squared minus 45. Negative 11 squared minus 45. Negative 11 squared is positive 121 minus 45. So what is 121 minus 45? 121 minus 5. So 11 minus 5, that is going to be 6. Here we'll remain with 1. 11 minus 4, that is, I think, 11 minus 4 is 7. Yes, 7. So we remain with 76. So this side we have 76. Let's see if we are still going to get 76 this side. So we are going to have 6 plus 3, that is 9. 9 squared minus 5. So 9 squared is 81. 81 minus 5. So 81 minus 5, that is going to be, I think, 76. Okay? 76. So I'm still getting the same, 76, 76. So in this case now, I can conclude that this operation is commutative. So our operation now has also qualified that it is commutative. Because I've used different numbers, I'm still getting the same. You can still decide to use other different numbers as long as those numbers are from the set of real numbers. Then the result that you should get, the two sides should be equal. That's what commutative simply means. So my conclusion is going to be the operation, which is a star, is commutative on R. Is commutative on the set of real numbers. Okay, so you prove by justification. Justification is what I've done here. You have to show this work as you answer this question, or this work has to be seen so that the marker can be convinced of what you are talking about. So that is what commutative is all about. A star B should be equal to B star A. Then we move on to part 3. So determine whether the operation is associative. So associative is quite complex. Associative is quite complex because it involves about three numbers, if I'm to say. Okay, whereas commutative it just deals with 2. So if we're still going to say if this operation is associative, if our operation is associative, then A star B in the brackets star C should be equal to A star open B star C. That is what associative mean. So if our operation is associative, then A star B in the bracket star C should be equal to A star open bracket B star C. That is what it means. So remember, let's look at this. If you look at our operation, we don't have C there. We just have A and B. But here we have A, B, and C. So what are you going to do? So let's first take this side. We'll come to this other side. I want you to understand this associative law because it is very complex. Okay? But I'm going to simplify and make it easy for you to understand. So this is what associative mean. A star B star C should be equal to A star B star C. So your focus here should be where the brackets are. So this is where your guide is. Okay? It's more like board mass. Board mass, you always start with where the brackets are. So our focus will first focus where these brackets are. So what are we going to say now? So what we're going to say, in the brackets we have A star B. So where the brackets are, these will take up the operation given. So our operation given is this one here. So where there is A star B, that is what we're going to put. So we're now going to say, I'll put these in brackets. So we are going to have our operation is 2A minus 3B, then squared, then we have minus 5B squared as well. Then I'll say this. So now this part, the A star B, has been taken up by this operation because a star b is equal to that operation. That's why I'm substituting there. Then now remember that we have c. So we have star c. Okay? So we are here now. So at this point now, we don't have c. If you check in the operation there, we don't have c. We just have a and b. So I'll still go back. So remember that our operation is defined by what? A star b. What is coming first is a. What is coming second is b. So at this point now, after substituting this part with the operation given, on the second step here, you can still see that we still have two things. The first one is this one here in red. The second one is this one in which is c. So what are we going to say? So what we're going to say now, this one which comes first, the whole this in brackets, the whole this is going to be our a. Okay? Because this is what the operation is saying. What is coming first is a. So we're now going to say this is our a. What is coming second? This is our b. Okay? So now in this operation for the second time, where there is a, anywhere where there is a, you'll be putting the whole of this. Okay? Then where there is b, you'll be putting c. But we are not going to use c because we don't have c there. That's why we are saying our this c will be taken up by what? B. Then a is going to be taken up by what? This. Why are we going to use this? Is because we don't want to confuse. We want a and b to still appear. So where there is b, we'll be putting this b. Where there is a, we'll be putting this operation. Okay? So let's go ahead and do that. That's why I said this is quite complex. It's very long. Because what we are doing this side, we should come and do this side as well. So now what are we going to say? So in this operation, okay. So in this operation, everywhere where there is a, we'll be putting the whole this. Okay? So let's go ahead and do that. So you can see that this is going to be it will be 2 open. Hey, this is tiresome. So it is going to be 2 open. Where there is a, let's put this. So there is a there. So where there is a, we are going to say, where there is a, we put 2 a minus 3b, you cross. Then square this, minus 5. Where there is b now, where there is b, you are going to still put a b, which is presenting c. We can't use c because there is no c in our operation. That's why we're still going to use a b. It's just presenting c. So we're going to say where there is b, we put what? We're going to put a b. Okay? Like this. So I'm here now. Then this whole thing in brackets, that part is squared. So let's square this. So we're going to say everything what? Everything should be squared. Then I'll put this again, minus. So we have 5 multiplied by b. What is b? B is still b. But b there is what? Is squared. Okay? Like this. So if you want, you can simplify this, but simplifying it to be very complex. So let's just maintain. So I have 2 open, then open 2a minus 3b, this, then everything squared, minus this is going to be 5b, then we have this everything squared, that, then now we have minus 5b squared. So at this point I'm going to say this part when we expand is giving us this. So the right hand side is giving us this. So what we are going to do later on, we are just going to assign numbers to prove what the value is going to be. Just pick 2 numbers again. So we are going to say let a be equal to any number. So here I have to use a very small number. Let a be equal to 1, then b I'll say be equal to -1. Then we are going to plug in this operation. Where there's a, we'll be putting 1. Where there's b, we'll be putting -1. But again, this side again is not just this side alone is not going to tell us if this operation is associative or not. We are also supposed to take the left hand side. Then this left hand side, we compare it with that. So let's, before we plug in values there, let's also go ahead and take the left hand side. So this left hand side, you can see that things have changed now. It's A star, B star, C. So here still prioritize where the brackets are. So here we're going to prioritize first what? We're going to prioritize B star C. Okay? So this B star C, we're going to say be equal to, A will still come as A. Then where there's B star C, put the operation given. So the operation which is given is this one here. Okay? So where there was B star C, I'll put that operation. So this is going to be A star, then open. This will be 2A minus 3B squared. Then, okay, squared. Then minus 5B squared as well, like this. So what do we have? Our next step, we're going to say what is coming first. So now we have A star this. Our operation is A star B. What is coming first is A. What is coming second is B. So now what we're going to say, our A is this one. What is coming second, this is our new B. So this whole thing is our new B. So in this operation again, we'll still go back. Where there's A, you'll be putting A is still A. B, where there's B, you'll be putting the whole this. So let's go ahead and expand or do that. So what do we have? So we have this is so involving, guys. So what do we have? So we have 2 multiplied by A. So 2 multiplied by A, our new A is still A, so it's still going to be 2A minus 3 multiplied by B. So 3 multiplied by B. What is B? B is the whole this. So where there's B, I have to put that. So that is going to be open 2A minus 3B, then squared, then minus 5B squared, like this. Okay? Then we are saying minus 5B squared. Okay? So minus 5B squared. Remember that what I've replaced here, that part is just this. The 3 that you see there is this one. That B, this B which you see here, is the whole of this. So what are we remaining with? We are remaining with 5 minus B squared. So we are supposed to subtract there. So because of space, I'm going to say everything minus 5 open multiplied by 5 multiplied by B squared. What is our B? B is this whole thing, but now it has to be squared. So let's replace that. So we're going to say we have 2A minus 3B, then this is squared, minus 5B squared again. So B was squared. We'll also square this. So at this point now we can substitute. So we have already did it. Let A be equal to 1 and B be equal to -1. So I'll start with this one in black. It is the right hand side. Then this one here, it is the left hand side. So let's start with the right hand side. So, and see the result that we're going to get. So there we have 2 multiplied by 2. What is our A? Our A we are saying should be 1 minus 3 multiplied by, what is B? -1. Then everything here should be squared. Minus 5 multiplied by B, which is -1. Then square everything. Okay? This is square here. We have to square everything, which is inside there. Minus 5 multiplied by B. What is B? B is -1. B is squared, so also say square there. Then let's go ahead and work out this. So we are going to have, this will be open, 2 open, that will be 2 multiplied by 1, it will still be 2. These 2 here are going to give us, those 2 there are going to give us plus 3, because they're multiplying. Plus 3, then there's a square outside. Then we have -1 multiplied by -5, that will be plus 5, like this. Everything squared, which is that square there. then minus 5 multiplied by 1 squared is still 1. 1 multiplied by negative 5 will still get negative 5. Then we'll come down and say this is going to be, okay, I have 2 here. So 2 plus 3, that is 5. Then square plus another 5. Everything squared minus 5. So what are we getting? So 5 squared is 25. 25 multiplied by 2. 25 multiplied by 2, that is going to be 50. 50 plus 5. So 50 plus 5 is 55. So we have 55. This one is squared minus 5. So what is going to be, what is 55 squared minus 5? So 55 squared, you can multiply that. 55 squared, which is the same as 55 multiplied by 55. So that is 3025. So 3025. Subtract a 5. So that is going to be 3020. Meaning that this side we are getting 3020. 3020. So let's see if we are still going to get the same value this other side. This is the most complicated part of associative law, is the most complicated one, especially if they bring you an operation which is very complex, like this one which has squares. It is very complex. It becomes simple if you are just dealing with direct operations. Let's say you have a minus b, something like this. It's very easy to work out with associative, but not like this. So let's go ahead and see what we have this side. So I'll start from here. Remember that you should use the same number that you used to test this other side. So we're still going to use a is 1, b is negative 1. So there we have 2 multiplied by 1, then minus 3 open, then open 2 multiplied by 1, minus 3 multiplied by b is negative 1, then everything should be squared. That is square. Then minus 5 multiplied by, what is b? b is negative 1, then square. Then everything should subtract this. So I think you should allow me to work out that one first, then we'll come and also subtract that. So let's go ahead and say this will be 2 minus 3 open. This is going to be 2 minus or plus 3. 2 plus 3 then squared. So 2 plus 3 is going to be 5. So 5 squared, which is this one here. Okay, yeah, that is what we have. Then minus 5. If you multiply negative 1 2 times, we are going to get positive 1. That multiplied by negative 5, we're going to get negative 5. So this will give us 2 minus 5 squared is 25. 25 multiplied by 3, that should be 75. 75 minus 5. This is the same as 2 minus 80. 2 minus 80, that should be negative 78. So the first part is giving us negative 78. Let's first also work out this one because it's subtracting. So we now have negative 5. Anyway, let me keep the negative because we're saying we'll subtract from this. So I'll ignore the negative. I'll just say positive 5 open. 2 multiplied by a, we say this 1, minus 3 multiplied by b, we say this negative 1. Then everything squared minus 5 multiplied by b, which is negative 1, but b is squared, so we square. Then everything squared, which is that one there. So this will give us 2 open. 2 multiplied by 1, that is 2. Negative 3 multiplied by negative 1, that is positive 3. Then square minus negative 1 squared is positive 1. Positive 1 multiplied by negative 5 is negative 5. Then everything should be squared. Okay, everything should be squared. Where is that 5? Okay, this was supposed to be 5. It's supposed to be 5. Okay, everything should be squared, which is this, because here I'm supposed to do this. Then now what do we have? So we have 5 open. 2 plus 3, that is 5. 5 squared is 25. So that is going to be 25 minus 5. everything squared. So that would be 5. 25 minus 5, that is 20. So what is 20 squared? 20 squared is 400. 400 multiplied by 5. So 400 multiplied by 5. Because we are saying this is squared, 400 multiplied by 5, that will be 0, 0. So that is 2000. So now let's subtract 2000 from this. So what are we going to get? So 2000 minus that, that is just going to be 2000, negative 2078. So we can see that this other side we are obtaining negative 2078, whereas on the right hand side we obtained 3020. So this simply means that the operation is not associative because it has failed to satisfy the condition which we said A star B star C was supposed to be equal to A star open B star C. So it has failed to satisfy this. So we are going to say A star B star C is not equal to A star open B star C. Therefore, the operation is not what? Is not associative. So that is what you are supposed to do, guys, with associative as well as commutative. So you can go ahead and find questions and associative and try to answer. Now, let's see. Let's answer part. This is part 4. So part 4 is now saying evaluate. So all of these are different from each other. That's why I think we're going to answer all of them together. So we are saying evaluate. So when they say evaluate, they simply mean find the value. So evaluate A star 2, then star C. Oh, not C, star 5. Because now we are dealing with action numbers. So if you look at this here, someone is going to say this is associative, which is true, because we have got A, B, and C there. So when evaluating, we are supposed to find the value, not just confirming is it associative or not. No, here we are finding the value. So our operation is still defined by this. So I'll bring that one here. We are saying A star B is equal to, that is 2A, that is 2A minus 3B, everything squared, minus 5B squared, like that. This is our operation. So what we are going to do from this, we can see that we have got 3 numbers, so we don't have C. So what we are going to do is first treat where the brackets are, just like what we are doing in associative, because in associative I said you first prioritize where the brackets are. So even here we're first going to prioritize where the brackets are. So let's isolate that. So in the brackets we have 3 star 2. So this 3 star 2, what is coming first based on this operation? What is coming first should be A, meaning that this is A star B. So now we are going to say 3 star 2 will be equal to, so our A is 3, our B is 2. So where there's A, go ahead and put what? Go ahead and put 3. So this is going to be 2 multiplied by 3, then minus 3 multiplied by B, which is going to be 2. Then everything should be squared, minus 5 multiplied by, what is B? B is 2. So B is squared, you also square this. So this will be equal to, that is going to be 6 minus 6. Okay, because negative 3 multiplied by 2 is negative 6. So everything should be squared, minus 5 multiplied by 2 squared, that is 4. So negative 6 minus 6, that is 0. So we have 0 squared minus 20. So 0 squared is still 0. 0 minus 20, we are still going to get what? Negative 20. So now what it means in this case is that you have reduced 3 star 2 has now just become what? Negative 20. So where there was 3 star 2, you now put this number. So let's go ahead and do that. So it means that now we have negative 20 star 5, because this one has been reduced to a single number, which is negative 20. That was the goal, so that we can make this one 1. So now we have negative 20 star 5. Then you still go back to your usual operation. What is coming first is A. What is coming second is B. So now in the operation, in this same operation, where there's A, you put negative 20. Where there's B, you're going to put 5. So let's go ahead and do that. And this is going to be our final answer. So we're going to say this is going to be equal to, open, 2 multiplied by a, which is negative 20, then minus 3 multiplied by b, which is 5, then everything should be squared, minus 5 multiplied by b, b is 5. 5 should be squared. So when we factorize this or work out, we are going to have negative 2 multiplied by 20, that is going to be negative 40. Then negative 3 multiplied by 5, that will be negative 15. Then everything squared. Then minus 5 squared is 25. Then negative 40 minus 15, that should be negative 55. Is it? Yeah, so I think it's going to be, yes, that will be negative 55, but it's squared. Then 20 multiplied by 20, or 5 multiplied by 25. So 5 multiplied by 25, that is going to be 125. So we're going to say minus 125. Then now let's square negative 155. Oh, negative 55. So 55 by 55, that is negative 55 squared is going to give us positive 3025. 3025 subtract 125. So the final answer to this question is going to be 2,900. So I'm getting 2,900. So it means that when we evaluate this one in this operation, the answer that we are getting is 3,000 or 2,900. Okay, so this is what you are supposed to do when they say evaluate. Just prioritize where the brackets are. So let me try to say, what if this question was what if this question was like this? The same numbers, but let's say if it was 3 star open 2 star 5. Was the answer still going to be the same? I don't think so, because in this case you are first going to prioritize this. So you're going to say your A will be this, your B will be that. Then you go ahead and plug in where there's A, put 2, where there's B, you put 5. Then the result that you are going to get, let's say you are getting 3 as your final result from this operation. Then you come back here and say, there is already 3 here. So you are going to say 3 star what? This will be 3 star the result that you obtained. Let's say 3. Then you start all over again and say this is your new A, that is your new B. And go ahead, then you still substitute in that. So when you have more than 2 numbers, what you are supposed to do is prioritize where the brackets are. Start from there. The result that you are going to obtain, you come and substitute those brackets with that value. Then change the things. Start all over again and go like that. Sometimes it will just be direct. Let's say you have 5 star 3. If they ask you to say evaluate 5 star 3, you just go ahead and plug in this. That is, your A is going to be 5, your B is going to be 3. Then the value that you're going to find, that will be your final answer. It means you're dealing with associative. Then 5, they are saying find the values of k for which you have negative 2 star k is 80. Negative 2 star k is 80. We should find the value of k. So now remember, guys, that our operation is A star B. So in this case, we have negative 2 star k. It means that our A is negative 2, our B is k. So we are going to say our B is k. So let's go ahead and do that. So we have negative 2 star k. Then will be equal to, so where there is A, we'll put negative 2. Okay, we'll put negative 2, but again they are saying that negative 2 star k is 80. So this part is going to be replaced by 80. It's going to be replaced by 80. So we're going to say 80 should be equal to 2 multiplied by, so we have A, this is B. 2 multiplied by A is negative 2 minus 3 multiplied by B is k, everything squared, minus 5 multiplied by B, which is k, then also squared. So we have 80 will be equal to, open, that is going to be 2 multiplied by negative 2, that is negative 4. then negative 3k, everything squared, minus, this is going to be 5k squared, like this. So this, I think, is going to read that into quadratic. I'm not going to finish, you are going to finish. So 80 will be equal to this one here. It means that you have got two of those, so you are supposed to expand. That is going to be negative 4, open bracket, negative 4 minus 3k, open negative 3k, or open negative 4 minus 3k, like that. That's what squared mean. It means you have two of those. So when you expand, you're going to have this. So negative 4 by negative 4, that will be 16. This will be plus 12k, then plus another 12k, plus that will be 9k squared. So what do we have now? What we have, these alike terms can be added. So that is going to give us 16 plus, that will be 24k, then plus 9k squared. So that is what I'm going to put there. So this part now, we are saying that I will rearrange. I will start with 9k squared plus 24k, then plus 16. Then we are saying minus 5k squared. So you can rearrange and say 80 will be equal to, so this 9k and 5k are like terms. So 9k squared minus 5k squared, that is going to give us 4k squared. Then we don't have any other like terms. This will be 24k, then plus 16. So now this is going to be quadratic. Rearrange in that order. So let this 80 close the equal sign so that we can have a quadratic equation. So the final equation is going to be 4k squared plus 24k. Then we are going to have plus 16 minus 80 be equal to 0. So that is 4k squared plus 24k. Then what is 80 minus 16? So 80 minus 16, that is going to be, this will be 4, that will be 7 minus 1, 64. So it means we are getting what? We are getting negative 64 be equal to 0. So now you know that this is a quadratic, so you can solve now. Here what you are supposed to do, just find the product, sum and factor. Two numbers that when you multiply you can get negative 64. When you add, that is the sum, you should get 24. And when you okay, so product, sum, the factors. So two numbers that when you multiply you get negative 64, you add you get 24. When you find those numbers, then factorize this equation. So because it is quadratic, the values of k are going to be 2. So if you can't find the factor, let's say you don't have factor, then you are supposed to use the quadratic formula. You are still going to get the values of k. So that's how you can solve for k in that equation, guys. Okay, so go ahead and try to find that. Then the last part of the question is saying, for each x is a member of R, determine if it exists. So we are saying that for any member of this set, we should determine if x inverse exists on the set of real numbers with respect to our operation. So remember that we are saying x can be any number as long as that number is a member of what? Real number. So does this x inverse exist in this operation? So let's see. X inverse is the same as 1 over x. So now we are saying that x can be any number as long as that number is a member of what? Is a real number. So let's say x is equal to, let me say it's equal to 2. So that is going to be equal to 1 over 2. So 1 over 2 is a real number. Is part of the set. Is part of the real number. So we are going to say that it does exist. But what if we say x is 0? It means that this is going to be 1 over 0. So a number over 0 is undefined. This is not defined. This is undefined. So it means because of this, it means that this does not exist. Because of just 0, it does not exist. But if you pick any number apart from 0, it's going to exist. So let's say you pick negative 4. So that is going to be 1 over negative 4. So this is it. This is what is defined, and the negative 1 over 4 is part of what? The real number. So because of 0, it does not exist, because 0 is going to make this operation be undefined. So if we didn't have 0, the operation is going to be defined. So it does not exist because of that. So basically this is an introduction, or something that you have to know, which you need to know when dealing with binary operations. Now, with this concept that you have obtained from here, you can go ahead and look for questions under binary operation and try to answer if you can get the answers correct. So let's look at question 20. Now that you already have an idea about binary operation based on question 19, I expect you to answer this question. What has changed here is that the question is saying consider the binary operation that is star defined on the set of now its natural numbers. This one was on the set of real numbers. So with the operation that we have with star a star b equal to, this is the new operation. So you can see that this operation is different from this. Then where a and b are in natural number. So by considering star on this, answer questions 1 to 5, question 1 to 6 in question 19. So meaning that based on this question, you should answer all of these. Okay? You should answer all of these but using this operation. That's what it means. So now I expect you to try out this question. Just follow whatever we did on question 19 and see the solution that you're going to get. So here you should know the set that you are dealing with. So the set, we are saying that it's a set of natural numbers. So what are natural numbers? So natural numbers, these are positive integers. Positive integers starting from 1, and they have to be whole numbers. So 1, 2, 3, 4, and so on up to positive infinity. That's a set of natural numbers. So the set that you are dealing with in this case now is numbers starting from 1 all the way to positive infinity. Whereas previously this was from negative infinity all the way to positive infinity. So meaning that if you want to choose a number now, you'll be picking a number starting from positive 1 going to positive infinity. So what operation do we have here? Let me answer a few questions. So we are saying we have a star b equal to, the operation is saying 2 to the power of modulus of a plus b, then plus a minus b. Then the first question, as usual, is a star binary operation on R. So we said that for you to answer that question, you're going to say if this is binary and not on R. If this is binary on n, now we are dealing with natural numbers on n, then a, b should be members of n, and the result that we are going to get, a star b, should also be a member of n, like that. Then after this you are going to say, because you want to prove, so you are going to say let a be equal to, pick any number from the set. So the set, we are saying from 1 all the way to positive infinity. So you can pick any number which is a natural number from that set. So we're going to say a will be equal to, let's say, I like using small numbers, a will be that. Then let's say b equal to negative 1. Let me use negative 1, like this. Then now we'll go ahead. The number that we should find should also be a natural number. Okay. Then we have, let's say that operation, it means that now we're going to have 1 star negative 1, because we are we're following this operation. That will be equal to 2 to the power modulus of what is 1. What is a? A is 1, then plus, then b is negative 1, okay, modulus, then plus a is 1 minus b, which is negative 1. So that and that. Just substitute where there's b, you'll be putting Where there's b, you'll be putting -1. Where there's a, you put a. So this is going to be equal to 2 to the power. This is going to be 1 minus 1. So 1 minus 1, it's 0. Okay, modulus. Then this side we're going to have plus. This is going to give us 1 plus 1. So that is going to be 2. So this will be equal to any number raised to the modulus of 0 in the first place. Modulus of 0 is 0. So which means that this is going to be 2 to the power 0 plus 2. Any number raised to the power 0 is 1. So that will be 1 plus 2. So 1 plus 2, that is going to be 3. Is 3 a natural number? Yes, 3 is part of this set. So 3 is a natural number. So that will confirm. We are going to say that this is binary on that. But what if you use other different numbers? Let's say you use 3 and let's say you use 3 and 4. It means that we are going to have 3 star 4 will be equal to, this is going to be 2 modulus of a is 3, then plus that will be 4 modulus, then plus a is 3 minus 4. So this will be equal to 2 to the power 3 plus that is going to be 7 modulus, then plus, or this will be minus 3 minus 4, that is -1. So this will be -1. So this will be equal to 2 to the power 7. 2 to the power 7 minus 1. So if you say, if you multiply 2 7 times, you are going to get an integer. Then you subtract -1 from that integer, it will also be, or you're going to get a natural number. Okay, you're going to get a natural number. Then when you subtract -1 from that natural number, you still get a natural number. So my conclusion is going to be star is binary. Star is binary on the set of integers. So that is the conclusion that you're going to make using that operation. So you can see that you can answer any kind of a question now. Just follow this. So here what we're avoiding is you shouldn't get a final result as negative. Negative numbers are not natural numbers. So if you get a negative result, it means that the operation is not binary on that set. It's not binary on that set. Then you can also try commutative. So commutative, we said if it's commutative, A star B should be equal to B star A. Then now what we're going to do is A star B is already defined, which is here. So where there's A star B, you are going to have, you're going to say you have 2 to the power A plus B modulus, then plus A minus B, then should be equal to, now you just change 2, where there's A you put B, where there was B you put A, should be equal to that, then it will be plus, this is going to be B minus A. Then after this, now you're going to say let A be equal to pick any number as long as that number is a natural number. Then B will be equal to pick also another number, then substitute and compare if the two sides are going to be equal. So at least try to use 2 or 4 different numbers, 2 for A and 2 for B, then get to have same results. Then you're going to make a conclusion that it's commutative. Associative, just do what we did earlier for question 19. Do the same. Try it out, then you can share your solutions so that I can, if you are correct or not, I can comment. Then for this one, the same. So I want you also to try this one, find the value, evaluate using this one or this operation now. Then you should also find the value of k for this one. Then lastly, we are saying for x is a member of, now we are saying natural numbers. Determine if this exists, so that is 1 over x. So 1 over x, we are saying that it can be any number, so that is 1 over, pick any number from the natural numbers. Let's say you pick 5, so it means you have this over 5. So now here you can, one thing you're going to realize is that 0 is not part of the set, so you can't pick 0. Earlier we said that this one did not exist because 0 was inclusive there, so we had something like 1 over a number 1 over 0, which is undefined. So now 0 is not part of. So try to work out if you are still going to obtain a natural number. If you pick any number, put it at x, if you are still going to obtain what? A natural number. So yeah, you can share your findings on all of these. Where you have a question, you can feel free to comment, then we'll be able to guide. Then we're still dealing with binary operations. So we're on question 21. Consider the set G. So G has got members E, A, B, and C with operation this only, with operation that it is defined below. So we have this. This is more like a mathematical table, those ones which used to be behind the covers of the books. So we have an operation there, then we have that row, then we also have got this column. So here what it means is that if we say A star E, for instance, it means that the A that you are picking is this A, then star E is there. So the result is going to be where the two intersect. So they intersect there. It means that A star E will be equal to A, and A is part of this set. So if you'll be asked a question to say, does A star B exist on this set, on set G, you are going to say yes. So basically, don't be confused with these. So let's start. We are saying that question 1 is the operation star binary on G. So we said that if the operation, if star is binary, if star is binary on set G, then if you pick any member, let's say A and B, these should be members now of, we are dealing with set G, and their result, that is A star B, should also be a member on that set. That's what it means. Then now we are going to let. So we're going to say let. We can see that the members that we have are these. Okay? So we are going to pick a member, any member from this set. Let's just pick two members from that set. Anything. So let me say I pick B and B star, let's say E. So what is the result? B star E. So remember that the operation we are using is this one. So let's go ahead and check what B star E is equal to. So the B that we're going to pick is this one. Then star E. E is there. Where these two intersect, that is our result. So the result is this is going to be equal to, so the answer is B. Is B a member of G? Yes, you can say that B is a member of G. So this one has satisfied our first condition. Okay, then what of if we pick, let's say, A star C? So A star C is going to be equal to what? So go back where there's A. So A is here, then where is C? C is there. What is the final result? The answer is where the two intersect. So the answer is B. Is B a member of G? That is true. Yes, B is a member of G. So it means that it is a star is binary on set G. You can pick any two random letters. Let's say you pick E star E. What is going to be E star E? So E star E, you can see that it's going to be E here, then star, not that, E star E. So the answer is E. E is a member of set G. So that is also making our operation to be defined. So based on those, we are now going to say star is binary on G. Okay, star is binary on G because we have confirmed. So you can pick, let's say, star C star B. So C star C here, then star B there. The result is A. A is part of set G. So it means everything, any two elements that you can pick randomly in this set, the result that we're going to get it to be within this set. So it means that this is binary on that set. We move on to 2 is saying if the operation associated So associative we said A star B, then we have star C. We said this should be equal to A star open B star C. So now you can see that here we don't have a defined operation. Our operation is this one here. Okay, this is the operation that we are using. So the first one, let's say we have A star B. So A star B, you're going just to pick randomly 2 letters in this set. Okay, pick 2 elements in that set. So let's say we pick E star C. E star C. Then we also have star, another star C here. Then E star C, what is the result of E star C? So E here, star C. What is the result? So that is C. So it means that this is going to be C star C. So now that we have C star C, what is the result for C star C? So, okay. So the result for C star C is C star C, we have C here, star C there. So that is E. So this side we are getting E. What about this side? So let's keep A. So we're going to have A star. Then remember that we picked, we are not going to change. We'll still maintain this. So we're going to have E star C. So what comes first is E. So we are going to have E star C. If I want, we can work that one out. So E star C, we are saying E star C. What is the result? So E star C, the result is C. E star C, the result is C. So meaning that now this has been reduced to C. Then we have our new elements. So what is A star C? So we are here now. What is A star C? So now we have A. Where is A? A is here. Star C. C is there. What is the result? The result is B. So A star C, this side we are getting B. So you can see that this side we got E. This side we are getting B. The two sides are not equal. So now we are going to say A star B, then star C is not equal to A star open B star C. Therefore this operation is not associative. So the operation is not associative because the two sides are not being equal. That is how you can answer this question. Very easy and straightforward. Then the last one is saying evaluate the value of, so we should find the value. So we have open bracket A star B, then star C star A. We should find the value, and for each X is a member of G. So this is the condition. For each, you should get X should be a member of that operation there. X should be a member of our operation. I'll come back. This is a different question when we proceed from there. So let's answer this question. So I said that always when you see brackets, that's where you start from. So here we're going to answer this one alone. Then we keep the star. We'll also answer this one. So let's go ahead. What is A star B? So A star B, we have A here, star. Where is B? B is there. So the result is what? E. So meaning that A star B is giving us E. Then I'll bring down that star. Then we come here now. What is C star A? So C star A, we have C star A. C star A, the result is B. So C star A is B, is giving us B. So meaning that this is going to be E star B. Then now the question is evaluate. So now that this has been reduced to E and this one has been reduced to B, now let's find E star B. So E star B. E star B, the result is E star B, the result is B. So it means that this whole thing is just equal to B. So therefore you are going to say A star B star C star A is just equal to B, but you have to show all your working. This is what I was solving here, they have to be same. Okay, so this is the final result. That's the answer. Then you can see that B is a member of G. That's what this means. We are saying that X, that is the result that you are going to obtain, should be a member of G. Then determine if there exists, that is so this question, if you have observed, starting from question 19, each and every question has this one here. So determine if there exists X inverse in G with respect to the operation. So I said that X inverse is the same as, you're going to say this is 1 over X. So in the previous question, which was question 20, this question, to answer this part, which was saying for each what does determine if this exists, that is now on the set of natural numbers, because the question is 20, but we're answering using question 19. So that was supposed to be 1 over X. So I said that natural number that we have, natural numbers, it's 1, 2, you keep on going. In short, these are positive whole numbers, countable positive whole numbers starting from 1. So we're saying that X can be any member of the set. X can be any member of our set. In this case, our set is a set of integers. So if you pick any number, let's say you pick 8, it means that X is 8. In that case, you are going to have 1 over 8. Is 1 over 8 a natural number? So 1 over 8 is not a natural number. This is what? This is a rational number. So some rational number. So for the fact that 1 and 8 do not have a common factor, this is a rational number, and a rational number of this kind is not equal to a natural number. It's not a natural number. Okay, so this is not a natural number, meaning that it's not part of the set. So we're going to say that this does not exist on the set of natural numbers. Okay, you can pick another number. Let's say you pick you're going to have 1 over 5. This also is a rational number. It does not exist. But you can also have a rational number which is 1. Let's say you pick 1. It will be 1 over 1. 1 over 1, this is going to be a natural number. This is going to be a natural number because it can be reduced to 1. But in this form, it is a rational number. So a rational number at the same time, it is also a natural number because it can be reduced. But not all rational numbers are natural numbers. Okay? So for the fact that we have some which are not natural numbers, it means that it does not exist. 1 over X does not exist on the set of natural numbers. So now our question or our attention is here. So we have to determine if this does exist on set G. So what it means here is that we are saying that X can be any member of set G. So just let X be any member of that set. So this is going to be equal to, let's say randomly I pick E. So we're going to have 1 over E. Do we have 1 over E in set G? So we don't have 1 over E in set G. It means that this does not exist on set G. It does not exist on set G. You can pick, let's say 1 over C. 1 over C also does not exist in set G. So therefore, X inverse does not exist. Does not exist on set G. In set G. That is the conclusion that we are going to make. Because initially what we are supposed to be getting, if we say 1 over any of these, let's say 1 over A, we are supposed to be getting, let's say we are supposed to be getting also a member on that set. So we are supposed to have 1 over A, or 1 over E, 1 over C, 1 over D, things like that. But we don't have, so they are not members of G. So for the fact that they are not members of G, it means that it does not exist. So this is how you answer binary operation involving questions.